Welcome to the AWS Certified Security Specialty training course. This course is organized into 4 main sections. In Chapter 1, the AWS Certification Exam and Preparation, and in this section you will receive an overview of the AWS Certification Exam and explore various study methods. The Chapter 2, Introduction to each service, that we cover all the services featured in the exam, providing a thorough introduction to each service. And I have prepared the practice question in Chapter 3. In the final chapter, the summary, I'm going to introduce additional learning resources and the service resources to help your study. So let's start from Chapter 1. In this section, I'm going to introduce an overview of AWS, the details of the certification exam, and how to set up the AWS account. So first off, let's talk about what AWS is all about. AWS, or Amazon Web Service, was founded in 2006 and has grown to become the leading cloud platform. It began its journey as a service with Amazon.com and gradually expanded to offer services like the virtual servers and the storage, known as infrastructure as a service. Today, they now offer over 240 services and continue to grow their market share. The AWS offers its services globally. As long as you have an internet connection, you can access their services. Their services are available in more than 240 countries and territories, with 36 regions and over 100 availability zones. And this is cloud market share. Over the past few years, AWS has held about a third of the global cloud market share, followed by the Azure and the Google Cloud. Since its foundation, the AWS keeps top share. The AWS certification is highly recognized and is one of the most popular in the IT world. And this is a comparison between the cloud and on-premise solutions. One of the main benefits of the cloud service is how easy it is to deploy the resources over the internet. In addition, you only pay for what you use, which usually means lower cost. But moving to the cloud is not just about the saving money. The standardizing the infrastructure can also make the management easier. Let me give you a quick overview how AWS started. In the early days, the AWS grew alongside Amazon.com business. The demand in an e-commerce changes with seasons, like during the Christmas and Black Friday, when lots of products are bought and Amazon's system gets busy. To make better use of their resources, Amazon decided to rent out the extra server capacity to other companies during the off-peak times. The AWS officially launched in 2006. The same year, they introduced the S3, an object storage service, and the EC2, a virtual server service. Now, AWS offers over 240 different services. And lastly, for your reference, I'd like to introduce the comparison chart for the 3 major cloud providers given by Google Cloud. All these cloud providers offer similar services. If you've had experience with the Google Cloud or Azure, this comparison helps you to understand the AWS better. And for those looking to study not only AWS but also other cloud services, this document can be quite handy. Next, I will introduce the learning path. In this section, I will explain learning methods for different certification levels. The AWS offers certification exam at 3 levels: foundational, associate, and professional. The foundational level is designed for beginners just starting to learn AWS. The associate level is for those with about 1 year of practical experience, and the professional level is for those with 2 or more years of experience. And if you are a beginner preparing for the foundational exam, we recommend starting with the video content that provides an overview of the AWS services. The official AWS document can be overwhelming because it has a lot of information which might be too difficult for beginners. To grasp the basics, we suggest using the packaged video content from the platform like Udemy to get an overall picture. And if you already have the practical experience and are already familiar with the AWS, we recommend focusing on the complementing your existing knowledge. Generally, the video contents contain more information than text data. It is said that the 1 minute of video content is equivalent to over 30 books in terms of the information volumes. However, this comparison is about the amount of information, not the knowledge you can get. Watching a 1 minute video doesn't provide the same depth of the knowledge as reading 30 books. The video learning style is typically a passive learning style, while document-based learning style is more active. For more advanced learner, in particular, document-based learning tends to be more efficient. As you progress in your AWS journey, adapt your learning style to match your growing expertise and increasing the complexity of the material. When it comes to studying, there is no one-size-fits-all approach to the studying. The learning style is different by person, and the time needed to pass the exam is also different by person. Easy and hard are subject and are not universal truths. In addition, the Rome was not built in a day. The engineering skills are built over time. The IT world is rapidly evolving, so there is no end to learning. Make the most of any free time and find a sustainable way to keep learning. Earlier I told you that the way of studying is differ from person to person. In this course, I'll be breaking down the AWS services by category and after that providing the practice questions. And whether you want to dive into the lecture first or tackle the question is totally up to you. And this course also includes some hands-on exercise. I'll guide you through the steps using the management console. Next, I'm going to introduce overview of the exam. And here is the overview of the AWS certification exam. As previously mentioned, the exams are offered at 3 levels, the foundational, associate, and professional. And currently, there are no prerequisites for taking these exams, which means you can take them at any time based on your experience. For example, you can take a professional level exam without holding an associate certification. In addition, AWS also offers a specialized certification in advanced networking, machine learning, and security. As there were major changes made to the lineup to 2024, the database and the data analytics exams were discontinued, and a new data engineer associate certification was added, and furthermore, AI practitioner and machine learning engineer associate were added. It is expected that AWS will continue to add or discontinue the certification to align with the industry trend. Next, let's look at the lineup of AWS specialty certifications. As of August 2024, there are the 3 specialty certifications available, which includes the advanced networking, the machine learning, and security. Each certification focuses on the highly specialized AWS services and the concept. The security specialty, which is the focus of this course, is a prominent certification in the information security field. You can also find many preparation courses for it on the platform like Udemy. Now for context, let's briefly touch upon the other well-known information security certifications. And globally, CISSP, the CISSP, is a highly recognized industry certification. It's known for being quite challenging, and they often require specific training or professional experience besides passing the exam. In the private sector, the vendor-specific certification like those from AWS itself, as well as from the companies like Cisco Systems and Microsoft are very common. The AWS Certified Security Specialty is generally considered to be the challenging certification compared to others as well. The earning it can definitely be a significant advantage for your career advancement or when seeking a new job opportunity, particularly within the rapidly growing cloud industry. At all levels, the exam consists of either the multiple choice or multiple response questions, whether you will choose the correct answer from options A, B, C, and D. The specialty exam has the duration of 180 minutes and consists of 65 questions. The exam fee is $300 as of now. Since the exam is lengthy, it's very challenging to keep concentrations. Before taking the exam, I highly recommend that you practice by timing yourself and getting accustomed to the exam session. According to the exam guide, the target candidate should have more than 3 years of experience in security and 2 years of hands-on experience with AWS services. While you don't actually need to have the years of experience, but I highly recommend that you study thoroughly because the exam is challenging. The exam consists of 65 questions, but only 50 of the questions will impact your score. In other words, 15 questions will not affect your score. These 15 questions are used by AWS for research purposes. Therefore, you may encounter questions about the services which do not appear in the exam guide. The passing score is 750 out of 1,000. Next, let's talk about the exam domains. The exam questions are distributed across these domains according to the weighting shown in this table. In this course, we will follow the original exam guide to introduce the relevant AWS services and the features for each domain. Based on the exam guide, here is a rough overview of the services we'll cover for each domain. For the threat detection and incident response, we will cover the threat detection services like GuardDuty, Amazon Detective, and Security Hub, as well as the services relevant to the incident response, such as the System Manager. For security logging and monitoring, we will discuss monitoring and logging tools including the CloudWatch, the Config, and the CloudTrail. In the infrastructure security domains, we will look at the network services like VPC, the related firewall capability, along with the compute services like EC2. And for identity and access management, we will cover IAM, the directory service, and the Cognito. In the data protection service, we will discuss the data storage services such as the S3 and RDS, and the encryption services like KMS. And finally, under the management and security governance, we will introduce AWS Organizations and related services. And finally, here is the sample questions. The exam format typically involves the selecting the correct answer from the multiple choice options. You may need to choose one correct answer or sometimes the multiple correct answer. Naturally, the question requiring the multiple selection tends to be more challenging. About 30% of the question on some exam might be on the multiple choice, the multiple answer type. And we have practice questions like this prepared for you in the chapter 3. Next, I will introduce how to create an AWS account. I'm sure those of you who are aiming for the specialty exam already have an account, but I'm putting it up just in the case. And first, I will introduce the tools for developed and managing in AWS. The Management Console, or simply the console, is a tool that allows you to manipulate graphically via a web browser. It is the first page you access after creating an account, from which you can access various services. The CLI or command line interface is a tool to control services via the command line. You can access the AWS environment using the access key and the secret key. And there is also the CloudTrail, which allows you to access the console once and control the CLI from your browser. You can manipulate the CLI without any setup. And SDK, the Software Development Kit, is a tool for developing the various AWS services. It provides the language-specific APIs for each service, such as Python and Go. And you can access the AWS with an access key and a secret key. And this is a step to create a root account and IAM user. And first, create a new AWS account and then set up IAM user. The IAM is a service that manages the permission of the users in AWS. I will explain it again in the next chapter. First, search AWS in your browser and go to the AWS web page. And you will see the button in the upper right corner that says Sign into the console, and click it. And if you already have an account, you can sign in from this page. To create a new account, click Create a new AWS account. Enter your email address to authenticate your email, and the verification email will then be sent to that email address. Next, enter your personal information such as your address, the credit card, and the phone number. A credit card or debit card is required for your billing, even if your billing is 0. And if you are not belong to the corporation and use AWS for personal development or just learning, I recommend you to choose the basic plan, which is free of charge plan. For developer plan and business plan, you can get support from AWS customer engineers. And once you have completed this process, the AWS account will be created successfully. And this is the page called the Management Console, and this will be the main page when you use the AWS resources from now on. Now, I'm gonna configure IAM. The first account that's created is called the root user, and it will be a powerful account like an administrator with access to your credit card. If the account is compromised, there is a security risk. Therefore, AWS recommends that you create an IAM user and sign in as an IAM user instead of using the root user. And first, type IAM in the search window above and move to the IAM dashboard. And this is the IAM dashboard. In the initial state, the root user has MFA, is marked with the red triangle. It is recommended that you install the token apps on your smart devices. And next time you sign in as a root user, authenticate with MFA. And next, create an IAM user. The next time you sign in as usual, sign in as IAM user. You should not sign in as a root user except when checking your credit account. Now click on the user in the left menu bar, then Add User. And set the username first, and check the access key and the password field for the credential types. The access key is used for the API, CLI, and SDK, and the password is used to sign in the management console. Select the Attach Existing Policy directory and choose the Administrator access. And this will give you the IAM user the privilege to accept the credit card access. And tags can be any text you like. The tags allow identification of IAM user. If you create multiple users in the future, you may set tags to identify each user. And after successfully creating a user, and be sure to save the access key and the password that displayed. You can also download this in CSV format. And when you have done setup IAM, you will return to the console again, and I will briefly introduce to the structure of the screen. From the menu bar above, you can move to various management screens, and you can return to the top page by clicking the AWS logo on your left. And click on the Services to see all the services offered by AWS by category. And you can also register frequently used services as favorite. And click on the CLI logos to open the Cloud Shell. And by doing so, you can manage the command line from within your browser as well. Click on the bell mark to view various notifications, and you can find out about the event, changes, and the incident for the services you are operating. And click on the question logo to get support. The type of support available depends on the plans. For example, the basic plans allow the ticket-based question about the fees, while technical support is available with paid plans. By clicking on the gear-shaped logo, you can edit the language, the visual mode, and so on. And this is a recently added feature. The menu bar configuration may change in the future. And next click on the bring down where the region name is listed to navigate to AWS region. The Northern Virginia is selected by default. And basically, by selecting the region that is close to where you want to deploy your services, and you can access your resources with low latency. And also, the services deployed and the fees vary slightly by region. Since the AWS is a US company, so release generally the earliest in the US region, and then after rolled out to other regions. A document and the other information is available in English for the latest services, and is gradually being translated into other languages. And finally, you can check account information you have created from the upper right corner of the console screen. And clicking on the organization will take you to the AWS Organization service page, where you can view the information about the organization you belong to. And from here, you can also check your service quotas and usage status and so on. And if you need to access credit information, you will need to sign out of your IAM user and sign in as a root user. So let's start Chapter 2, Introduction to each service. In this chapter, we will introduce security-related services and features for each service category. The content align with the exam guideline, but I will add supplementary explanation as needed. And before we dive into specific services, let's cover some fundamental knowledge and frameworks in general information security. The information security is essentially about protecting the safety of the information, and this includes safeguarding the corporate secrets, the personal data, and the information systems that handle this data. The information security is often defined by three core elements as outlined in the standards like ISO 27002, the confidentiality, integrity, and availability, and which commonly known as the CIA triad. The confidentiality means ensuring the information is accessible only to those with authorized rights. Integrity means maintaining the completeness and accuracy of information, ensuring it hasn't been corrupted or improperly modified. The availability means ensuring the information and the systems are accessible and usable when needed by authorized users. And it's worth noting that AWS itself holds the ISO 27001 certification and actively supports the customer in building and operating the system on AWS that meets the ISO 27001 requirement. Next, let's discuss the risks in the information security. The information security risk typically involves the two key elements, the threats and the vulnerability. The threats is any potential cause of an unwanted incident which may result in the harm to systems or information assets, such as the theft or unauthorized use of data. The threats can often be categorized as the intentional, the accidental, or the environmental. And the vulnerability refers to a weakness or gap in security safeguards or control that could potentially be exploited by the threat. The vulnerability can exist in the software and in documentation or organization process, or even in the physical aspects like a location being prone to disasters. The information security countermeasure can be viewed from the several perspectives, such as the infrastructure, the authentication, and the data protection as outlined. The common example includes the keeping the software up to date through regular patching, the implementing the security control like a firewall, the IDS and IPS, and the antivirus software, and deploying the SIEM systems for the centralized logging and analysis. And from the authentication standpoint, this involves setting the appropriate user IDs and a strong password, and potentially implementing the more advanced authentication systems using the methods like the client certificate, the device authentication, or biometrics. For the data protections, the measures include applying the principle of the least privilege when configuring the data sharing, encrypting the sensitive data both at rest and in transit, and potentially entrusting the data storage to reliable cloud providers. As a cloud provider, the AWS offers numerous services designed to help customers to secure their information assets, operating under the shared responsibility model. There are several common information security frameworks that provide a structured approach to managing these security aspects. The prominent examples include the ISMS standard from the ISO, such as the ISO 27001, the CIS control, and the NIST Cyber Security Framework. The NIST Cyber Security Framework, CSF, published by the U.S. National Institute of the Standards and Technology, NIST is the widely adopted standard for managing the cybersecurity risks. It organizes the cybersecurity activity into 5 core functions: the identify, the protect, detect, respond, and recover. And these functions are further broken down into the specific category and subcategories, providing the common language and the structure for managing the risks. The AWS provides the services and the resources that support the alignment with the NIST CSF. And finally, the CIS benchmarks are the best practice guideline for securely configuring the IT system and software created by the non-profit organization CIS. There are the specific CIS benchmark for AWS services that provide a detailed security guideline. And you can find these benchmarks and tools to check the compliance in places like the AWS Marketplace. that covers the basic security concepts and the frameworks we want to introduce. While this background information might not be direct exam questions, it is useful for understanding the cloud security well. So we will refer back to these ideas as needed later in the course when we talk about the specific AWS services. So let's now discuss the threat detection and incident response. In this chapter, we will introduce the threat detection services like Amazon Macie, the GuardDuty, Security Hub, and Amazon Detective. And we will cover the services like AWS Config and IAM Access Analyzer, which also play a role in the threat detection in later chapters. And for incident response, we will cover the Systems Manager, Lambda, and EventBridge. In the area of information security, there are two fundamental concepts, the prevention and the detections. The prevention is the process aimed at stopping the security incident before they can happen. And the detection, on the other hand, is a process for discovering the incident after they have happened. In other words, the prevention is the proactive approach, while detection is a reactive approach. Now let's briefly map some AWS services to core function in security framework that identify, protect, detect, respond, and recover. For the identify function, the services like the AWS Organizations SCP, the System Manager, and AWS Config can help establish and monitor your environment posture. And for protect, we have services such as the AWS Shield for DDoS protection and various firewall services. For detect, the monitoring services like the CloudWatch and the CloudTrail are crucial, along with the specialized detection services like Amazon Detective, Amazon Inspector, Amazon Macie, and Amazon GuardDuty. And for respond and recover, the Lambda, the CloudFormation, and the System Manager can be used to take action. So let's start with Amazon Macie. The Amazon Macie is a data security service that uses machine learning and pattern matching to discover, classify, and help protect sensitive data stored in S3. It is a free managed service, and you can easily get started by enabling it from the console. Once the Macie is enabled, it typically analyzes your S3 inventory and provides the initial statistics and insight about your S3 security posture within about 48 hours. The analysis result includes the findings about the potential presence and the location of sensitive data, as well as the assessment based on the security policies like the public accessibility and the encryption status. For example, it highlights the findings based on the severity, such as the discovery of the credit card number or the personal health information, PHI. You can also customize how you are notified based on the types of the severity of the data detected. Our core function of Amazon Macie is the sensitive data discovery. It uses the machine learning and pattern matching techniques to detect and classify sensitive data within your S3 object. The Macie uses the data identifier to detect the sensitive data patterns. There are two types of the types, the managed data identifier and the custom data identifier. The managed data identifier are predefined patterns provided by AWS, covering the many common sensitive data types like the credential, the financial information, the PII, and the PHI. And as of now, there are over 100 managed data identifiers available, and the list is regularly updated. The customer data identifier allows you to define the patterns for the sensitive data specific to your use case. For example, you could define a custom identifier for internal employee ID. And these custom identifiers are typically defined using the regular expressions. The Amazon Macie uses these identifiers to classify and detect sensitive data according to your specification. In addition to sensitive data discovery, the Amazon Macie also helps assess your S3 security posture. It identifies S3 packets that are publicly accessible, unencrypted, or shared with accounts outside your organizations. It helps pinpoint potential security risks by discovering the packets that might be unintentionally exposed or lack encryption. While enabling the Macie provides an automated discovery insight, you can also run targeted sensitive data discovery jobs for deeper or more specific scans. And this job allows you to precisely control the scope, timing, and the specifiers of the data detection process. And first you define the scope, which specifies which S3 packet or even specific object prefixes to include in the scan. The scopes can be finely filtered using the criteria like a bucket or object names, tags, the prefixes, the last modified date, the file extension, or object size. And next, you can define the schedule for running the job. The jobs can be configured to run one time or on a schedule such as the daily, weekly, or monthly, and you can also specify the job's start time. You also define what sensitive data to look for. This involves selecting which managed data identifier and/or custom data identifier the job should use. The filtering to only the necessary identifier that helps reduce the potential false positive and the scan cost. And policy checks can also be part of the job's findings. The Macie presents its findings in the dashboard in the management console. The findings provide details such as the affected S3 packet or object, the data identifier, the severity level, the high, medium, low, and the time of the discovery, the occurrence count, the relevant policy, the account ID, and the region. For example, if credit card number are found in S3 packet, Macie might generate a finding with the critical or high severity. You can then configure subsequent actions based on these findings, particularly the severity. For instance, the finding with the critical or high severity can be integrated with the services like a Security Hub or EventBridge to automatically send a notification to administrator or trigger the remediation workflow. You can also download the findings report in formats like a CSV or JSON. And finally, you can automate notification and necessary action based on the Macie findings. By integrating the Macie findings with other services, you can automate the subsequent response. The primary integration point for Macie findings is EventBridge. The Macie automatically publishes all findings as events to the default event path in the EventBridge. And from the EventBridge, you can trigger the various targets. The common use case is sending the finding details to a SNS topic, which can then notify subscribed endpoints like an email address or chat tools. And this allows security teams to quickly become aware of the critical issues. And you can also use Lambda function as targets in the EventBridge to define automated remediation or custom response actions. For example, if Macie generates a finding indicating the policy violation, a Lambda function could be triggered to automatically enable the settings on the S3 packet. And furthermore, Macie can be configured to automatically send its findings to Security Hub. The Security Hub provides a unified view by aggregating the findings from multiple security services, including the Macie, GuardDuty, Amazon Inspector, and so on. The Security Hub itself can also trigger EventBridge rules based on all these aggregated findings, allowing for the centralized response workflow. We will discuss Security Hub in more detail in later chapter. So let's briefly touch upon the types of sensitive data Macie can detect and its relevance to major compliance and standard and regulations. As we've discussed, the Macie helps you address the compliance requirements by detecting the various types of sensitive data, such as PII and PHI. However, it's important to understand the key point. While Macie detects the sensitive data, Macie itself doesn't guarantee your compliance. It identifies where potentially regulated data resides. For example, you still need to use other services and implement appropriate control to actually encrypt this sensitive data, ensure least privilege access to it, and meet all the specific requirements mandated by the relevant compliance standard. So let's take a PCI DSS as an example. The PCI DSS is a security standard designed to protect the credit card holder data and the sensitive authentication data. Again, while Amazon Macie can detect the credit card information with your S3 packet, properly protecting that detected data requires adhering to specific technical and operational requirements outlined by the PCI DSS standard. These requirements typically include the control like network protection, implementing the strong access control, and employing the strong cryptography. The AWS provides a wide range of services and features designed to help you implement these types of the control and meet such a compliance requirement. Throughout this course, we will introduce specific AWS services relevant to protecting the sensitive data according to the various security best practice and compliance need. The next is Amazon GuardDuty. The Amazon GuardDuty is an intelligent threat detection service that helps protect your AWS account, the workload, and the data stored in S3. It uses machine learning, anomaly detection, and integrated threat intelligence to continuously monitor for malicious activity and unauthorized behavior. It is a free managed and agentless service, so you don't need to deploy or manage the agent. You simply enable it, and it automatically starts analyzing data source. For example, while Amazon Inspector has agent-based options, the GuardDuty primarily operates without needing agent deployed on your resources. The GuardDuty analyzes logs from the sources like CloudTrail, the VPC Flow Logs, and the DNS logs. It identifies an anomaly by detecting activities that deviate from the baseline. And in recent years, the GuardDuty has expanded its protection scope. Specifically, it now offers the threat detection capability for additional services including the EKS, RDS, Lambda, and the EBS volume. We introduced the GuardDuty as the threat intelligence service. The term information and intelligence are often compared and representing the different stage in processing data. Information generally refers to the unprocessed data. The focus is primarily on facts like what happened, where, and when. The example includes the facts like the access attempts to the server increased since yesterday, or information about the specific software vulnerability was publicly disclosed. The intelligence, on the other hand, refers to the insight derived from the information for a specific purpose. It aims to answer questions beyond just the facts such as why did this happen, what does it signify, what might happen next, and what action should be taken. The GuardDuty collects information like a network traffic log and API call log analyzing the data, and provides actionable intelligence in the form of the prioritized threat findings. The GuardDuty primarily analyzes the three main data sources: the CloudTrail event log, the VPC Flow Logs, and the DNS query logs. The GuardDuty continuously processes these logs over time to learn the normal behavior, establishing the baseline for your environment. It then detects the anomalous activity that deviate from the baseline. For example, it might detect the access attempts from unusual geographic locations or abnormally high volume of the API call from a user. And furthermore, the GuardDuty continuously utilizes the threat intelligence feeds both from the AWS itself and from the third-party security partners like the Proofpoint and the CrowdStrike. And these feeds provide the GuardDuty with updated list of the known malicious IP addresses and domains, which it uses to identify the communication with known bad actors. So let's illustrate how GuardDuty works with the specific examples such as the detecting the cryptocurrency mining on the compromised instance. And first, an attacker gets the unauthorized access to an EC2 instances within your VPC. The GuardDuty might detect the initial compromise itself. For example, it can detect the potential SSH brute force attacks, the port scanning, or the communication indicative of the backdoor malware. The attacker then typically downloads and executes cryptocurrency mining software like the XMRig on the compromised EC2 instance. The software attempts to connect to the cryptocurrency mining pool to start its mining operation. Because GuardDuty is enabled, it's continuously analyzing the VPC Flow Logs and the DNS logs from the EC2 instance. The GuardDuty also maintains a list of the IP address and the domain names associated with the known cryptocurrency mining pools. When the EC2 instance attempts to communicate with these known malicious IPs or domain with the mining pools, the GuardDuty detects this communication, and the GuardDuty then generates the finding detailing the threat type, the time of the occurrence, and the severity level, the affected resources, and the associated malicious IP addresses and domains. So next, let's discuss some protection capability enhanced since around 2020. The GuardDuty initially focused on the threats related to EC2 IAM and S3, but its scope has expanded significantly. The EKS protection provides the threat detection for EKS cluster. It monitors for threats unique to the Kubernetes environment by analyzing the EKS control plane. It can detect suspicious API calls, the potential privilege escalation, and the connections from the known malicious IPs to the API server. The S3 protection detects the potential security risks and the malicious activity targeting your S3 packet. It analyzes the CloudTrail S3 data events like a get object, the put object, and the delete object to identify the suspicious data access patterns or API call indicating the misconfigurations. And the runtime monitoring detects the threats occurring within your EC2 instance and the container workload. It provides the deeper visibility by monitoring the detailed host-level activities like the file access, the process execution, and the network connections, and often utilizing the lightweight optional GuardDuty security agent. Continuing with the expanded protections. When GuardDuty detects a potential threat on EC2 instance or container workloads that suggests the malware might be present, the malware protection feature can automatically initiate the agentless scan, and it takes a snapshot of the relevant EBS volume and scan it for malware without requiring any software agent on the instance itself. And RDS protection focuses on detecting the potentially compromised login activity against your RDS database. It uses machine learning model trained on the RDS login events to identify the anomalous login attempts that deviate from the established patterns. And the Lambda protection analyzes the network activity logs to detect the potential threat involving your Lambda functions, such as the functions communicating with non-malicious IP addresses or performing the cryptocurrency mining. The GuardDuty's findings contain the detailed information about the threat to help with the investigation and the response. The finding type uniquely identifies the kind of threat, structured by category, resource type, and the specific threat. The severity level, the high, the medium, or low, based on the internal score from 0.1 to 8.9, that indicates the potential impact and helps to prioritize your response. The high severity findings typically require immediate attention. The other details include the affected resources, the action involved, the timestamp, the relevant account information. You need to review these findings and take appropriate action based on your investigation. And similar to Macie, when GuardDuty detects a threat, it sends the findings to EventBridge, and you can set up the EventBridge rules to filter these findings based on the severity, the resource type or finding type, and define action for the matching event. For example, you could configure a rule to only send a notification for high severity findings. And the security administrator analyzes the findings and, if necessary, use services like Lambda or Systems Manager to implement the remediation steps triggered automatically by EventBridge. So now let's talk about the digital forensic. The digital forensics is the process of collecting, preserving, and analyzing the electronic data from the digital devices. And this data is used as the evidence for legal reasons or finds the cause and understands the impact of the security incident. Through this process, you can investigate what happened during the incident, identify how the attack occurred, and work to prevent it from happening again. The NIST cybersecurity incident response lifecycle defines the typical phases from incident detection to the post-incident activities. So let's think about the incident in the AWS cloud using the typical forensic workflow. For example, here are some steps if you suspect an EC2 instance has been compromised. The first is the preparation. Before any incident, this involves the setting up the security tools, preparing the monitoring dashboard, and having an incident response team or plan ready. Next is the detection and analysis. You detect unusual activity using the services like GuardDuty, Security Hub, or CloudWatch alarms. You then analyze the various logs for more detail to understand what happened. And if an incident is confirmed, the next step is the containment. You need to isolate the affected EC2 instance to stop the problem from spreading. For example, you can modify its security groups to control network traffic. And it's important to remember that terminating the instance at this stage would cause data loss. Generally, you should not delete logs for investigation. After containment, preserve the evidence by taking an EBS snapshot. You might also correct the memory dump. After analyzing the evidence and removing the threat, restore the system, perhaps by launching the new clean instances from the backup. And finally, post-incident activity, and this involves reviewing the incident. Did monitoring and alerts work correctly? What was the root cause? You then use this information to improve the security settings and prevent the future incident. Understanding the forensic investigation flow can also be relevant for the certification exam, so please review these steps. The next is Amazon Inspector. The Amazon Inspector is a security service that automates the vulnerability management and detects the unintended network exposure for workloads running in your AWS environment. It scans for things like a known software vulnerability based on the CVEs, the check configuration against the CIS benchmarks, and can perform the code level scans. It continuously scans EC2 instances, container image in ECR, and Lambda function to identify software vulnerabilities and the potential network configuration issues. The Amazon Inspector offers the different types of the scans, including the automated vulnerability scans and the CIS scans. The automated vulnerability scan is core feature. It discovers software vulnerability in OS packages and language library like the Python or Java package, and checks for the network exposure for reachability issues. And this applies to EC2 instance, the container image in ECR, and the Lambda functions. The CIS scan assesses whether the operation system configuration on your EC2 instances comply with the security best practice defined in the CIS benchmark. And this helps identify the OS misconfiguration or the insecure settings. And it supports various operating systems, including the common Linux distributions like the Amazon Linux, the Ubuntu, Red Hat, and Windows Server. The CVSS is an industry standard framework for rating the technical severity for information system vulnerabilities and expressing it as a numerical score. It is maintained and managed by the organizations. The CVSS provides a common scoring standard across the industry, and this score helps the organization to prioritize their response to discover the vulnerabilities. The scoring criteria includes the base, the temporal, and the environmental metrics, and the score is calculated based on the values against these different metrics. Based on the base metrics, a CVSS base score ranging from the 0.0 to 10.0 is calculated. A higher score indicates a potentially higher severity for the vulnerability. NVD, the National Vulnerability Database, a U.S. government repository of the vulnerability data maintained by NIST, provides the standardized CVSS base scores and the severity level like low, medium, high, critical for most registered CVEs. The Amazon Inspector identifies the CVE numbers for the vulnerabilities found on the resources like EC2 instance, the references the NVD, and then displays the corresponding CVSS base score and the severity level for you. The next, the CIS benchmark collection of the best practice guideline for security configuration, IT system, software, and networks. And they are developed and published by the non-profit CIS, the Center for the Internet Security. They provide a secure configuration standards, often with the step-by-step procedure for various IT systems and software. The CIS was founded by various organizations including the US government agency and universities. The AWS services like Amazon Inspector and the Security Hub use specific CIS benchmark tailored for the AWS environment to automatically check the security configuration. In the past, with Amazon Inspector Classic, you would create an assessment template to configure the assessment target and the rule packages. The assessment target refers to the AWS resources that the Inspector Classic would evaluate. An assessment target could include all EC2 instances in target region, or it could be managed by specifying the tags. A rule package was predefined collection of the assessment checks, and we will introduce these on the next slide. The assessment schedule defines the frequency of duration of the assessment run. The rule packages include checks for the network reachability and host assessment which checked for the vulnerability on EC2 instances. The network reachability assessment evaluates your network configuration to assess the network reachability of your target resources. The host assessment rules packages checked for the vulnerability within your EC2 instances. To run the host assessment rule packages, it was necessary to install the Amazon Inspector agent on your instances. With these host-based rule packages, the agent sent data from the instances to Amazon Inspector, where it was evaluated against the selected rule package. The rules being evaluated are listed in the table here. These include the common assessment items like the CIS benchmarks and the CVEs, as well as the security best practice provided by AWS. So let's summarize the key point about how the current version of Amazon Inspector scans the EC2 instances. As for software vulnerability scanning, the inspector detects the CVEs in OS packages and the language packages on your instance. It utilizes the System Manager agent to collect the software inventory information for analysis. The scanning is continuous, meaning the instances are automatically re-evaluated when changes occur or when new vulnerabilities are published. As for the networking reachability analysis, the inspector assesses if your instances are potentially reachable from the unintended network based on your VPC network configuration like security groups. And this analysis is agentless and run continuously. And CIS benchmark scanning assesses if the OS configuration complies with the specific CIS benchmark. And this can also leverage the SSM agent and the SSM association feature to run checks on the instance. Next, let's look at the vulnerability assessment for ECR. The Amazon Inspector detects known software vulnerability in OS package and the language package within the container image stored in ECR. The known agent needs to be installed inside the container image. The inspector integrates directly with ECR to analyze the image layers. When enabled in your ECR repository settings using the enhanced scanning, the scans can be triggered automatically when the new image is pushed, and existing images are monitored continuously. And this helps find the vulnerability early in your CI/CD pipeline. The scanning for the Lambda functions. Amazon Inspector detects known software vulnerability in the application called dependency used by your Lambda functions. And this scanning is agentless. The initial scan runs automatically when a Lambda function is deployed or updated. and the deployed functions are monitored continuously and reassessed if new vulnerabilities are published. The scanning includes checks for dependency and also security issues within your own function code. And finally, by integrating the detection tool Amazon Inspector with the services like the System Manager and Lambda, you can automate the process from the vulnerability detection to response. For example, you combine the Amazon Inspector with the System Manager allows you to automate the workflow from detecting the vulnerability on an EC2 instances to applying the necessary patch. And you ensure the SSM agent is installed on the target instances. When Inspector detects a vulnerability finding, and this finding can trigger a Lambda function. The Lambda function can then use the run command to execute the remediation script or patching command on the affected instance. The next is AWS Security Hub. The Security Hub is a central service designed to give you a comprehensive view of your security status across your entire AWS environment. It helps you manage and check your security posture. It gathers security findings from the various AWS security services and also from the supported third-party security product. Additionally, it helps you continuously monitor your security posture by running the automated check based on the AWS security best practice and the industry standard. And the Security Hub can be used across multiple regions and multiple accounts often integrated with the AWS Organizations. And therefore, it's commonly used in larger environments to centralize security findings. The Security Hub integrates with the multiple services. It helps make the security management more efficient by handling the findings in the common format. The ASFF, the AWS Security Finding Format, is the standard JSON format that Security Hub uses. And this allows it to receive the findings from the different sources and process them consistently. And here is a list of the AWS services that integrate with the Security Hub. And besides the AWS services, you can also bring the findings generated by the third-party security product into Security Hub if they use the ASFF format. And this is a simple example of the ASFF format. The ASFF includes the information such as the identifier, the time the finding was generated, the severity level, a description of the security issue, details about the affected resources, and the finding status with the Security Hub. In reality, the finding might involve the multiple resources or state, so the actual ASFF can be much longer. The ASFF standardizes the security information across the different services, making it easier to correlate the findings and integrate tools. Let's look at the steps to set up the Security Hub. To use Security Hub effectively, especially for the compliance checks against the standards, the AWS Config needs to be enabled first. The Security Hub gathers the findings based on the AWS Config rules. Next, you enable the Security Hub itself through the console or API and configure its settings. And with Security Hub, you can enable the security standards. These include the AWS best practice, the CIS benchmark, and the PCI DAS. Once enabled, the Security Hub automatically runs checks based on the rules defined in these standards. The Security Hub can aggregate the findings from the multiple regions into a single region. It also supports the multi-account setup. The aggregating the findings across the multiple accounts is the best managed by the integrating with AWS Organization. Alternatively, you can manually invite individual accounts. The Security Hub provides the dashboards that show the insight based on the aggregated findings from the all integrated services and enabled standard. With this, you can centrally manage the security information from the multiple accounts and the multiple services in one place. And here, let's briefly introduce a concept for securing the public cloud operations, CNAPP. The CNAPP stands for the Cloud Native Application Protection Platform. It is an integrated concept or approach for protecting the application and the data in public cloud environment. The representative capability often includes in the CNAPP CSPM, the Cloud Security Posture Management, which helps prevent the cloud misconfiguration and assess the compliance, and the CWPP, the Cloud Workload Protection Platform, which monitor and protect various clouds centrally. The AWS Security Hub primarily functions as a CSPM tool. It checks whether your AWS resources configuration deviates from the security best practice and the selected compliance standards. The next is Amazon Detective. Amazon Detective is a service that makes it easier to investigate the root cause of potential security issues in your environment. Here we see the 5 functions of the NIST frameworks again. The Amazon Detective primarily helps during the phase after the detection and up to response. While services like GuardDuty and the Security Hub detect the potential security threat, the Amazon Detective takes these findings and helps you investigate the related activities by automatically collecting the log data. It simplifies the complex investigation tasks, saving the users from having to manually collect large volumes of different logs. And let's clarify the detective relationship with other services. The security incident analysis requires primary log sources, and this layer includes the raw data about the event and activity, for example, the CloudTrail, the VPC Flow Log, and DNS logs, and the logs from the ELB, CloudFront, WAF, and the CloudWatch logs. Next, the detection tools analyzes these primary logs to find the potential threats and the vulnerability. And then Security Hub aggregates the findings from these detection tools into one place, and this makes security monitoring more efficient. And finally, Amazon Detective often starts its work based on the finding identified in the Security Hub or the GuardDuty. It helps you investigate the underlying events and the related activity in details, assisting in identifying the root cause and the scope of the impact of the potential security issue. Amazon Detective analyzes the relationship between collected logs to build a model called the behavior graph. And this graph visually representing the interaction between your resources. The Amazon Detective automatically processes the log data and the findings to construct and continuously update this behavior graph. And you can explore the behavior graph and the related findings through the Amazon Detective console. A behavior graph consists of the administrator account and the member account. The log data is collected from all member accounts and analyzed within the single behavior graph, and managed by the administrator account. The administrator account can invite and manage member account, and this allows you to centrally analyze the security data from multiple accounts within your AWS organization. The behavior graphs are region-specific, so pricing and any free tier usage are also calculated per region. And here's some example of insight you can get from the Amazon Detective. A typical use case includes the investigation findings related to the unusual API call pattern, the suspicious access from the non-malicious IP addresses or increases in the failed login attempts. So let's walk through the steps in the Amazon Detective investigation. And first, an investigation usually starts from the specific finding detected by the GuardDuty or Security Hub. And from the console, you can select the finding and choose to investigate it in the Amazon Detective. Next, based on the finding type, the severity, and other details, you use Detective to understand the potential threat. The Amazon Detective often groups related findings and activities together, helping you to see the bigger picture of the potential security event. And you can use the severity to prioritize your investigations. And you then analyze the details of the entities using their dedicated profile pages within the Detective. As mentioned, the Amazon Detective automatically collects and processes data from the multiple log sources. From an entity's profile page, you can view the related findings, such as the CloudTrail API call or network traffic information from the VPC Flow Logs. Amazon Detective helps highlight unusual activity compared to the entity baseline. And it's important to note that you cannot directly trigger EventBridge rules or Lambda function based on the investigation result within the Amazon Detective itself. If you want to perform automated actions, use EventBridge to capture the initial finding event from the GuardDuty or Security Hub. You can then trigger a Lambda or other target from those initial findings. The Detective's primary value lies in the investigation and analysis phases, helping you to gather the context and understanding the needed to decide on the right response actions, where the manual or automated. So let's now introduce the AWS Systems Manager. The System Manager is an operational management service designed for hybrid environment, including your AWS and on-premise resources. The System Manager actually provides many different capabilities. It offers a function to support your system operations such as application management, change management, node management, operation management. The System Manager originally started as the EC2 Simple System Manager, a service focused on managing the EC2 instance. Its name was later changed to System Manager around 2017. Because of its origin, it has a strong future for the server management, and is often abbreviated as the SSM. To use most System Manager features, you need to install the SSM agent on the target instances. The SSM agent is installed by default on many recent Amazon machine images for Windows and the Linux distribution. However, for on-premise server or some other OS version, you will need to install the SSM agent manually. It's common to use several System Manager features together to achieve a specific outcome. To give you an idea of a common use case, so let's introduce a basic pattern for the automated patching. And here's an example of using the System Manager for patching. The first, you use the Patching Manager to define rules for upload the patches for each operating system. And these rules are defined in the patch baseline. The Patch Manager is a primary tool for managing the patch operation to check the patch compliance status, define these baseline, and execute patching. Next, configure maintenance window. This defines a specific time slot when the maintenance tasks should run. You also specify which instances should be included in the window and which tasks should be executed. When the scheduled times arrive, the specified tasks such as the patch scanning and the patch installation are executed on the targeted instances. The run command is used internally to execute a necessary command on the instances. It typically runs the predefined SSM document that contain the steps for the tasks like the scanning on the installing patches. Continuing the patch example. The inventory and the compliance reporting feature gathers the patching status from the managed instances. And Explorer and Ops Center provides the dashboard where you can view the overall patch status. If issues are found, they can be automatically tracked as the Ops items for investigation or further actions. The detailed results are collected and can be reviewed in the console or through the generated reports. As you can see, it is common to use multiple features together in an integrated way. By combining these features, you can automate many operational tasks like patching, improving the efficiency and consistency. In the AWS document, the System Manager's features are introduced under the four main categories: the node management, the change management, the operation management, and the application management. The node management tools help with the tasks like managing the lifecycle, the configuration, access, and the patching of your managed nodes. The change management feature helps you centrally implement and track changes to your infrastructure and application in the controlled way. The operation management tools assist with detecting the operational issues, responding to the incident, and understanding the overall operational state. The application management tools help with deploying the applications, managing the configurations, and handling the parameters or secret. And we will now explain some key tools within each of these categories. There are many features, so this might seem detailed, but they are all important tools for efficient operation. The first, let's look at the node management tools. The Fleet Manager provides a GUI to manage your managed nodes. It allows you to check the status of individual nodes and perform the basic operation on them. The Session Manager provides the secure remote share access to your managed nodes without needing the open inbound ports like SSH port 22 or RDP port 3389. The access is controlled through the IAM Policy. Traditionally, you might need to connect via SSH, possibly using the Bastion host, but keeping these ports open increases security risk. The Session Manager avoids these risks and also allows the logging of session activity, so you can audit who connected to which server and when. Run command lets you remotely execute a command on the managed nodes. The run command is often used internally by other features. The State Manager helps ensure that managed nodes are maintained in the desired configuration state. It automatically checks the configuration defined in the SSM document on the schedule you define. For example, it can check if specific software is installed or if certain OS settings are correctly applied, and automatically take corrective action if a node is non-compliant. The inventory automatically collects the metadata from your managed nodes about the installed application, network configuration, the files, and more. It centrally stores the inventory data so you can query it to understand your environment. The Patch Manager automates the process of the patching operating system. It handles the scanning for the missing patches, the reporting on the patch compliance status, and scheduling the patch installations. The distributor allows you to centrally distribute and management software packages on your managed nodes. The next are change management tools. The automation is a tool that allows you to create and run automated workflows called runbooks using the script the calling AWS API, and run commands. It is used to automate the common tasks safely and repeatedly. The change calendar lets you define the specific time period during which changes initiated by the system manager are either allowed or prohibited. For example, you can block automated changes during the important business events or peak hours to prevent the unintended disruptions. The Change Manager provides the central framework for managing the end-to-end process of operational changes. It helps standardize the change request, the reviews, the approval, the tracking, and the reporting using the predefined change template. The maintenance window defines the scheduled window of time for performing the maintenance tasks. Typically, the system maintenance is scheduled during the off-peak hours. The next is the operational management tools. Explorer provides an operational data dashboard aggregating the information from across your account and region. It helps you get an overall view of your operational health, including the summaries of the patch compliance, ops items, and inventory counts. The Ops Center centralizes the operational issues, tracking them as the ops items. It can aggregate the issues from CloudWatch alarms, the Security Hub findings, or detected patch non-compliance, for example. The Ops Center provides a central hub for investigation and resolving these ops items. You can integrate Ops Center with the automation runbooks to automate the response to certain issues. The Incident Manager helps you prepare for and respond to the critical incidents more effectively. You can define the incident response plans upfront, which specify the contact plans, the escalation paths, and the automated diagnostic or remediation runbooks. When an incident is detected, the Incident Manager automatically initiates the relevant response plan to engage the responders and run automated actions. And finally, Application Management Tools. The Application Manager helps you manage your application by grouping the related resources together as an application. You can then discover the operational data, the deployment status, and the compliance information of application in one consolidated view. The app config is used to manage the application configuration data dynamically. It allows you to safely deploy the configuration changes without needing to redeploy your application code, and includes the validation and the rollback capability. The Parameter Store provides a secure hierarchical storage for configuration data and secret. It can manage the standard string as well as the secure string, which are automatically encrypted using the KMS. The Parameter Store also supports the versioning of the parameter and the fine-grained access control via IAM. The next one is Amazon EventBridge. The EventBridge is a serverless event bus service. It receives the events from the various sources. It then filters these events and routes them to specific targets. The EventBridge plays a central role in building the event-driven architecture. By decoupling the event sources from the event target, it helps increase the flexibility, the scalability, and the resilience of your systems. The EventBridge is the successor to CloudWatch Event. While CloudWatch Events primarily handle the events originating from within the AWS, and EventBridge adds the native support for third-party partners. It also offers expanded capability for event processing and routing. And currently, the EventBridge includes the three main capabilities: Event Bus, the Pipes, and the Scheduler. Event Bus is the core and the most fundamental capability, and similar to the original CloudWatch event functionality. The event bus allows you to build an event-driven pipeline connecting the event sources to the target. You can configure event sources and the target, and use rules to filter incoming events based on the defined patterns, sending only the matching events to the target. There are different types of the event buses. The default event bus existing in every AWS account by default and automatically receive the events published by the most AWS services. The custom event buses is created by you to receive the event published from your own custom applications. And the partner event buses is used to receive the events directly from the supported SaaS partner after you configure the integration. Within the event bus, you can configure rules to connect the incoming event with the target that should process them. With the rules, you can selectively filter specific events flowing onto the event bus based on the event pattern. They then route them matched events to the specified target. For example, this is an event pattern designed to capture object-created events for specific S3 bucket. The target can include Lambda function, SQSQ, step function, and Kinesis streams, and many other AWS services. The EventBridge pipes helps you create a simpler point-to-point integrations. It is designed to connect a single specific event source directly to the single specific target. While Event Bus uses rules for flexible routing from many sources to many targets, the pipes focusing on the streaming one-to-one connection between the specific supported services. Optionally, you can include the steps within the pipes for filtering events based on the criteria, or enriching them before they reach the target. Let's look closer at the EventBridge piped features. As mentioned, the pipes offer an optional enrichment steps, which you can transform the events data or add more information to it by invoking other services like a Lambda, step function, or external API. And beside enrichment, the pipes also offer built-in features for event filtering, the input transformation, the ordering guarantees for certain sources like a FIFO SQSQs, and error handling configuration. Next is the EventBridge Scheduler. EventBridge Scheduler is a serverless scheduler designed to trigger tasks based on the defined schedule, and you can configure a schedule using the familiar cron or late expression. While you can also create the scheduled rules using the event bus, EventBridge Scheduler offers more advanced feature and scalability. For example, EventBridge Scheduler supports one-time schedules, supports time zone, allowing triggering the wider range of AWS services. API targets directory, includes a built-in error handling like dead letter queues and retry policy, and offers high scalability, allowing you to create and manage millions of the scheduled tasks. The next is AWS Lambda. The AWS Lambda is an event-driven, serverless compute service. The event-driven means the service runs your code in response to the specific event rather than running continuously. The serverless means you don't need to manage the infrastructure. AWS handles that for you. You are also charged only for the compute time you consume. The Lambda integrates with the various services and runs your code in response to the event. The services like Lambda that run function in the cloud are often called FAST or Function as a Service. And Lambda supports various languages such as Java, Python, Go, and others. While it can integrate with many services, the function needs appropriate IAM permission to interact with those services. And here are some common use cases for Lambda. The Lambda supports a wide range of applications. For example, you can trigger a function in response to HTTP request via API gateway, trigger a function when data is uploaded to S3 bucket, the run function on the regular schedules. To better understand the Lambda's roles, I think looking at the example is helpful. And this is a sample Node.js scenario where Lambda is triggered by an HTTP request via API gateway to retrieve data from DynamoDB. It's common to use API gateway together with Lambda when processing HTTP requests from web or mobile applications. An application sends a HTTP GET request to API gateway. The API gateway acts as the HTTP endpoint, receives the request, and then invokes the configure Lambda functions, passing the request details to it. The Lambda function then processes this request. When the Lambda function is triggered, it might extract an ID from the request query parameters and uses that ID to fetch the corresponding data from the DynamoDB table. If the operation is successful, it returns the retrieved data back to API gateway, which then sends it to the original client. When many requests arrive concurrently, Lambda automatically handles the load by launching the multiple execution environment to the process request in parallel. However, there is the default concurrency limit for your function per region, typically starting at 1,000 concurrent execution across all functions in the account. If more requests arrive than can be handled within this limit, subsequent invocation request will be throttled. If you are facing the throttling failure, you need to request a limit increase from the AWS support. The document indicates that this limit can potentially be increased to the tens of thousands requests. So next, let's introduce Lambda layer. The Lambda layer provides a way to package library, custom runtime, or other dependency separately from your function code. And these layers can then be shared and used across the multiple Lambda actions. By storing the commonly used component in layer, you can reduce the size of your individual function deployment package, making the deployment faster and easier to manage. The Lambda also supports versioning and aliases. The versioning allows you to publish and maintain multiple versions of your function code. When you update your function code and publish it, the Lambda creates a new immutable version. And the aliases act like the pointers to specific function version. You can create the aliases and point them to different function versions. This allows you to easily manage the different deployment stages or perform the traffic shifting between the versions. And lastly, I will introduce the quotas for Lambda. Lambda is charged based on the number of the function executions. To prevent the unlimited charges, the Lambda has a timeout setting. The default timeout is 3 seconds, and the maximum execution time per request is the 900 seconds, which means 15 minutes. Since the maximum time is only 15 minutes, the Lambda is not suitable for long-running tasks. It's best for short jobs. The temporary storage for data is limited to 512 MB. The total size for function and layer is 75 GB. But this can be increased by submitting a request. The default concurrent execution per region are limited to 1,000, but this can also be increased with the request. And if your function hits the limit during the high traffic, you will need to raise the limit. The memory starts at 128 MB and they can go up to the 10,240 MB. You can add up to 5 layers per function. The Lambda is used in a lot of use cases and is a service you will frequently encounter in certification exam. Since Lambda allows you to run custom code, so theoretically it can perform an extremely wide variety of tasks. It can be triggered by events from the many different AWS services and easily integrate with others, so making it seems like the viable option in many different scenarios. However, a key consideration is that the using Lambda requires developing, testing, and maintaining code. Therefore, it involves the implementation and operational effort. If one exam question includes the requirement like the minimal operational overhead, the Lambda might not be the best answer compared to using the free managed service. Also, as we just discussed, the Lambda has several quota or limit. The Lambda is the best suited for the short running, the stateless, the processing tasks triggered by events. Next, let's cover security logging and monitoring. And we will start by looking at the key logging and monitoring services like the CloudWatch, Config, and the CloudTrail. And we will briefly touch on the tools for log analytics. And firstly, I will give you an overview of the system monitoring. And system monitoring is the process of monitoring a system to ensure that it's working properly. The system monitoring includes the infrastructure monitoring such as the servers, network, and the operating systems, and the service monitoring such as the software, DNS, and the load balancer. And it also provides a trail of who did what and when. You can take appropriate action when the problem occurs. And furthermore, it's also necessary to take a history of changes on the resource side, such as whether the resources in operation are compliant with the appropriate rules. The AWS provides the CloudWatch as the system monitoring, the Config as a resource change management tool, and the CloudTrail as a trace management tools. So let's get started with Amazon CloudWatch. The CloudWatch is an integrated operational monitoring service. It has many features and can monitor any AWS services, making it the most widely used monitoring tool. The CloudWatch monitors AWS resources and can trigger actions and alerts based on the changes in the logs and metrics. And you can find the complete overview of the CloudWatch functionality here. It collects the logs and the metrics from the monitored EC2 instances and raises an alarm if a preset threshold is exceeded. It also sends a notification via SNS and can work with the Lambda function to perform necessary actions. The CloudWatch Logs is a free managed service to centrally collect and analyze logs data from the AWS resources and on-premise servers. You can store logs long-term and search them via the console or API when needed. And this helps with the incident investigation and meeting the compliance requirement. The log data typically has a timestamp and a message, and the log streams are a sequence of the log event, often from a specific source, and the log groups are containers to organize these log streams. The CloudWatch Logs Insight lets you interactively query and analyze your CloudWatch logs. To run a query, you select the target log group and specify a time range, and you can also define fields or patterns matching your log format. And here's an example query for searching VPC Flow Log, searching by the source address and the timestamp. And for more complex analysis or visualization, you can export logs to S3 and use the tools like Amazon Athena or Amazon QuickSight. The metric filter lets you find a specific term, phrases, or patterns in your CloudWatch log in near real time. They count the occurrence of these patterns and extract the numerical values, and publishing the result as a custom CloudWatch metric. And this allows you to monitor specific events in your log. For example, you could create a filter for the production log group to count a log contain an error or fatal. Then you could set up the CloudWatch alarm to send a notification if this error count metrics go above the 10 in the 5-minute period. The next, CloudWatch metrics. The metrics are measurement taken over a specific time period, providing the information about the system health and performance. The metrics can be automatically obtained from the various AWS services or through APIs. In addition to standard metrics like CPU usage and HTTP request, you can also create a custom metrics tailored to your needs. Besides AWS resources, you can retrieve the metrics for on-premises systems and other cloud services. The metrics can be collected by installing the CloudWatch agent on the Linux and Windows server. The agent collects data from the system and sends it to the CloudWatch. Next is CloudWatch alarms. The CloudWatch alarms are triggered when the predefined thresholds are exceeded or abnormalities are detected. The alarms can trigger SNS notification and actions, allowing you to respond to incident quickly. You can set the statistics to be monitored, the time period, the threshold for triggering alarms, and the specific metrics to be alarmed on. Alarm states include OK, alarm, and insufficient data. The EventBridge, the former CloudWatch event, allows you to take a specific action based on the events and the rules. You can trigger action on a target based on these events and rules. There are two types of the event source, the schedules and the events. A schedule defines an event such as trigger and action on a certain day of the week. The events trigger action when the metrics for resources exceed a certain threshold, or when there is a changes in the resource status. You can define a schedule using the method like a late or cron. The example of the late and the cron expression are listed in this table. The target is AWS resources, where the action will be executed. And the CloudWatch events are often used in conjunction with Lambda functions. You can also set up the events to trigger another AWS resource to perform an action. The CloudWatch, Config, and CloudTrail are monitoring tools, but you can also think of them as the detection tools because they help find potential threats and risk. The CloudWatch can use its alarm feature to detect when certain metrics go above a threshold and when a specific pattern appears in the log using metric filters. The Config detects when resources settings don't follow your defined rules, indicating the non-compliance. The CloudTrail, by sending its logs to CloudWatch logs, allows you to use metric filter and alarm to detect if specific API call happen too frequently, exceeding the threshold. Also, events or alarm from these tools can work with the EventBridge to automatically trigger other services like a Lambda function or SNS notification, enabling the automated responses. Next, I will present the example of server management using the CloudWatch agent. I will use the example of setting up and running the CloudWatch agent on to demonstrate the implementation. First attach an IAM policy to the target resource. Then use the System Manager to install, configure, and start the CloudWatch agent. And finally configure CloudWatch for monitoring. And if necessary, you can adjust the CloudWatch settings during the operation as needed. First, attach an IAM policy to the target resources. The default policy related to the CloudWatch agent includes the CloudWatch agent admin policy and the CloudWatch agent server policy. The CloudWatch agent admin policy allows you to the SSM put parameter, which enables the configuration file to be written during the setup. After the setup, SSM put parameter is no longer needed, so CloudWatch agent server policy is sufficient for operation. And the Amazon SSM managed instance core grants the permission to use the core feature of the System Manager. It includes the permission for executing the commands and sending the output to System Manager. And let's take a closer look at the JSON content of the CloudWatch agent admin policy. It's a bit too long, so I've split it into 2 lines. The put metric data action is needed for sending the metrics, and the put log event is required for sending logs. The put parameter refers to the writing to the configuration file, and the action is used during the setup and is usually not needed during the regular operations. Following the principle of the least privilege, the put parameter becomes unnecessary after the setup is complete. And the next step is to use System Manager to install, configure, and start the CloudWatch agent. You can install the Amazon CloudWatch agent from the System Manager distributor. The agent is configured through the terminal. The many AMIs, the Amazon machine image, comes with the agent pre-installed. The Microsoft and the Linux AMIs released after the 2016 already have the agent included. However, on some servers and on-premises servers, you need to install the agent from the System Manager. You can start the CloudWatch agent by running Amazon CloudWatch Managed Agent from the run command. Once the CloudWatch agent is running, it will begin sending logs and metrics from the server. The detailed settings for the metrics and logs that the CloudWatch agent captures are defined in the agent configuration file. And here you can set the correction interval for metrics and specify where the log files are stored. In this example, you can specify the CloudWatch logs. In the metrics section, you can define the things like disk usage, memory usage, and more. And you can also add dimensions for each resource. In the log section, you can specify the log storage location, the log file path, and the log stream. Finally, you can filter the logs you can get and visualize them in the dashboard. After installing the agent, you can filter logs by specifying the strings like errors, warnings in the CloudWatch logs. And these logs can be filtered and used as metrics. For example, if a log containing a certain string exceeds a specific threshold, it can trigger a notification to other services. The metrics you can obtain with the CloudWatch agent include those listed here. The agent allows you to gather detailed metrics such as the disk, CPU, memory, and network usage. Additionally, you can get application log, system log, and HTTP access logs with the CloudWatch agent. Next, I will introduce AWS CloudTrail. The CloudTrail is a service that records the user activity and API operation as a trail. It logs details like when, who, and what. The CloudTrail captures two types of events, the management event and the data event. The management events involve the creation, modification, and the deletion of resources, while data events create the operation on the specific AWS resources. For example, creating the S3 bucket is logged as the management event, while saving an object to S3 bucket is logged as the data event. The trail includes information such as the event timestamp, event name, username, and resource name, and it allows you to track who did what and when and why. The CloudTrail Insight can also be enabled to detect and display anomalous activity logs, and please note that the CloudTrail Insight is a paid feature. So let's cover CloudTrail's basic feature. The CloudTrail is enabled by default, recording the past 90 days of the management event in the event history. And for longer retention or to the log data and the log insight event, you can create the trail to deliver logs to an S3 bucket. A single trail can capture events from the all region. And with AWS Organization, an organization trail can aggregate logs from all accounts into a single S3 bucket and simplify the auditing. And for security, the logs in S3 are encrypted by default and with an SSE KMS option for customer-managed keys. And the log file integrity validation is available to detect tampering using the digest file, often needed for the compliance. The CloudTrail records the three event types, the management, data, and insight. The management event track resource management actions like create, modify, delete, and are logged by default. And the data events track actions within the resources like S3's get, put, and the Lambda inbox, and require explicitly the enabling in the trail for specific resources. The insight event records unusual API activity pattern detected by the CloudTrail using the machine learning, and this is an optional paid feature that you need to enable separately by enabling the CloudTrail Insight on the trail. The CloudTrail Insight identifies unusual activity related to API call and error rate. The insight event related to the API calls are generated for write management APIs, while events for API error rates are generated for both write and read management. The CloudTrail Insight establishes a baseline based on the activity over past 7 days of the management event data. If API call volume or error rate deviates significantly from this baseline, an insight event is recorded to help you investigate potential operational issues or security incident. And if you want to prevent modification or deletion of trail, such as for auditing purpose, it's recommended to use KMS encryption, the S3 bucket policy, IAM policy, and MFA delete settings. Additionally, you can create a dedicated account for storing the trail, the separate operation stuff from the security administrator, and use the digest file to detect any tampering with the trail. Next, I'll introduce AWS Config. The AWS Config is a service that logs configuration changes of AWS resources and evaluates whether they comply with the organizational rules. The config tracks the resource change history and evaluates the resource based on the specified timings. It's particularly useful for enhancing the security and governance. For example, you can use config to create rules that ensure SSH connections are properly configured for EC2 instance. The SSH is an encryption technology that secure traffic to the EC2 instance. In this case, the config will track the EC2 instance's startup and modification history. And if it detects that EC2 instance has been started without SSH configured, it will notify you that the rule has been violated and can trigger corrective actions if necessary. By setting up the aggregator, you can centrally manage the config rules, compliance results, and the resource inventory data from the multiple AWS accounts and regions in a single account. And integration with AWS Organizations is also possible. The aggregating the data to simplify the monitoring and the governance across your AWS environment. The AWS config allows you to set up the config rules, check the compliance with your rules, and then receive notification when the resource doesn't follow the rule. The config rule includes the AWS managed rule, which are provided by the AWS by default, and the customer managed rule, which are customized by the user. For example, the restricted SSH, which checks whether an SSH connection is configured for an EC2 instance. The number of the available rules has increased every year since the service was launched, and as of now, there are over 150 rules. When an event occurs, the config checks if the resources follow the rules and records the result. For example, an EC2 instance is evaluated when it is started or modified. The rules can be evaluated continuously on a daily basis. The continuous recording logs changes as they happen, while the daily recording logs change only once a day. The continuous recording can be more expensive due to the higher the number of the notifications. The config is charged based on the number of the rule evaluation. The config rule compliance changes or resources configuration changes can generate the events sent to EventBridge or findings set to Security Hub. For automated action, the standard method is to capture these findings or events in the EventBridge and trigger services like Lambda or Systems Manager. And you can combine Systems Manager to automatically remediate the resources found on non-compliant by config rules. When the config rule reports non-compliant, it can trigger SSM automation runbook to perform the corrective actions. For example, SSM can modify security group rules to block access to unintended traffic. And you can also add in the approval steps before the automated remediation. The next, conformance packs is a feature that bundles the multiple config rules and the remediation action into a single package. They act as a template to help to meet specific compliance standards or internal policy. It is written in YAML. The conformance packs allow easy to deployment on the consistent set of the rules across the multiple accounts and region in your AWS organization. And you can use the standard queries to search log history. While CloudTrail is a service that tracks API activity on user side, the config is primarily focused on capturing the change history on the resource side. And this is a sample JSON of the items that can be retrieved with the config and the example query. Next, let's discuss the log analytics. We've mentioned that AWS monitoring services offer some log analysis capability. However, for more advanced analysis, you can use dedicated data analytics tools. And we'll now explain the features and typical use cases for some key analytics services. A common approach is the data lake analytics using the S3, the Glue, and Athena. The S3 is ideal for the durable, the available long-term log storage, letting you to use the S3's security features. And you can use AWS Glue to define the structure of the log data in S3. Then use Amazon Athena to query the structured data using the standard SQL. The Athena query result can be saved back to the S3 and visualized with a tool like Amazon QuickSight. The Open Search Service is an analytics tool based on the Apache Lucene. It offers full-text search, the log analytics, and the real-time analysis. The Kinesis is a platform for the collecting, the processing, and analyzing the real-time streaming data. The Kinesis often acts as the data streaming hub, feeding other systems, rather than being the final analysis engine itself. And managed query tools like the CloudWatch Logs Insight are suitable for quick, interactive querying without needing to transfer the data. First, let's discuss the ETL, which stands for Extract, Transform, and Load. The extract is the process of retrieving data from various sources like databases, API, or flat file. The extracted data is then transformed into the format suitable for the target system. The transform is the process of the modifying and the cleaning the data to meet the business or analytical requirement. And finally, the transformed data is loaded into another target system. The ETL is traditionally used with the batch processing system, where the transformation is done before loading. And recently, with the cloud-based data warehouses like Amazon Redshift, the ELT has become popular. It can transform the data after loading. The AWS Glue is a comprehensive ETL tool. Let me first provide an overview of the Glue's functionality. The Glue consists of the several components. The Glue crawler retrieves the schema information from the data sources, which can include the relational database as well as the semi-structured data. The schema information is stored in the data catalog. Additionally, the Glue offers a feature called the Glue Schema Registry, which can save the schema for streaming data. And when needed, ETL job can be executed. The data transformation can also be performed based on the predefined rules using the Glue data quality. And furthermore, the entire set of the Glue functionality can be managed through the workflow. For instance, you can trigger a Glue crawler when an object is added to the S3 bucket or execute workflow on the schedule. The workflow can be managed via the Glue Studio. And from here, I will introduce the feature of the Glue step by step. And first, I will explain the Glue crawler, which extracts data and the metadata store and the data catalog. The Glue supports a variety of services as data sources, including the database, streaming data, and the various data stored in S3. And not only AWS, it also supports the public cloud services and on-premises services. The metadata obtained by Glue crawler is stored in the Glue data catalog. The Glue data catalog manages the metadata for S3 and the database services. The metadata includes details such as the schemas, the data format, and the storage location. And if you want to manage the schema for streaming data like Kinesis or MSK, you can use the Glue Schema Registry. The Schema Registry is suitable for maintaining the schema consistency in real time and tracking the changes in streaming data. The Glue crawler automatically infers schemas from the data sources and creates a table definition in the data catalog. And here is an example of metadata extracted by the Glue crawler. The table information includes the general details such as the table name and the storage location. The table property contains information such as file format and the compression method. The table schema includes the actual table name, data types, and attribute information. AWS Glue has two types of data structure, data frame and dynamic frame. The data frame is a concept from the Apache Spark and represents the distributed collection of data organized into the named columns. The data frames are immutable and can be transformed into new data frames. The dynamic frame is specific to AWS Glue and is designed to provide the flexibility of ETL. It is useful when the schema is not predefined in advance. They can be easily converted to and from to data frames when needed. The next I'm going to introduce ETL job. The AWS Glue's ETL jobs support various data transformations. The Glue's ETL jobs are based on the Apache Spark and Python. In addition to basic data transformations, you can also create a custom transformation logic. And here is the example code for the data transformation using the PySpark. To filter rows where the age is greater than 30, and concatenate the first name and the last name, and you would write the code like this. In AWS Glue, the dynamic frame is used for the initial data reading and the final data writing, while the PySpark data frame is used for the actual data transformation process. So when you want to import data from the data source, use a data frame. When you want to convert data, convert the data frame to dynamic frame, and then convert the data frame again to a data. Finally, I'm going to introduce Glue's workflow. The Glue's bookmarks allows you to create a checkpoint within the job. When bookmarking is enabled, increasingly added data will be processed, and which improves the processing efficiency. And you can start the Glue jobs based on the schedule or event. You can use cron to execute ETL tasks at a specific interval or time. Additionally, you can specify events to trigger a job based on the state changes or a specific condition. And the Glue Studio is a tool for visually managing ETL jobs. The Glue jobs are defined using the DAGs, the Directed Acyclic Graph. You can define the ETL tasks in the specific order. And finally, the table summarizes the types of computing suited for different dataset size. And you can use Lambda for transforming the small-scale data. However, the Lambda has limitations on the runtime and memory. For example, the maximum execution time is 15 minutes. For small-scale data processing, where Spark or Ray is not used, you can use the Python shell. For medium-sized data requiring the parallel processing, Ray can be used. For large-scale data, the Spark is appropriate. For example, when loading the terabytes or petabytes of data in Redshift, the Spark is recommended. Additionally, for processing the real-time, such as with Kinesis or Kafka, you can use the Glue for streaming. Next, I'm going to introduce Amazon Athena. The Amazon Athena is a tool for querying and analyzing data stored in S3. It allows you to execute a query on the various data formats in S3. Since Athena is serverless, you don't need to manage the infrastructure, which you can start querying data immediately. You only pay for the query you execute, and there are no server running costs. Athena is built on Presto, the distributed SQL engine. It supports data formats like a packet on the ORC, improving the query performance while reducing the cost. The Athena uses the standard SQL to analyze the data formats by Apache Hive, including the packet, the CSV, the JSON, ORC, and Avro. The Athena integrates natively with the AWS Glue. The Glue automatically detects and catalogs metadata, simplifying the table management. The Athena adapts the schema-on-read model, where the schema is applied at the query time, and this allows raw data to be stored. In contrast, the schema-on-write model requires both data and the schema to be stored, enforcing the schema compliance during the data ingestion. Athena directly queries data stored in S3, which you don't need to load the data into Athena. You need to create a database and a table in order to query data with Athena. And there are two types of the create table, the definition the DDL manually from the Athena console or using the Glue data catalog. When defining the DDL in Athena, you need to manually specify the table schema, data location, and data format. The Glue data catalog is natively integrated with Athena. It automatically discovers the schema, catalog data, and support versioning. Generally, using the Glue alongside the Athena simplifies the process. I will introduce working group. A work group is a feature that segments the environment. You can configure access permissions for users or teams, isolate the environment. The work groups are used for environment isolation, the restrictions, and access control. For example, if you want to grant access to the production environment only to specific IAM user, the work group can be used. Each work group is assigned at ARN, which allows you to define the permission for each ARN using IAM Policy. With federated query, you can execute the SQL query across the multiple data sources. In addition to data in S3, you can analyze the relational, the non-relational, and the custom data sources. And you can also define your own custom function as UDFs, the user-defined functions, and call them with the SQL query. Using the Athena Query Federation SDK, you can implement these functions in Java, and they can be invoked from the Athena as Lambda functions. By utilizing the UDF, you can standardize the frequently used operation and enhance the query functionality. Next, I will discuss the cost and the performance of Athena. The cost of the Athena is based on the amount of data scanned. For example, in Tokyo region, it costs $5 per terabyte. Since the cost is based on the data size stored in S3, you can reduce the cost by compressing the data. I will introduce best practices for optimizing the query performance. First, ensure proper file sizes. If you run query against a large number of small files, the query performance will be low down. For columnar format, it is recommended to keep file sizes between 128 MB and 512 MB. You can improve the query performance by merging or splitting the file as needed. It is also recommended to use columnar formats, and this allows only the necessary column to be read, reducing the I/O operation. And set up the appropriate partitioning to make query efficient by filtering data, and this avoids reading unnecessary data. And compress the file to reduce both the reads and the storage cost. I will introduce the partitioning and the bucketing. The partitioning divides data into the directory unit. By partitioning the data based on the query, you can improve the query efficiency. For example, when selecting the logs by date, the partitioning by date improves the query performance. The bucketing divides the file based on the specified column. The file size affects the query efficiency if it is too large or too small. An optimal file size is typically between 128 and 512 MB. The partitioning and bucketing are independent concepts, so both can be used simultaneously. And so far, I have introduced the best practice for improving the Athena's performance. The AWS Technical Blog features a top 10 ways to improve the Athena performance, and I will share it here for your reference. The next I'm going to introduce Amazon QuickSight. The Amazon QuickSight is a free managed BI tool. Since it is free managed, you don't need to manage infrastructure. The QuickSight can scale accommodate hundreds of thousands of users without requiring the infrastructure management as users increase. The QuickSight offers a rich set of charting and reporting features. It supports not only AWS data sources, but also third-party tools. With its in-memory database Spice, the QuickSight enables a high performance without loading data. To use QuickSight, you need to create an account. There are two pricing plans, the Standard and Enterprise. The Enterprise edition offers more features and provides not only author accounts, but also reader's account. Additionally, the Enterprise queue includes access to the QuickSight queue. Next, we will discuss the QuickSight analysis features. The QuickSight calculated fields are custom fields used to manipulate the data. You can make a simple calculation, aggregation, and more. On the other hand, if you implement a large-scale data or complex logic in the calculated fields, the performance may degrade. In such cases, it is better to process the data using the AWS Glue beforehand and then load the transformed data into QuickSight. The QuickSight ML Insight provides the features such as the anomaly detection, forecasting, and the natural language processing using the machine learning. For example, by loading the past sales data, you can use machine learning to analyze the trends and predict the future sales. The ML Insight is available in the Enterprise edition. The QuickSight queue provides the features provided by natural language processing. With QuickSight queue, you can ask a question in natural language and receive appropriate visualization tool. For example, if you input show me the top selling items from the last week, the QuickSight will interpret the query and return a bar chart of the relevant data. The next is Spice. Spice is an in-memory engine developed by Amazon and specifically for the QuickSight. By using the Spice, the calculation can be much faster than directly querying the source data. The Spice automatically scales up or down based on the demand. The Spice is built to perform the parallel calculation across the multiple cores, enabling efficient processing of large dataset. The next is security features of the QuickSight. The QuickSight provides 3 roles. The admin has the full administrative permissions, including the account management, the data source configuration, and the user and permission management. The author responsible for creating the analysis, building the dashboard, and sharing the reports to utilize and visualize the data. and the reader builds the created dashboard and analyzes the data using the filtering and drill down capability. QuickSight provides a row-level and a column-level security. Instead of showing all data, you can control access to the specific rows and the column for particular users or tags. For example, the users with the department ID A can view only the data where the department ID is A. To use RLS, you need to create the RLS rules, the map users or groups, and share the dashboard. The RLS rules includes the range of data that can be accessed. Enabling the RLS can impact the dashboard performance. When filtering a large amount of data, it may take longer to reflect the changes. The RLS only restricts the data display within the QuickSight. It doesn't restrict access to the actual data source. And therefore, if someone has access to the data source, they can view all the data. To ensure the strict control over the data access, you must use IAM or resource-based policy to restrict access to the data source itself. The next is Amazon OpenSearch service. The OpenSearch is a search and visualization service. You can collect large-scale data, real-time data, and you can use the query to interact with search logs from the dashboard. The OpenSearch is a distributed search and analytics services. It is developed by the OpenSearch project and licensed under the Apache 2.0. Originally, the Elasticsearch and the Kibana were developed by the Elastic, but in the 2021, they were moved to the public license. Subsequently, the AWS led the creation of a new OpenSearch project. The OpenSearch offers advanced search capability. Not only simplify the matching the keyword, you can utilize more complex queries. The OpenSearch offers the ranking and evaluation, the phrases search, the proximity search, the fuzzy search, and the language-based search. These full-text search features enhance the searching capabilities, which allows you to find the information efficiently. The OpenSearch dashboard supports both API-based analysis and browser-based analysis. The OpenSearch dashboard allows you to search, to visualize, and generate the report for the data stored in OpenSearch. It enables the interactive operation and is used for the log analysis and system monitoring. Next, I will introduce Kinesis. First, let's quickly talk about the streaming data. There are two main ways to process data, the batch processing and the streaming processing, and these tools are often compared. The batch processing collects a large amount of data over a period, like hours or days, and then process it all at once, usually on the schedule. The streaming processing, on the other hand, processes the data continuously as it is generated or arrived, starting the processing almost in real time. For streaming, the data is processed and analyzed in real time. In addition, it requires to respond to a sudden increase in the workload. The Kinesis is a collection of the service that handles the streaming data. The Amazon Kinesis data streams, or simply KDS, collect and process streaming data in real time. The Amazon Data Firehose captures streaming data and transform it and load it into the target services. The Amazon Managed Services for Apache Flink is a service to analyze the streaming data. It supports SQL and Apache Flink. The Amazon Kinesis Video Streams is used for the streaming videos. The Amazon Kinesis Video Streams is outside the scope of the certification exam. The Amazon Kinesis Data Streams (KDS) is a free managed service for collecting and processing large volumes of real-time data streams. The streaming data consists of the data blocks of any size, such as the log stream, events, data feeds, and IoT data. The KDS is a real-time streaming service which processes streams to less than a few seconds. The KDS has a high scalability. As data volume increases, it automatically scales up and the data streams. Data can be replicated to multi-AZ to ensure the data durability. It integrates with the EMR, Lambda, Redshift, and S3, and with KDS, you can make streaming data analysis dashboarding. So I will explain ingestion and delivery on the producer side. For data ingestion, the records are divided into the data blobs and partitions. Based on the partition key, the data is divided into partitions. The partition key is a hash value which determines which shard to be added based on the hash range that each record has. And I'm going to introduce some key metrics related to Kinesis. The monitoring metrics per shard is crucial when determining the number of the shards. The record put rate representing the number of the records written per second. The limit per shard is 1,000 records per second. Byte put per shard indicates the amount of the data written to the shard. The throughput limit per shard is 1 megabyte per second. And if these limits are exceeded, you need to increase the number of the shards to process the data in parallel. Next, the Kinesis agent is an agent that collects a log file on the server and transfers them to Kinesis data streams or data firehouse. It is installed on the servers such as the EC2 instances to stream log information. And here we have the key features of the Kinesis agent. Similarly, the CloudWatch agent also runs on the server, but its main purpose is sending the logs to CloudWatch logs and metrics to CloudWatch metrics. The Kinesis agent, on the other hand, specializes in the sending data to Kinesis data streams or data firehouse. So next, let's introduce the consumer side. A consumer is a data target that retrieves data from Kinesis. By using the Kinesis client library KCL, you can build a multi-threaded application that reads data in parallel from the multiple shards. The KCL is a helper library designed to enable developers to efficiently read data. The records are retained within the shard for 24 hours to a maximum of the 365 days. During this period, the consumers can retrieve the same data multiple times. The KDS offers two capacity modes, the provision mode and on-demand mode. In the provision mode, you can manually determine number of the shard, and each shard is allocated with the ingress capacity. The cost is based on the number of the shard provisioned every hour. With on-demand mode, it automatically manages the capacity. It provides a default ingress capacity. It scales automatically based on the throughput peak in the last 30 days. Next, let's discuss the enhanced fan-out. The enhanced fan-out is a feature that provides a dedicated throughput for each consumer, reducing the latency. It allows up to 20 consumers to be registered. Each of these 20 consumers is provided with the 2 megabytes per second of the dedicated throughput, resulting that the total throughput is 40 megabytes per second. And this is significantly higher than the standard throughput of 2 megabytes per second. Additionally, enhanced fan-out is enable data to be directly pushed to consume using the HTTP2, and this reduces the latency to as low as 70 milliseconds. And I have summarized the quotas of KDS. Each shard can fetch up to the 1 megabyte and 1,000 records per second. The shards can also be reallocated among the third. In other words, it supports resharding. The data retention period is 24 hours by default and can be extended up to 365 days with an additional charges for the data retention. In terms of the performance, the data latency is less than 1 second. It can also read up to 2 megabytes of the data per second. In the context of the real-time processing, the KDS is often compared to the SQS. Here is a summary of the differences between KDS and SQS. SQS used for message queuing service, the KDS used for the streaming data processing. So please keep in mind that generally KDS offer more advanced features such as the ordering and throughput. The Amazon Data Firehose is a service that groups the streaming data sent in real time and transforms it into the format that is easier for subsequent steps to process. The streaming data flows continuously, making it difficult to process in its raw form. Therefore, it is grouped based on the certain size or time interval. For example, the data is grouped and processed every 60 seconds, and this means that the data firehose is not fully real-time, but rather near real-time, offering the performance close to real-time. Additionally, the Lambda functions are integrated into the backend of the data firehose, allowing for simple data transformation. The data processed by the data firehose can be delivered to the Redshift, S3, OpenSearch, and other destinations. The data firehose is a free managed service designed to process a large volume of data in near real time and load it into the other AWS services. While Kinesis data streams require the shard and throughput management, the data firehose reduces the need for such tasks. It supports automatic scaling to handle the fluctuation in the data volume. The data firehose can send the data to S3, Redshift, OpenSearch service, and Splunk. The data firehose allows for the data transformation and compression. With built-in Lambda function, it can transform data. The data firehose groups the data either by a fixed size or time interval before delivery, enhancing the data processing efficiency. The streaming data flows continuously, but its volume may fluctuate depending on the times of the day. In such cases, the grouping data by size or time interval improves the processing efficiency. The data firehose allows for buffering, enabling you to configure the time of the data delivery. And from 2024, you can set your buffering time to 0 seconds, and this allows you to have real-time data delivery. The data firehose supports compression and encryption, helping to reduce storage cost. And with built-in Lambda function, the data firehose offers flexible data transformation capability. In data firehose, the data transformation is performed using Lambda functions. For example, you can install the Kinesis agent on the EC2 instances to stream the logs to data firehose, where Lambda transforms the data. The transformed data is then sent to the services like OpenSearch for analysis. The data firehose provides the blueprints, which are predefined template to call function for the data transformation. The blueprint code is also publicly available on the Git. The format on the left side is the log format of Kinesis agent, and you can define the Lambda function to transform it into the JSON format shown on the line. And this is a comparison table of the data stream and the data firehose. The data streams require customization for both the producer and the consumer. Additionally, it requires manual management such as the sharding. On the other hand, the data firehose is a free managed service, and you don't have to manage your infrastructure. It offers the near real-time processing with a minimum buffering time. It's natively equipped with the serverless data conversion with Lambda. Amazon Managed Service for Apache Flink is a free managed service for processing the real-time data. Based on the open source framework Apache Flink, it is suited for the processing a large volume of streaming data. And for example, it can be used in the scenario where the log data sent from the Kinesis data streams and trigger an alert when the specific threshold is exceeded. The managed service for Apache Flink is a free managed service for real-time data processing. In 2023, its name was changed from Amazon Kinesis Data Analytics to the current one. It's a free managed service that allows you to use Apache Flink in the AWS environment. Since it's free managed, there is no need for detailed configuration or cluster management. It provides high scalability. If the data volume increases, then it automatically scales. It can process data with millisecond level latency, enabling the real-time data processing. Apache Flink can be integrated with the services like those listed here. You don't have to manage the infrastructure or cluster in the managed service for Apache Flink. Then you can process data stream using only business logic written in the SQL without needing to manage the data streams and or the processing task. And you can perform the analytics using the standard SQL. Additionally, it supports processing streaming data with Apache Flink and Apache Beam. You can also use the Studio Notebook for data analysis. Since the Studio Notebook is integrated with Apache Zeppelin, you can interactively develop using the languages such as Python, Scala, and SQL. Apache Zeppelin is an open-source web-based notebook platform. It enables the data-driven analytics and document sharing. The query result can be instantly viewed within the same interface. It supports a variety of interpreters, including the Apache Spark, Python, JDBC, Markdown, and Shell. It is also integrated with many tools such as Jupyter. The next is infrastructure security. In this chapter, we will introduce the infrastructure services focusing mainly on the networking services, and we cover them in this order: the VPC, Firewall, Gateway Services, the VPN, Direct Connect, CloudFront, the Route 53, Load Balancer, and API Gateway. First, I'd like to introduce an overview of AWS network services using the typical network diagram. On the left side, the diagram shows a network connected to the Internet through the Internet gateway. On the right side, it shows the network connected to the on-premise site and the VPN to using the virtual gateway. The first area, the outline in the red, representing the AWS cloud space within the specific region. The AWS provides the services from the data center in geographically separated regions globally. Each region consists of the multiple physically isolated availability zones designed for the high availability against failure. Within the AWS region, to create the VPC, the virtual private cloud, you are logically isolated the private virtual network. You define your own IP address range, CIDR block, and have control over your network environment within your VPC. Inside the VPC, you create a subnet, which is another address space. Within the subnet is where you actually place your AWS resources. In the diagram on the left, there are both private and public subnet. The confidential data should be placed in the private subnet, which cannot be accessed directly from the internet. On the other hand, the public subnet hosts the web server and allows access from the internet via the internet gateway. In the diagram on the right, the two subnets with the same configuration are placed in the different availability zone. And this setup ensures that if one subnet becomes unavailable, the other subnet can continue running the service. To allow access to and from the VPC, you need the gateway services. To access the internet, you use the NAT gateway, which converts the global IP address used in the internet space to the local IP address used inside the VPC. The internet gateway also has NAT functionality. To connect the VPC with an on-premise site, you set up the virtual private gateway on the VPC side and the customer gateway on the on-premise data center side. Each subnet has a route table that records the routing information, and this allows the routing between the resources, subnet, and the VPC. Additionally, each subnet is equipped with a firewall function called a security group. So now let me introduce the various services. A VPC, the virtual private cloud, is a private and logically isolated virtual network space within the AWS cloud. Using your VPC allows you to isolate your network environment. For example, you can set up the separate VPC for development and production. You define your own IP address range, CIDR block, and have full control over the designing your network within your VPC. The subnets are a smaller address segment within your VPC where you launch the AWS resources like EC2 instances. You can apply network ACL and the routing route table at the subnet level. Each subnet exists within a single availability zone. Using the multiple AZ increases fault tolerance. The public subnets have a route to the internet gateway, allowing direct internet access for resources with the public IPs. The private subnet lacks the direct route, protecting the resources like the databases from the direct internet access. They typically use a NAT gateway for the outbound internet communication. The IP addresses play an important role. They allow you to access AWS resources. You can use the CIDR ranges. The IP addresses you can set in the VPC are limited. And for IPv4, you can configure a range between /16 and /28, and this equals to 16 to about 65,000 IP addresses. And the first 4 and the last IP address in each subnet are reserved by AWS and cannot be used. Each service requires different IP addresses, so you will need to assign them accordingly. You can choose any address range, but using the private IP address spaces from the RFC 1918 is recommended, and these addresses are not routed over the internet, so they are safe for internet use and have saved global IP addresses. CIDR, the classless inter-domain routing, is a method for allocating IP addresses and sharing the route information to the internet. The CIDR allows the IP addresses to be divided into the groups called subnets, which can each be routed individually. In CIDR notation, the IP address is followed by a slash and a number that indicates the length of the subnet mask. For example, 192.168.1.0./24 represents the subnet with the 256 IP addresses starting from the 192.168.1.0. And in this case, the first 24 bits represent the network part, and the remaining 8 bits representing the host part. In AWS, you can set the subnet mask between 16 and 28, and which provides between the 16 and about 65,000 IP addresses. And each time the number after the slash increased by 1, the available IP addresses are halved. Although IP addresses itself may not appear directly in the exam test, it's useful to understand this concept. The AWS provides two types of the public IP addresses. The elastic IP addresses are static IP addresses that can be reused. You can associate an elastic IP address with any EC2 instances within your AWS account. Even if the instance is stopped or terminated, the elastic IP addresses remain the same. Be careful about the pricing of the elastic IP addresses. When an elastic IP is associated with the instance, there is no charge. However, if it is not associated with the instance, you will be charged. This is because IP addresses are limited resources, so a fee is applied as a penalty when they are not in use. Additionally, if multiple elastic IPs are associated with a single instance, the charges will apply. The auto-assigned public IP addresses are automatically and dynamically assigned by AWS. However, if the instance is stopped or terminated, the public IP is released. When the instance is restarted, a new public IP address is assigned. Next, I will discuss the VPC Flow Logs. The VPC Flow Log is a feature that captures information about IP traffic going to and from network interfaces (ENI) in your VPC. You can publish flow log data to the CloudWatch Logs or S3 for storage and analysis. The flow log captures traffic metadata, includes the source and the destination IP and the port, the protocol, packet byte counts, and the timestamp, and whether traffic accepted or rejected. And this helps monitor traffic and troubleshoot connectivity, confirming if the security groups or network AC are working as expected. However, the VPC flow log captures only metadata, not the actual payload of the traffic. To inspect the data content, you need different tools like the network firewalls or host-based agent. An ENI, Elastic Network Interface, is a virtual network interface within your VPC that allows AWS resources like EC2 instances to connect to the network and communicate. Resources such as IP addresses and the security groups are associated with an ENI. When you launch a EC2 instance, a primary network interface is always created and attached by default, serving as its main network connection point. You cannot detach this primary ENI while the instances exist. Optionally, you can create and attach secondary ENI to an instance, allowing for the multiple private IP address or network connection within the same availability zone. When using virtual appliances on AWS like a software-based virtual firewall, the NAT instances, or IDS IPS systems, you usually need to disable source destination check for the appliance's ENI. The virtual appliances are typically software running on EC2 instances designed to handle the network traffic passing through them. And by default, an EC2 instance's ENI will only send and receive traffic if its own IP address is the source or destination, and this is called source destination check. However, appliances like NAT instances or firewall need to forward traffic where they are neither the original source nor the final destination. If source and destination check is enabled, the instances will drop this forwarded traffic. Disabling this check is necessary for the appliances to function correctly, usually in conjunction with the VPC route table that directs the traffic through the appliance's ENI. Next, let's introduce the VPC Traffic Mirroring. The traffic mirroring is a feature that lets you copy network traffic passing through the ENI. It then sends a copied traffic to another target for deeper inspection. And we previously discussed the VPC Flow Log, which records metadata about network traffic like IP, ports, protocol, accept and reject status. While Flow Logs give you an overview of the traffic, they do not show the actual content. The VPC Traffic Mirroring, on the other hand, copies the entire network packet including both header and the payload, and this allows you to inspect the full content of the communication in detail. And here's how VPC Traffic Mirroring generally works. And first, you specify the mirror source, which is the specific ENI whose traffic you want to copy. And this can be ENI associated with the resources like EC2 instances, network load balancer, or RDS instances. Next, you specify a mirror target, which is a destination for the copy traffic. The common target includes the network load balancer and the gateway load balancer. A network load balancer is a very common target type. You typically place your traffic analysis or monitoring tools in the target group behind the NLB. The NLB distributes the mirrored traffic across those tools, providing the scalability and high availability for your monitoring setup. A gateway load balancer endpoint is often used when you need to send the mirrored traffic to specialized third parties, virtual security, or monitoring appliances. The VPC peering is a networking feature that connects two VPCs, allowing them to communicate with each other using private IP addresses as if they are on the same private network. Since it uses the AWS private network, the communication is secure. It's also designed to be highly available and avoid a single point of failure or bandwidth bottlenecks. You can create a peering connection between VPC in a different AWS account and even different AWS region. The resources communicate using their private IPs, so there is no need for public IP, gateway, or VPN connection between them. Now let's look at the case where the VPC peering cannot be used. If the CIDR blocks of the VPCs overlap, you cannot create the peering connection. And transitive peering is not supported. For example, even if you have the peering connection from the VPC A to VPC B and from VPC B to VPC C, the VPC A cannot communicate directly with the VPC C. And the VPC peering cannot be combined with other networking structures like the VPC connections, the Direct Connect, Internet Gateway, the NAT device in the private subnet, or VPC Endpoint for AWS services. A VPC endpoint is a virtual device that offers a private access from within your VPC. Generally, an endpoint refers to the physical device used for the communications. There are two types of the VPC endpoint, interface endpoint and a gateway endpoint. For example, now you are going to access an S3 bucket in another VPC from your EC2 instance. With an interface endpoint, the request side endpoint communicates with the service provider's endpoint. The endpoint on the requesting side is called an interface endpoint, while the endpoint on the service provider's side is called a VPC endpoint service. This endpoint uses the AWS private link to securely connect without going through the internet. In contrast, the gateway endpoint accesses the services provided VPC through the gateway endpoint. In this case, no endpoint is created on the service provider's side. The gateway endpoints are useful for S3 and DynamoDB routing the directory within the VPC without exposing the IP addresses. And here is a summary of the differences between gateway and interface endpoint. The gateway endpoints support S3 and DynamoDB, and they are free of charge. To connect, you need to add a route to the gateway in your route table. Since it's routed within the VPC, IP addresses are not exposed. It's not possible to access the gateway endpoint directly from the external environment. You need to set up a proxy server for the external access. The interface endpoints support many services. Since they use private link, they are pet service. An ENI and the DNS are associated with the interface endpoint. The DNS is specified in your application when making a request to the service. The interface endpoint allows private communication between the ENI and the service. This also makes it simpler to connect from the on-premise environment without using the proxy server. Now, both S3 and DynamoDB now support interface endpoint as well as the gateway endpoint. Choosing an interface endpoint for these services can offer advantage in specific cases. For example, they allow direct private access from your on-premise network using the Direct Connect or VPN. You can also apply the security groups directly to the interface endpoint for a specific network security control. Additionally, using the interface endpoint can sometimes simplify access across the different AWS regions or make it easier to connect with other services using the AWS private link network. And you can attach an endpoint policy to control access through the specific endpoint. Let's take an example. An EC2 instance needs to get an object from the specific S3 bucket via the gateway endpoint. The first, EC2's IAM role needs a policy allowing the get object on that bucket. The second, the endpoint policy can be configured to further restrict access through this endpoint. By default, it allows everything, but you could restrict it, for example, to only allow the get object action only from the specific EC2 instance role and only to the specific S3 bucket. And finally, you can also add a condition to the S3 bucket policy itself, restricting the access to only allow the request coming from the specific VPC endpoint. And this creates a layered security. Now let's speculate briefly on the historical reason why only S3 and DynamoDB originally offered a gateway endpoint, though this is not officially documented by the AWS. First, both S3 and DynamoDB are massive regional services that exist outside of any specific VPC. As they handle lots of requests, the gateway endpoint works by adding a route to your VPC route table, directing the traffic to the service within the AWS network without using an ENI in your subnet. This route-based approach might have been simpler and more efficient initial implementation for handling the scale of S3 and the DynamoDB compared to managing the potentially huge number of the ENI for interface endpoint back then. The benefit also includes the not consuming the private IP addresses in your subnet and having no additional hourly charge for the endpoint itself. And here, we will focus on the gateways that connect to your VPC to the Internet. The Internet gateway is a core component connecting to your VPC to the Internet. You attach one Internet gateway per VPC. It handles the network address translation for instances that have public IP addresses, enabling the two-way Internet communication. A NAT gateway is a managed service that allows instances in the private subnet to initiate the outbound connection to the Internet, while preventing the inbound connection from the Internet. It translates the private IP to the public IP address, and the NAT stands for Network Address Translation. The NAT gateway supports IPv4 traffic. For outbound-only Internet communication using the IPv6 from private subnet, you use the egress-only Internet gateway. When using an Internet gateway, the routes table for the subnet must be configured correctly, and this means having a route for Internet-bound traffic represented by the 0.0.0.0/0 for IPv4, pointing to the appropriate gateway. Also, for inbound traffic coming through the Internet gateway, it must be allowed by both the network ACL and the security group before it can reach the resource. The outbound traffic is similarly controlled by this security layer. The 0.0.0.0/0 CIDR representing the range covering all possible IPv4 addresses, as the /0 indicating a 0-bit network prefix. And for your reference, and this is a summary of NAT gateway and NAT instance. The NAT gateways have the redundancy in each availability zone and high availability. It can also expand bandwidth up to 100 Gbps. As a managed service, you don't need to maintain it. However, NAT instances, like EC2 instances, require you to manage the failover configuration and the maintenance. Unless there is a specific reason, a NAT gateway is commonly recommended. While generally not recommended, here are a few niche scenarios where a NAT instance might be considered. The first, for cost saving in a low traffic situation. Running a NAT instance on a small EC2 type could be cheaper than NAT gateway's charges, but only if the traffic is minimum. The second, if we have the specific network requirements not supported by NAT gateways, such as needing a certain protocol like GRE tunneling directly to the NAT device, though alternatives like a gateway load balancer might now exist. And finally, if you require OS-level traffic monitoring or full packet capture directly on the NAT device itself. While NAT gateway traffic can be monitored via VPC logs, you could install packet capture tool on NAT instances OS. However, the VPC traffic monitoring might be better alternative for this now. The next is Firewall Services. The first, let me provide an overview of the AWS Firewall Services. A firewall is a service that protects the network control to protect the system's security. AWS offers services that correspond to both the application layer and the network layer of the OSI reference model. The network layer firewall includes the network ACL, which controls the traffic at the subnet level within the VPC, and the security group, which controls the traffic at the resource level. The firewall that operates at the application layer is AWS WAF. The WAF designed to protect the web application by monitoring and controlling the HTTP and HTTPS traffic. The Route 53, the Resolver DNS firewall, operates mainly at the application layer and is used to prevent access to inappropriate sites by controlling the DNS query response. AWS Network Firewall operates at both the application and the network layer. It controls the traffic at the session and the packet level, provides a domain and the URL level control, and includes the intrusion detection and the prevention system. The AWS Shield protects the resources from the DDoS attacks and mainly operates at the network and the transport layer. The AWS Firewall Manager centrally manages all these firewall services. Another way to classify the firewall is the stateless and the stateful firewall. The stateful firewall keeps track of the state of the previous connections and automatically allows the packets that belong to the previously allowed traffic. This allows the firewall to maintain context for the traffic, where the context refers to the session state and the previous traffic patterns. The stateful firewall provides more advanced traffic filtering based on this context. The stateless firewall, on the other hand, evaluates each packet individually without considering the previous state or session. They apply predefined allow or deny rules to each packet, such as the rules based on the IP address or protocol. Because they do not track traffic context, the stateless firewalls are generally faster. In terms of the AWS services, the security groups and the WAFs are classified as the stateful firewall, while the network ACL are classified as the stateless firewall. You can control traffic using the security groups and the network ACL. The security groups are set as the instance level. In practice, they are attached to the instances, the ENI, the Elastic Network Interface. The network ACL are set at the subnet level. Using both security groups and the network ACL together provide a defense in depth. Typically, you use the security group first to implement allow list control for each instance, permitting only the necessary minimum traffic. Since security groups are stateful, managing the return traffic is generally easier. Then you can optionally configure network ACL as an additional defense layer for the entire subnet. For example, to add explicitly the deny rules for specific IP address. Since network ACLs are stateless, you need to manage both inbound and outbound rules explicitly. Again, the security groups are stateful firewall, while network ACLs are stateless firewall. The stateful means it remembers the previous traffic and makes dynamic decisions based on it. The stateless means it doesn't remember the previous traffic, so rules must be set in advance. The security groups control traffic at the instance level, specifically at the ENI attached to the instance. The network ACL controls traffic at subnet level. And by default, security groups allow internal traffic, and the network ACLs allow all traffic. Let me explain how security group and network ACL work with the ephemeral port. Ephemeral port are temporary port numbers assigned by the client operating system when it starts an outbound connection. Because security groups are stateful, if an outbound connection is allowed, the return traffic is automatically allowed. You don't need to do a specific inbound rule for the ephemeral port. In contrast, the network ACLs are stateless. They evaluate the inbound and outbound traffic independently. Allowing traffic in one direction doesn't automatically allow the return traffic, so you must explicitly create the rules to allow the return traffic. AWS WAF is a web application firewall as a free managed service. It helps protect your web application or APIs from a common web exploit like a SQL injection, the cross-site scripting. Unlike the network firewall operating at lower layers, the WAF works at the application layer. It inspects the content of the web request to detect and block malicious patterns and unwanted traffic. You can associate AWS WAF with the resources like the CloudFront, Application Load Balancer, API Gateway, and AppSync. Let's look briefly at how WAF works. The central component is the Web ACL, which contains a set of the rules for inspecting traffic. You associate the Web ACL with the resource you want to protect. When a request arrives at the resource, the WAF evaluates it against the rule in the Web ACL in order of priority. If a request matches a rule, the rule's action is taken, and the evaluation stops. If no rule matches, the default action for the Web ACL is applied. For reference, there are default quotas on the number of the Web ACL and rules, but these can often be increased upon the request. Any quotas mentioned in this course are example and subject to change. There are two main types of the rules, the managed rules and the custom rule. The managed rule groups are a predefined set of the rules curated and maintained by AWS or by security vendor on the AWS marketplace. They cover common threads like WASP top 10, known bad bots, the specific application vulnerability. The managed rules are easy to deploy and automatically updated. You can often enable the specific rule within a group. The custom rules are rules you create yourself based on the specific condition matching your application's needs. For example, you might create a custom rule to block traffic from the specific IP addresses or restrict access based on the geographic location. The AWS currently offers over 10 different AWS managed rules groups. And the WAF rules provide the flexible control by increasing the different request criteria. You can create the rules based on the request origin, the controlling the access by specific IP addresses, the CIDR block, or geographic location. The other common rule type inspects the various HTTP request element. The WAF can check the content of the size of the header, the query string, URI path, the request body, or the HTTP method using the string or regex matchings. The WAF also uses the web attack signature, often through the AWS managed rule groups, to detect known malicious patterns like the SQL injection, the cross-site scripting. And finally, rate-based rule tracks the frequency of the request from the single IP address over a short period, typically 5 minutes. If the rate exceeds the set limit, the WAF takes action like blocking, and which helps to mitigate the brute force attempts and certain DOS attacks. Let's look at the actions a rule can take when the request matches. The basic actions are allow, block, and count. The count which allows the request bad logs for monitoring. It's a good practice to first deploy new rules with the count actions to test them and ensure they don't block legitimate traffic before changing the action to the block. The WAF also offers the interactive actions like the capture and the challenge to help distinguish the human with the legitimate browser from the automated bot. And finally, here are the main AWS services you can associate AWS WAF with: the CloudFront, Application Load Balancer, API Gateway, and AppSync. By placing the WAF Web ACL in front of these resources, you can protect the application and APIs exposed through them from the various web-based threats. The AWS Network Firewall is a managed firewall that provides a detailed network protection for your VPC. It offers features similar to the traditional network firewall appliances, like the stateful packet inspection, the intrusion prevention system, and web filtering. It delivers them as a highly available and scalable managed service, reducing your operational burden. While AWS WAF focuses on the protecting web application traffic, the network firewall operates across the broader network layer to inspect and control traffic. And this table summarizes the key differences and the typical use case for the WAF and the network firewall. While WAF focuses on the protecting the web application traffic, the network firewall operates across the broader network layer to inspect and control traffic. The network firewall can inspect traffic across the various protocols like TCP, UDP, ICMP, and not just the HTTP. And generally, the WAF is the primary choice for protecting the web application and API against the common web exploit. The network firewall is suitable for broader network security needs such as the protecting the boundary of your VPC, the controlling the traffic flow between the different subnets, inspecting the traffic using the protocol other than HTTP and HTTPS, and providing the intrusion prevention system. And using both WAF and the network firewall together can provide the layered security for your application and VPC. The network firewall endpoints are deployed in the dedicated subnet within the VPC. A common approach is to use a dedicated inspection VPC to host the firewall endpoint. The transit gateway is then used to route traffic from the other VPC or on-premise network through this inspection VPC, forcing traffic through the network firewall. This centralized method simplifies the policy management and traffic inspection across the multiple VPC. And for high availability, endpoints are deployed across the multiple AZ and the service scales automatically. While deploying the firewall in each VPC is possible, the central inspection VPC model is often preferred for the unified management. This diagram shows a simple multi-AZ network firewall setup. The firewall endpoints are placed in the dedicated firewall subnet. To inspect the internet inbound traffic, the internet gateway is associated route table. The direct incoming traffic to firewall endpoint first. After inspection by the firewall, the allowed traffic is then routed onwards to its final destination subnet. The network firewall uses both the stateless and the stateful rule within its policy. The traffic first hits the stateless rule checked by the priority, which can pass, drop, and forward it for the stateful inspection. If forwarded, the stateful rule then checks the connection and can allow, drop, or alert. You can send firewall logs to the CloudWatch logs or S3 or Kinesis data firehouse. The firewall policy holds the rules for checking network traffic. The stateless rule checks individual packets similar to network ACL. Based on the IP address, the port, and the protocol, the action can be the pass, drop, or forward the packet to the stateful rule for more checks. And these rules use priority order. The first rule must win, and very fast for the simple allow or deny decisions. The stateful rule tracks entire network connection for deeper inspection, like advanced security groups. They include the 5-tuple rule, check based on the source destination IP address, the source destination port, and the protocol with action like a pass, drop, or alert. And the domain name filtering let you allow or block access to specific website domain, and use the suricata, the compatible signature, to find protect against known threats like malware or exploit within the traffic itself. And you can use the AWS managed or your own custom IPS rule. The stateful rules also use priority order. And if the traffic is forwarded from the stateless engine but doesn't match any specific stateful rule, the default action for stateful traffic is applied, and which often allows the established connection follow. AWS Shield is a managed service protecting your application from DDoS attacks. The DDoS attacks try to make the service unavailable by flooding them with too much traffic from many sources. Since some DDoS traffic can look like a normal traffic, the standard firewall may not be enough, so requiring the specialized protection like AWS Shield. The AWS Shield detects attacks by looking for the abnormal traffic pattern at the network, transport, and application layer. And it protects against a known attack method and also uses techniques like traffic flow analysis to detect new or previously unknown threat pattern. The AWS Shield comes into two tiers, the Shield Standard and the Shield Advanced. The Shield Standard provides automatic protection to all AWS customers at no additional charges. You don't need to do anything to enable it or configure anything specific. It's always active on your account. It protects your AWS resources against the most common network layer and the transport layer DDoS attacks. The Shield Standard works automatically at AWS edge location using the built-in traffic monitoring and automatic mitigation techniques to detect and reduce the impact of these attacks. The Shield Advanced is a pet service offering the stronger protection against more sophisticated DDoS attacks. It is designed for business-critical applications that need a higher level of protection. You need to subscribe to use Shield Advanced. It provides additional capability on top of Shield Standard. A key benefit is help with detecting the application layer DDoS attacks, such as the HTTP floods. This requires integration with WAF. The cost of WAF are included. And here the types of the resources supported with the Shield Advanced. Unlike Shield Standard, you must explicitly select which specific resources. The Shield Advanced also gives you a 24/7 access to the DDoS response team, the DRT. You can contact them for help during the suspected DDoS attacks. Additionally, it provides health-based detection. This feature monitors the health of your resources, for example, the application responsiveness or error rate on the CloudWatch metrics. And if it detects the performance degradation that indicates DDoS attacks, it can automatically notify the DRT. The DDoS attacks can target various layers of your infrastructure, and this diagram shows an OSI model and the corresponding common attack types. The AWS recommends using the multiple services together to achieve the defense in depth, rather than relying on the single service. The defenses are often split into the infrastructure and application layer. The infrastructure layer attacks target network bandwidth or server connections. Besides AWS Shield, other services help mitigate these attacks. The Route 53 is inherently resilient to the DNS flood. The ELB distributes traffic, avoid a single point of failure. Security groups and the network ACL reduce the attack's surface by restricting the traffic based on the IP port route, though they have limit against high-volume attack alone. The application layer attacks aim to exhaust application resources. The key defense include the AWS WAF inspect HTTP requests to block web exploit and apply the rate limiting. The CloudFront absorbs traffic at the edge and offer access control. The API gateway provides a request throttling. The ALB distributes load effectively. The auto-scaling adds capacity for traffic surges, but blocking attack traffic fast with WAF and Shield is vital to control cost. The AWS Firewall Manager is a service that centrally manages the firewall service across the multiple accounts. The Firewall Manager supports WAF, the AWS Shield Advanced, the Security Group, the Network Firewall, the Route 53's DNS Firewall, and even third-party firewall. It allows you to manage the multiple accounts and the resources from one place. And when using the Firewall Manager, you need to be part of the AWS organization and have AWS Config enabled. Since it works with the AWS Config, it can also detect the compliance with the config rules. As mentioned before, the Firewall Manager is designed to work with the AWS organizations. The using organization is the prerequisite. You can apply firewall policy selectively based on the organizational unit, the specific account, or resources identified tags, and it automatically applies your defined security policy when new accounts are added to the organization, or when new resources that match the policy scope are created. And this helps to continuously monitor compliance with your security policy across the organization and identify the non-compliant resources. The Firewall Manager can also send its findings to Security Hub, and this centralizes the security findings from various resources. And this table shows what the different firewall service can do. You don't need to remember every detail, but the most important point is that each firewall service works in a different way. It's very hard to understand all the differences, and this is where the Firewall Manager comes in. Its main purpose is to give you one central place to manage the rules for different firewalls across all your accounts. Let's explain host-based firewall. A host-based firewall runs directly on the individual computer and controls inbound and outbound traffic on the host. And this concept is different from the network firewall, which usually sits at the network boundary and controls traffic for the entire network segment. In AWS, the host-based firewall are not provided as a managed service, and you need to manage your host-based firewall by your responsibility, and which is managed directly within the operating system on each host. On EC2 instances, which run the standard Linux or Windows OS, you can use the built-in firewall, such as the IP table or NF table on the Linux, or the Windows Defender firewall. Alternatively, you might install the third-party security software that includes the host-based firewall feature. A VPN, the Virtual Private Network, is a technology that creates a virtual private communication network over the Internet. It enables secure communication without relying on the physical connections. So let me explain the key technologies that support VPN. A VPN creates a virtual tunnel between two locations. Even without a direct connection, it enables private network between them. Encapsulation makes context less visible from externally by wrapping in another protocol, and this makes the content secret. It supports encryption protocols like SSL and IPsec, which makes the data package unreadable. The authentication systems like SSO, the single sign-on, are used to ensure that only authorized user can set the data through the VPN. Since the VPN work over the internet, they are affected by the internet bandwidth. For example, in the areas with heavy usage, there is a risk of slower communications. Therefore, in the mission-critical system, you should consider deploying a dedicated line connections. There are two VPN connection methods, AWS Client VPN and Site-to-Site VPN. I will introduce each of them on the following pages. The AWS Client VPN, a VPN service that allows individual clients to connect securely to AWS. It can scale automatically based on the number of users, adjusting a flexibility to change in demand. The AWS Client VPN provides an open VPN-based VPN. The client can access AWS resources by installing the software on their devices. It's used in the use case where, for example, the remote workers access the AWS cloud. The client VPN supports Active Directory, the federation authentication, and the certificate-based authentication. And when deploying it, you can configure the VPN endpoint and use an ENI to exchange data between the client and AWS. And this allows you to manage access to both on-premises and the AWS resources. AWS Site-to-Site VPN is a VPN service that connects the on-premise data to VPN. And it supports IPsec to secure communications. It connects the customer gateway to the virtual private gateway. The AWS Global Accelerator allows you to configure an accelerated site-to-site VPN. This can improve the network performance by up to 60%. The VPN Cloud Hub allows you to establish a VPN across the multiple sites. You can connect the multiple customer gateway to a single virtual private gateway. And it's also possible to place several customer gateways within the one on-premise network to configure redundant site-to-site VPN. As the number of site-to-site VPN connections increases, so will the cost. And here I will introduce the types of VPN, the Open VPN and IPsec VPN. The Open VPN works at the transport layer, and it's easy to set up, install software on your devices, making it popular for individual devices and smaller networks. And in contrast, the IPsec VPN operates at the network layer and is directly integrated with the Internet Protocol. Since it's relatively complex to set up, so it's commonly used in the corporate network. The Open VPN is categorized as a software VPN, and IPsec VPN can be categorized as both software and hardware VPN. Since the hardware VPN needs a router or a VPN server, it makes less flexibility compared to software VPN. Next, I'll introduce AWS Direct Connect. Direct Connect is a dedicated connection service. It connects your customer router to Direct Connect router using the fiber optic cable. And this allows you to connect the AWS without using an internet service provider, providing the private and the dedicated connections. The Direct Connect offers two types of connection, the dedicated connection and the hosted connections. A dedicated connection uses the physical Ethernet associated with a single account. The supported port speeds are shown here. A hosted connection are operated by the AWS Direct Connect partner. The Direct Connect partners include, for example, the telecom companies like the AT&T, Verizon, and NTT. You can select the port speed depending on the partner. I will introduce the redundancy architecture using the VPN and Direct Connect. You can use a VPN as a backup for Direct Connect. And if the Direct Connect connection fails, the VPN will serve as a fallback. It's expensive to establish two Direct Connect connections, so to use the Direct Connection primarily, with a VPN as a backup in case of failure. And it recommends to set the speed as close as possible during the normal and failover conditions. For example, configure the VPN to handle 1.25 Gbps and the Direct Connect to handle the 1 Gbps. You can choose the level of resilience for your Direct Connect connections. You can choose from the maximum resilience, the high resilience, and the development and testing. The maximum resilience duplicates your Direct Connect across the multiple locations and also within the single location. The high resilience duplicates across the multiple locations but not within the single location. And the development and testing does not provide redundancy between the locations. To use Direct Connect, you need to create the virtual interfaces, the VIF. And these are three types of virtual interfaces, the private, the public, and the transit virtual interfaces. The private virtual interface allows for the connection via the private IP address. The public virtual interface is used for accessing the public AWS services such as S3 and EC2. And a transit virtual interface is associated with a transit gateway through a Direct Connect gateway. The public VIF connects the public endpoint, which poses the security risk. It also provides access via public endpoint, which means it can be subject to network congestion and the effort of users' traffic. The transit gateway serves as the central hub that simplifies the management and of the multiple connections, making of the transit VIF the straightforward solution for connectivity. The public IP address is supported only by public VIF. Additionally, you can connect to the multiple VPC with private VIF and the transit VIF. To connect the multiple VPC with the private VIF, you need the VPC pairing. Next, I will introduce Direct Connect Gateway. The Direct Connect gateways allow the users to connect multiple VPC across the different AWS regions to their on-premise network through a single gateway. By using this gateway, the network architecture is simplified, making the data transfer between regions easier. With Direct Connect Gateway, you can establish a connection across the different regions. The VPCs connected through the Direct Connect Gateway cannot communicate directly with each other. The Direct Connect Gateway is designed to connect an on-premise network to multiple VPC, but it doesn't support routing between VPC. To enable direct communication between the VPC, you need to use a transit gateway. This allows the VPC to communicate directly with each other. Additionally, since the Direct Connect Gateway can connect up to the 20 VPC, if you need to connect more than that, the Transit Gateway is also the appropriate option. And you can also connect a single direct connect gateway to multiple transit gateway across different regions. Next, I will explain LAG. The LAG, the link aggregation group, is the logical interface that aggregates the multiple connections and treats them as single connections. With LAG, you can increase the available bandwidth, achieve redundancy, and enable load balancing across the connections. The available speeds are 100 Gbps, 10 Gbps, and 1 Gbps, but all aggregated connections must have the same speed. They also use the same direct connect endpoint. And finally, I will explain the pricing for direct connect. The direct connect charges are based on the port hours and the data transfer. The port hours are charged at a different rate depending on the bandwidth and the connection type. The billing starts either 19 days after the connection is created or when the connection between the direct connect endpoint and the customer router is established, whichever comes first. For data transfer with a private VIP, the charges apply to the AWS account transferring the data. For public VIP, the charges apply to the owner of the resources being accessed. And here I will introduce the Broader Gateway Protocol, BGP. The BGP is a protocol used for exchanging routing information between different networks on the Internet. It's primarily routing the protocol that makes up the entire Internet, allowing for the detailed control over the network routing. The BGP is known as the Path Vector Protocol, where each BGP speaker maintains a list of AS paths that are reachable to them. The information is exchanged with the neighboring BGP speakers. For example, the BGP speaker 1 holds a list of AS paths to connect to the AS2. The autonomous systems AS refers to the network that forms the part of the Internet. This is managed by the Internet Service Provider or corporations. AWS Direct Connect can perform the routing between the client network and AWS using the BGP. Then I will introduce to the concept of the Content Delivery Network, CDN. A CDN places a cache between the client and the origin server to offload the origin and improve the response time to the client. The AWS offers the CloudFront as its CDN service. And without the cache, requests from the client are sent directly to the origin server. Then the origin server responds directly to the client. In such cases, if a large number of the requests are sent by the client, it can lead to the high load on the origin server and a slower response to the client. By strategically placing the cache, the load on the origin can be reduced and the response times can be improved. The interaction between the client and the CDN are termed as the viewer request and the viewer response, while the interaction between the CloudFront and the origin are referred to the origin's request and the origin's response. Now I will introduce the AWS global infrastructure, the edge locations, and the point of presence, the POPs. As of now, there are over 600 POPs, the 400 edge locations, and the 13 region edge globally. The POPs are physical locations that transfer traffic between end user and the AWS data center. By hosting the CDN service at the edge location, you can reduce latency effectively. Since the CDN services are hosted at the edge location, These are also referred to as edge location services. And this is for your reference regarding the AWS resources and their locations. For example, RDS and EC2 are deployed within the VPC. The S3, while the global service, stores its data in specific region. The services that are located in the region are referred to as the regional services. On the other hand, the CloudFront and the Route 53, which offer globally, are referred to as the global service. So let me introduce to the Amazon CloudFront. The Amazon CloudFront is an advanced CDN service. It delivers the cached content from the global edge locations. The CloudFront offers the fast distributed delivery, the DDoS protection using the WAF and the AWS Shield, and the reporting features. Additionally, the pricing is based on the amount of the data transferred and the number of the requests, making it as the pay-as-you-go service. In CloudFront, it's important to control caching effectively. With compressing the content, you can optimize the communication speed and reduce cost. And it's also important to set the cache retention period. If the time to live (TTL) of the cache is too long, the outdated content remains on the CloudFront even after the update at the origin, preventing the latest content from being delivered to the client. On the other hand, if the TTL is too short, it returns in a lot of requests to the origin server. A cache hit occurs when CloudFront returns cached content in response to the client request. In CloudFront, it's important to set the appropriate cache retention period based on the request types and the cache hit rate. The CloudFront charges for the data transfer, the calls to CloudFront functions, and the requests to the Lambda functions. If you configure an AWS resources at the origin, there are no data transfer charges between the CloudFront and the origin. However, if you use an external resources as origin, the data transfer charges between the CloudFront and the origin will apply. Next, I'll introduce the security features of CloudFront. The CloudFront has SSL certificate enabled by default, which encrypts the communication between the client and the CloudFront and between CloudFront and the origin server. The CloudFront also supports WAF and AWS Shield. The AWS Shield protects your resources from the DDoS attacks. And for access control, the CloudFront supports restriction based on the geographic location and the IP address. If the origin is the S3 bucket, you can set the S3 bucket policy to allow requests only from the OSC or OAI. And if the origin is ALB, you can configure it to route request only when the specific HTTP header is included. I will explain the detailed setting on the next page. The CloudFront also supports signed URL and signed cookie. So let's explain the detail of the OAI and OSC. Both OAI and OSC are features used to prevent direct access to your S3 bucket. They ensure users access your S3 content only through your CloudFront distribution, not by using the S3 directory. The OAI is a legacy method for doing this. You would configure your cloud distribution to use a special OAI identity when accessing to the S3 origin. Then, you would modify the S3 bucket policy to allow access specifically from the OAI principal. However, the OAI had several limitations as listed here. The key limitation included not being able to access S3 object encrypted with the SSE KMS, and being designed mainly for GET object request with limited support for the other method like a put or post. The OSC was introduced more recently as a successor to OAI. It overcomes the previous limitation, offering the better security and improved functionality. Using OSC is now recommended for the restricting the S3 origin access to the cloud front. Here is a sample S3 bucket policy that allows request when using the OSC. Therefore, the principal, we specify the CloudFront service principal, and this means we are allowing the request that comes from the CloudFront service itself. A key difference from the older method is the OSC uses the service principals, not a special virtual user identity like OAI did. And importantly, we also use a condition element with the AWS source ARN key. And this adds a restricting to the allow statement. It ensures the policy only permit access if the request comes exactly from the ARN of your specific CloudFront distribution, that is configured to use OSC. And this prevents the other cloud distribution from accessing your bucket. So next, let's look at the example where the origin is application load balancer. The routing is possible only when the request includes a specified HTTP header. In this example, the requests are routed to the target group 1 only if they contain a custom header named X custom header with the value header value. Conversely, the requests that do not include this custom header cannot be routed to the target group. Next, I will introduce signed URL. The signed URL are used to grant access to specific users only. And here is an example of the signed URL. A signed URL consists of the CloudFront distribution, the file path, the expiration parameter, the signature parameter, and the key pair. As I mentioned in the S3 chapter, signed URL includes the expiration, and once the expiration is reached, the URL becomes invalid. Next, I will introduce the signed cookies. The signed cookies are evaluated as the CloudFront edge locations. Using the signed cookies, you can access private content only if the cookie is valid, and it's associated with the specific URL. The signed cookies include a key pair, a signature, and policy. The policy can specify the URL, the expiration, and even a range of IP addresses. And here is a summary comparing the signed URL and the signed cookies. And both methods provide a temporary, secure access to your private content, but they work differently. The signed URL are best when you need to control access to individual file. Each file gets a unique temporary URL to contain the access credential. The signed cookie, on the other hand, are more convenient when you want to grant access to multiple files or entire directory paths at once using the standard URL. For example, in a scenario like the membership website or video streaming service where user needs to access to many different private files, the signed cookies are often easier to manage for the application and allow you to keep using the simple standard URLs for your content. Next, I will introduce edge functions. The edge functions run at edge locations. With edge functions, you can customize how CloudFront distributes and handle HTTP requests and responses. The edge function performs actions on requests and responses passing through the CloudFront. For example, you can write code for basic authentication and authorization, or to generate HTTP responses. The purpose of the CloudFront is to reduce the load on the origin server. So by executing the process at the CloudFront instead of origin, you can further reduce the load on the origin server. There are two types of edge functions, the CloudFront functions and the Lambda at edge. The CloudFront functions support JavaScript, while the Lambda at edge supports the Node.js and Python. Generally, the CloudFront functions are used for the simpler task, while a Lambda is used for more complex process. The CloudFront function typically handle the request coming from the viewers, and the Lambda at edge can handle the wider range of use cases, serving both viewers and the origin. And compared to regular Lambda functions, the Lambda at edge function have shorter execution times and require less storages. And this means that Lambda at edge has less processing power than regular Lambda functions. And this is a sample of Lambda at edge. And this is sample trigger user authentication for the viewer request event. The request is executed only if the authentication header is correct. The next is Amazon Route 53. The Route 53 is a highly available and highly scalable cloud-based DNS service. It effectively routes the end-user request to the resources on AWS on-premises. You can use Route 53 to register and manage the domain names, supporting a wide variety of top-level domains. The DNS routing is a core function. The Route 53 resolves the domain name into the IP addresses or other record types that the browser application needs to connect to your service. Route 53 also offers health checks to monitor if your application endpoints are operating correctly. If an endpoint becomes unhealthy, the Route 53 can use the DNS routing policy to automatically stop sending traffic to the unhealthy resources and direct the user only to the healthiest one, and this is often called the DNS failover. And these are the records used by Route 53. In particular, alias records are the AWS-specific record type that can be mapped to AWS resources. When the IP address of AWS resource changes, the DNS is automatically updated. Amazon Route 53 is a DNS service. It offers a domain resolution, DNS routing, and health checking capability. And not only them, but it also offers a lot of functions such as the policy-based routing beyond ordinary DNS services. Route 53 is an edge location service that provides high availability and performance. I will explain how DNS queries are resolved in Route 53. First, the end user types the domain name www.example.com into their browser. The user's computer queries a DNS resolver to convert the domain name into an IP address. The DNS resolver starts by querying the DNS root name server, requesting the information about the .com top-level domain. The domain names consist of the several parts, with .com being the highest level in this example. The name resolution occurs in the order from the highest level domain, such as .com, .co.jp, or .organizations. The root name server directs to the top-level domain name server, which in case manages the .com domain. The top-level domain name server further forwards the query to the Route 53 name server, specifically to the servers managing the example.com domain. The Route 53 name server returns the IP address, the 192.168 0.2.44 for requested domain name www.example.com to the DNS resolver. The DNS resolver then sends this IP address back to the end user's computer. Then the user browser uses this IP address to connect to the web server. The Route 53 offers several routing policies. The simple routing policy maps IP address directly to the domain names on the one-to-one basis. The failover routing policy, in an active and passive setup, this policy routes traffic to the secondary server's IP address in the event of failure. The geolocation routing policy routes traffic based on the user's location. Geo-proximity routing policy directs traffic to the nearest server when multiple servers are distributed across the various locations. A latency routing policy routes traffic to the location with the lowest latency. The IP-based routing policy routes traffic based on the IP address and the user's location. And the multi-value answer routing policy, which accesses servers almost randomly when the multiple servers are distributed. And this is typically useful for the load balancing. And the weighted routing policy, which determines the routing frequency based on the specified weight or time proportions. Starting on the next page, I will present several important features regarding these policies. A geolocation routing policy and the geo-proximity routing are similar, but have the slight differences in the use case and the settings. On the left side, the geolocation routing routes the traffic based on the user's location. For example, the users in the Tokyo are directed to the resource in the Tokyo region, while users in the US are directed to the resource in the North Virginia region. There are also use cases like restricting the access to the Tokyo-specific resources only to the users from Japan, and routing access from the abroad to the secondary server. The geo-proximity routing considers the location of both the client and the resource when routing. It routes the traffic based on the proximity, meaning it directs the clients to the nearest available resources. Next, the multi-value answer routing returns the multiple IP addresses chosen randomly from the list of the healthy resources for a single DNS name. It improves the availability and provides a simple load distribution at the DNS level. If a client cannot reach one IP, it might try another from the list. It's not a replacement for the elastic load balancer. The weighted routing policy distributes traffic across the multiple resources based on the weight you assign to each record. And the use case includes the gradual rollout or the routing traffic based on the server capacity. You can improve the security with the routing policy. The multi-value answer routing policy allows Route 53 to respond to DNS query using up to 8 randomly selected healthy records. The policy doesn't return IP address that fail health check, which ensures that routing is only to the resources that are functioning correctly, thus improving the security and availability. The geolocation routing policy routes traffic based on the user's location. It can block access from the outside the service region, thereby preventing the unauthorized access and the potential attacks from outside the service area. The Route 53 resolver handles the DNS query resolution within your VPC and enables the DNS resolution between your VPC and on-premise networks. The Route 53 resolver provides a default DNS capability for your VPC. The resource inside the VPC automatically uses the resolver, sometimes called the Amazon-provided DNS, to resolve the public domain names and the names defined in your Route 53 private hosted zone. Originally just a basic DNS server for VPC, AWS enhanced these capabilities and branded them as the Route 53 Resolver to better support a hybrid cloud environment. The Route 53 Resolver enables the hybrid DNS through the endpoint. The inbound endpoint allows your on-premises system to query and resolve the domain names hosted within your VPC. The outbound endpoint, on the other hand, allows the system within your VPC to forward the DNS query to your on-premise DNS server. With Route 53 Resolver, you can also configure resolver rules. And these rules allow you to conditionally forward the DNS query for specific domain names to the IP addresses of the designated DNS server, such as your on-premise DNS server, instead of using the default VPC resolver. The Route 53 resolver resolves the DNS query within the VPC. It also functions as the forwarder, transferring the DNS query to name server. For publicly available domain on the Internet, it performs a recursive query to the public name server. You can configure the hybrid DNS access with on-premise side by setting up the inbound endpoint, outbound endpoint, and the outbound rules. The image shows the placement of the DNS server in the hybrid environment. It resolves a query from the AWS to on-premises name server across two availability zone redundancy. The Route 53 Resolver, the DNS firewall, is a security feature of the Route 53 Resolver. It filters outbound DNS queries from your VPC, allowing you to block or monitor access to known The Route 53 Resolver's DNS firewall is a security feature of Route 53 Resolver. It filters outbound DNS queries from your VPC, allowing you to block or monitor access to known malicious domain or domains disallowed by your organization security policy. Within the DNS firewall, you define the rules that specify how to filter DNS query. The rules evaluate the query based on whether the requested domain matches a specific domain list, and then determine the action. The available actions are allowed, block, or allowed. The rules have priority, and the action of the first matching rule is applied. The rules are defined by domain list. You can use AWS Managed Domain List, which are maintained by AWS based on the threat intelligence. Using these helps you to easily protect against the current known threat. You can also create your own custom domain list based on your policy. The Elastic Load Balancing is a managed load balancing service. It automatically distributes incoming network traffic across the multiple targets. It distributes the incoming load evenly across the multiple targets, reducing the burden on any single target. It includes health checks to constantly monitor the health of the target and send traffic only to those responding correctly, and this prevents the downtime and increases the overall availability of your service. The ELB provides a single point of access, which is usually a DNS name for your clients, and this allows you to add or remove backend target without the client needing to change how they connect. From the outside, it looks like a single endpoint. ELB often work together with AWS autoscaling. When traffic to your application increases, the autoscaling can automatically add more backend target, and ELB will send traffic to the healthy instances. Currently, there are three types of load balancer: the application load balancer, network load balancer, and the gateway load balancer. And now the classic load balancer are out of date, and it's recommended to use application load balancer, network load balancer, and gateway load balancer. The ALB works at the layer 7, the application layer. It is used to control the HTTP traffic and provide several security features. And NLB operates at the layer 4, the network layer. It is high performance and doesn't require pre-warming. And the GWLB is primarily used with the third-party intrusion detection system. And there are two key components in configuring the ELB, the listener and the target group. A listener checks and receives traffic at the load balancer, and you can specify protocol and port in the listener and set rules and action. For example, you can configure it to forward traffic from the specific source IP address to the target and respond with an error to the other traffic. And you can set the multiple listeners on the single load balancer. And the targets can include EC2 instances, ECS, IP addresses, or Lambda functions. You can also configure health checks and the routing algorithm. The ALB operates at the application layer, so it's designed to control the HTTP and HTTPS traffic. It allows you to configure the detailed listener rules. Its targets can be the EC2 instance, IP addresses, Lambda function, or containers. A NLB that operates at the network layer, controlling the TCP, UDP, and TLS traffic. The protocol used for GWLB is fixed to Junave. Its listener configuration is also fixed, specifically for handling the Junave traffic, and often used with the security appliances. This table summarizes security features provided by ELB. Since ALB operates at the application layer, the rich traffic management is possible. Integrated with WAF and user authentication and detailed access log and applying the security groups are possible. And NLB and GWLB operates at the network and the transport layer, so they are limited to more low-level features. The detail of these features will be introduced in the later chapter covering each service. And here, we will introduce features specific to the ELB. Both ALB and NLB support SSL TLS termination. This encrypts the traffic between the client and the load balancer, requiring the certificate on the listener. And it's recommended to use the AWS Certificate Manager, ACM, because it's for free and full managed and automatically renewing the certificate. To also encrypt the traffic between the ELB and the backend target like EC2 instance, you must install the certificates on those targets and set the target group protocol to HTTPS or TLS. Next, the sticky session or session affinity is a load balancer feature ensuring the requests from the same client consistently go to the same backend target during the session instead of being distributed randomly. And this is mainly needed for the stateful application that store users' session information like the login status or shopping cart. Without stickiness, the user might hit different servers and lose their session data. How stickiness works depends on the load balancer. The ALB typically uses the HTTP cookies. The NLB, operating at the layer 4, often uses the client source IP address, and the GWLB uses connection hashing to keep traffic flow going to the same virtual appliance. The network load balancer has an ENI with private IP address. For internet-facing NLB, you can assign the static elastic IP addresses to these ENI. The static IP makes it easier for you to configure the firewall rule based on the IP address. In contrast, the application load balancer has a dynamic public IP address, so you should always use the ALB's DNS name. And if you need the static IP address in front of ALB, it recommends to use the global accelerator. And remember, the NLB work at the network transport layer, so placing it directly in front of the ALB isn't always the most efficient use of its feature. Next, I will introduce the health checks. As I mentioned in the EC2 health check, the ELB health check is a TCP three-way handwave check and a HTTP status check. And this is a summary of the health check feature of the ELB and Route 53. While Route 53 provides health checks for any resources, both inside and outside of AWS, the ELB performed health checks only on the registered instances. Route 53 conducts health checks based on the request timeout and the failure rate. On the other hand, ELB performed health checks based on the HTTP code, response timeout, and the HTTP response. For cost, the Route 53 charges per health check, whereas there are no additional charges for health checks with ELB. Additionally, Route 53 manages the DNS failover, and you can also use Route 53 in conjunction with ELB. Amazon API Gateway is a service that acts as the interface for web application. It's free managed service that makes it easy to create, secure, publish, and monitor APIs. The API Gateway supports HTTP APIs, the REST APIs, and WebSocket APIs. API Gateway receives events from the client and creates requests for the API. It's often used with Lambda, which sends requests to API Gateway to be transferred to AWS resources. I will introduce the component of API Gateway. The API Gateway is associated with endpoint. Through these endpoints, the client can access API resources. The endpoints are created for each stage. The stages are used to separate environment, like development and production. And you can set quotas for each stage by combining the usage plans with the stage. And there are three types of endpoint. The edge-optimized API endpoints route through the global edge locations, making them useful for users around the world. The regional API endpoints are useful when users are concentrated in a specific region. The private API endpoints are used when accessing the API from the specific VPC. Next, I will explain some metrics of API Gateway. The throttling is the maximum number of the requests API Gateway can handle. If this limit is exceeded, the request will be throttled. The throttling means controlling requests when they exceed the threshold. By default, the throttling is set to the 10,000 requests per region, but you can apply to increase this limit. You can also set quotas for each API key. Additionally, you can track metrics like error rate and latency. With monitoring these metrics, you can adjust your architecture design. Now I will explain how to integrate the front end with the back end. The Lambda is the most commonly used integration. A Lambda function handles the request from the client and sends them to the backend. It also returns the response from the backend to API Gateway. The HTTP integration is used when the backend is based on HTTP. The private integration is used to send a request to HTTP resources inside the VPC. The mock integration doesn't connect to an actual backend resource. Instead, it returns a fixed response and is mainly used for testing. In API Gateway, you can customize the mapping definitions. If the request format is different, you can customize the mapping template to convert it into formats that the resource can accept. And this is an architecture where the client sends data through API gateway and Lambda to write into DynamoDB. Then you can convert the query parameter into JSON to write into DynamoDB. Similarly, you can convert the response from JSON to XML. And here are the setup steps for API gateway. The first, select the type of API gateway. You can choose from the HTTP API, WebSocket API, or REST API. Next, specify the API name and the endpoint type. And for the API method, you can use the common method like the one listed here. Then you can also set the integration type. A typical service to integrate with API gateway is Lambda, which can handle the request it receives. Before deploying, you can run a test by specifying the query strings for the API. And finally, when you deploy, an endpoint URL is generated. I will introduce the usage plans. A usage plan sets the number of requests and the throttling limit for each API key. It is used to give different access level to multiple applications. For example, you can allow free plan users to make 1,000 API calls per month, while paid plan users can make 10,000 calls. This helps prevent excessive use of the resources and maintain preset usage level. Now I will talk about improving the performance in API gateway. And you can improve performance by enabling the caching. And this allows API gateway to reuse responses from the backend for the same request. And this reduces latency and offload on the backend. And however, you will be charged based on the caching capacity. The API gateway supports encoding, which compress the data size and reduce latency during the data transfer, and it automatically compresses response payload using gzip. Next, I will introduce the security feature of API gateway. That you can install the client certificate in API gateway, and not only that, you can also create and verify this certificate. Additionally, you can set resource-based policies. The authentication method in API gateway includes the IAM, the Cognito Authorizer, and the Lambda Authorizer. You can restrict the execution role of API to specific IAM user. With the Cognito Authorizer, the client includes a token obtained through the sign-in via the Cognito user pool in the authentication header when making the request to API gateway. The Lambda Authenticator allows for the custom authentication or the use of third-party authentication. The pricing is based on the number of API calls received and the amount of data transferred. There are no charges for data transfer with private APIs. To understand how API gateway works, I will explain serverless architecture using API gateway, Lambda, and DynamoDB. For example, assume we are building a book-selling application. Through this app, you can add and get information on books in the database. First, the client application input data for a new book. The application converts the data format and sends it as a POST request to the API gateway. API gateway receives the request and routes it into the Lambda functions. The Lambda function passes the JSON data from the request and creates a new record in DynamoDB. The first client will create a JSON file. The book information includes an ID, which is considered as the primary key, and the book title, the author, the genre, and the price. And there is an empty table in DynamoDB at the initial state. The client will send a POST request and the API gateway received it, And this includes the endpoint of the API gateway. The JSON object also includes the request body. And once the request is sent, it will route to DynamoDB from the Lambda function, and the data is written into the DynamoDB. Next, assume we will get information about a book from DynamoDB. The client will get information about a specific book through the application. The application sends the book ID to the API gateway as a GET request. Upon receiving this request, API gateway routes it to the appropriate Lambda functions. The Lambda function passes the book ID from the request and fetches the book record from DynamoDB. And finally, the data is returned to the client via the API gateway. The client will send a GET request to the get the information with the book / the get / 123. It means the get data with the ID of 123 from the DynamoDB table named the books. Once DynamoDB receives the request, it sends the response back to the client. I will explain the security feature of the API gateway. It's a common practice to include the security token in the request. This allows the server to associate each request with the appropriate client. And this is an example of HTTP request with API token. The API gateway is highly scalable. When a large number of requests are sent from the client, normally the 429 error is returned, but API gateway automatically scales to handle the request. The API gateway has maximum processing count called the throttling. By default, it can handle 10,000 request rate per second and a burst of 50,000 requests. Moreover, you can increase this throttle count. And here I will introduce the exponential backup. The exponential backup is used to handle the throttling of API requests. When throttling error occurs, it's designed to automatically retry sending requests from the application to the server. The SDK natively includes the exponential backup as its retry logic, so you don't need to manage the retry logic yourself. Exponential backup works by waiting a certain amount of time after detecting the error before sending the request. If an error is detected again, it increases the wait time before resending, and this helps to reduce the unnecessary request as much as possible. I will also introduce the definition of API. The API, or Application Programming Interface, refers to the exposing the part of the application to the Internet, which is shared with third-party applications. By using API, you can eliminate developing the application from scratch, which leads to cost reductions. In addition, API can enhance security and enable retrieval of the latest data from external applications. Additionally, I will introduce REST. The REST is a set of design principles suitable for coordinating the multiple software components in distributed system. It has the characteristics listed here. The API gateway supports not only HTTP API, but also REST API. The next is Identity and Access Management. In this chapter, I will introduce IAM, Directory Service, and Amazon Cognito. The IAM is one of the most important services. It's also the service that most often appears on the security exam. IAM, or Identity and Access Management, is a service that manages access permission for AWS resources and accounts that access them. With IAM, you can control fine-grained access, which enhances security across your AWS account. When you create an AWS account, a root user is created, but typically you sign in as IAM user. An IAM user has specific permission to perform certain action on specific resources. IAM also allows you to set permissions on resources as well as users. And this allows for security design such as the laws of least privilege. Let me introduce the element of IAM. The IAM consists of the components such as IAM policy, users, the groups, and the roles. I will explain each of these elements on the following pages. Now first, let's talk about IAM user. An IAM user is an identity defined in IAM. There are two authentication methods for IAM users, ID and password, and access key and secret key. The ID and password are used to log into the console, while key pairs are used to authenticate applications and APIs. To enhance security, you can enable MFA, the multi-factor authentication. While IDs and passwords are stored information, the key pairs are more vulnerable to exposure, so it's recommended to set up the additional layer of authentication. When storing the key pairs, follow the principle of the least privilege, avoid hard-coding key pairs, and instead use environment variables. And you should also restrict IP addresses for users who have access to key pair, rotate the key pair regularly, and periodically check the key pair usage. Next, an IAM group is a collection of IAM users. You can assign the permission to an IAM group, which then applies to all users in the group. And this approach simplifies access management and minimizes the risk of both the over-privileging and under-privileging. As your organization grows and the number of IAM users increases, the managing individual users can become time-consuming. It's recommended to organize IAM group according to the appropriate roles or teams. The root user is the account holder who signs in using the email address and password set up when the AWS account was created. Root users have very powerful privilege. Unless restricted by the SCP in AWS Organizations, the root user can perform any action on the AWS account. Therefore, it is generally recommended to delegate the privilege to the IAM user and sign in as an IAM user instead. Only the root user can perform specific tasks such as the configuring the AWS account, the managing the billing setting, and suspending the account. The privileges of the root user have been updated several times in the past. For example, as of now, the root user can delegate the support plan changes to an IAM user. And please refer to the official document for the latest update. An IAM policy is a set of rules that define what actions are permitted on which resources, and there are several ways to classify IAM policy. The one classification is based on the attachment target, the identity-based policy, in which are attached to the entities like users and groups, and the resource-based policy, which are attached directly to the resources. Another classification is by customization method, inline policy, and managed policy. The inline policy are directly embedded into the IAM entity and used when you want to assign the specific permission to a particular entity. When the entity is deleted, the inline policy is also deleted. And there are two types of managed policy, the AWS managed policy, and which are predefined by AWS, and the customer managed policy, which are customized and created by user. And in general, AWS managed policies are easier to manage and recommended over inline policy. The IAM policy are written in the JSON format. The structure of the IAM policy is outlined here. The current policy version in the 2012, the 10, and 17. For reference, the previous version was released on the October 17th, 2008, and the current version allows for the more functionality compared to the older one. The statement can contain the multiple conditions. Since an IAM policy may define the several permissions, there are often multiple blocks of the curly bracket under the statement. The SID is any identifier you choose. For example, in this policy, the EC2 full access is used to identify the policy as one that allows all the action on the EC2 instance. For effect, you can specify allow or deny, and the principal is the subject of the effect. It defines who has the effect, and required for resource-based policy and trust policy. In action, you define the specific operation. Each resource has its own set of actions that can be described in the detail. In this example, a wildcard is used, meaning any action is allowed. Conversely, if the effect is denied with a wildcard, it means all actions are denied. The resource field indicates the resource being acted upon. You can also add a specific condition under the condition field. The term ARN stands for the Amazon resource name, which uniquely identifies an AWS resource. And the string equal is used to match a specific string, so in this case, it ensures only a particular IAM user can perform the action. And you can set detailed conditions within the condition field. The table here summarizes some common conditions. The string equal checks if the strings are exact match. For example, it can verify if the resource name or tag's name matches. The similar condition includes the string like and the not equal. The numeric equal checks if the numbers are exact match. The similar condition includes the numeric not equal and the numeric greater than. The bool represents the Boolean value and defines a binary condition of either the true or false. For example, a condition might be only valid when encrypted communication is enabled. And the ARN equal check if the AR match, and the date equal check if the date matches. In every exam, there will likely be at least 2 or 3 questions that require you to read and understand the JSON of these policies. The IAM policy can be attached to resources as well as identities, and this is called resource-based policy. I'd like to introduce a couple of patterns that are commonly used. When integrating the services, it is necessary to set policy properly. And if you forget to set the policy, you will encounter the authorization errors, and the service will not be available. This is especially common with the S3 bucket policy with CloudFront origin, execution policy of the Lambda and SQS. Since Lambda and SQS are services that always work with other services, it is necessary to grant policy. In practice, authorization errors often happen because the policies are not properly configured, so it is important to keep them in mind. And here is a list of policies associated with IAM. In addition to identity-based and resource-based policy, there are also the permission boundary, the SCP, the service control policy, and the session policy and set in the AWS STS. And you can define these policies in JSON as well as IAM policy. Now, I will introduce cross-account setting. The image shows an example of executing an action from the application on the EC2 instances to an S3 bucket. On the left side is the cross-account setup, and on the right side is the single account setup. In the scenario, the identity executing the action and the resource receiving the action in a separate account. In such case, the only actions that are allowed by both the identities policy and the resource policy are valid. This means that the policies must satisfy the AND condition. In this example, only the getObject action is valid. In contrast, for a single account, any actions allowed by either the identities policy or the resources policy are valid, which follows the OR conditions. In a cross-account setup, if you want to allow a specific action, you must explicitly allow in both identities and the resource policy, and conversely, for a single account, if we want to deny specific action, you must explicitly state deny. So now let's look closer at the specific steps for an EC2 instance in the account A performed action on the S3 bucket in account B. A trust policy is attached to the IAM role and defines which principal is trusted and allowed to assume this role. In this case, the principal is the EC2 instance. When an EC2 instance is launched, an instance profile associated with a specific IAM role is attached, and this IAM role must have the trust policy set that allows the EC2 service to assume this role. The EC2 instance retrieves temporary security credential for the attached IAM role via the EC2 metadata service. The trust policy functions as the prerequisite for these assume role steps. A permission policy is attached to the IAM role and defines what action this role can perform on which AWS resources. Whether EC2 can access S3 is determined by this permission policy. The application uses the obtained temporary credential to call the S3's API. An S3 bucket policy is a resource-based policy created in the account B. It defines which principal is allowed or denied access to this S3 bucket. And this is a sample trust policy for IAM role, and this policy allows the EC2 service to assume this role. When creating a role for EC2, this policy is usually set automatically. And this is the sample permission policy for an IAM role, and this policy is attached to the role that has the trust policy. It defines the specific access permission to the S3 bucket. This sample includes the getObject and putObject. And finally, this is an S3 bucket policy. This S3 bucket policy contains a statement allowing the EC2 role to perform the action via the specific VPC endpoint. In this case, the neither policy defines a deny, but action from the EC2 role not coming through the specific VPC endpoint are implicitly denied. And next, I will introduce the permission boundaries. The permission boundary is a policy that is added on the top of the existing policy to apply further limit. In this image, the yellow area represents the policy, and the blue area represents the permission boundary. As a result, only the permission within the overlapping the green area are allowed. The permission boundaries are useful when you want to limit the action of the particular IAM user. In this example, by adding the permission boundary that allows or denies a specific action to IAM identity with the administrator right, only these actions specified in the boundary will be allowed. The permission boundaries are applied to IAM identities to ensure they only have the minimum necessary permission, which is important for the governance and security. The permission boundaries are applied to individual IAM user and roles to limit their permissions. The permission boundaries in IAM and SCP in the AWS organization are quite similar. The SCPs are used in the organization hierarchy to limit the sum of the permission inherited from the parent level. For example, the parent level may allow launching all EC2 instances, but the child level might not be able to launch certain EC2 instances. The JSON format works the same way. Next, I'll introduce AWS STS. The STS, the Security Token Service, is a service that provides a temporary access to AWS resources. While IAM grants to permanent credential, STS issues temporary credential with the expiration time ranging from a few minutes to several hours. And once the credential expires, the access is no longer available. For security reasons, these credentials are dynamically generated and not stored with the user. The temporary credentials, like access keys, secret access key, and session tokens, can be obtained through the assume role action in AWS STS using IAM roles. When providing the access to the external users, the manually creating IAM users and assigning the policy to each one increases the operational overhead. Moreover, the granting the long-term permission to temporary users poses a security risk. A session and access data can be stored in services like DynamoDB, and when a request for credential is made from a role, the STS issues and grants the temporary credentials. And I will explain the temporary authentication using STS between different accounts. In this example, account A is trying to access a resource in account B, and this is a command to get a temporary credential, and here assume the role named my role. And this will return a response here. The credential field contains the temporary access key ID and secret access key and session token. And with the credentials, account A can access the resource. And you can also set an expiration time for the credential. And once expired, the credential will no longer be available. The IAM roles are created to be assumed by a user, a service, or AWS account. In this example, if a user in account A wants to access a resource in the account B, the role is created in account B. The trust policy for the role specifies account A, allowing the user in account A to assume the role. Although the role existing in the account B, it is assumed by the user in account A. And when accessing the resources in account B from account A, includes a temporary credential obtained earlier in the CLI environment variables. Next, let's talk about the confused deputy problem as an example of complicated permission issue. A confused deputy problem is a security issue where an entity without permission to get another entity with higher privilege to perform an action on their behalf. For example, the account A has an IAM role called the example role, which it shares with an IAM user from a corporation. The company's IAM user assumes the example role and access account A's resources. And however, another user from account B somehow assumes the same example role and gets account A's resources accessed on their behalf. And this is the confused deputy problem. Now I will explain how to avoid or minimize the impact of a confused deputy problem. And first, follow the principle of the least privilege by allowing only the minimum necessary actions for the minimum necessary account, and this reduces the impact if a proxy problem occurs. And you can also reduce the potential risk by setting access expiration in STS. And additionally, by using an external ID when granting an IAM role, you can prevent unauthorized third parties from assuming the role without knowing the external ID. On the next page, I will show you a specific example of how to implement this workaround using the external IDs. When setting up the example role, set the external ID in the condition field, and provide the example role from account A to corporation. The corporation's user will include the external ID when sending an access request. Only when this external ID matches access will be granted. If another account that doesn't know the external ID accesses the account A, the request will be denied because the external ID does not match it. And this external ID acts like a password. I will show you how to implement it from the next page. And first, create an example role on account A, and here is a sample example role. And this trust policy allows the assume role request from the corporations. And this permission is only granted if the external ID matches the 1, 2, 3, 4, 5, the condition that the string equals external ID 1, 2, 3, 4, 5 is included in the condition field. When the corporation user access account A, they use a command like this to assume this role to obtain temporary credential. And with this command, the corporation user assumes the example role and obtain the temporary credential to access account A's resources. The external ID is set at the end of the command. And it is important and commonly used technique to put the external ID in the condition field to restrict the access. The IAM Access Analyzer is a service that supports identifying the potential security risks, especially unintended external access and unused access permission. It analyzes the IAM policy to detect if access from the outside the trusted zone is permitted. The trusted zone is set as your own account or your organization. And if a risk is detected, it sends findings to Security Hub or execute necessary action with the EventBridge. Also, using the IAM Access Analyzer's policy generation feature, you can automatically generate a policy aligned with the security best practice. Now, I will introduce the feature of IAM Access Analyzer. The first, external access analysis continuously analyzes your resource-based policy using the automated reasoning. If a policy allows access from the principal outside your trusted zone, the Access Analyzer reports things as the finding. The IAM Policy Validation feature checks your IAM policy for correct JSON syntax or also evaluates them against the AWS security best practice. It provides a guidance, for example, the things like overly broad wildcard permission or suggesting the improvement based on the access level. And next, working with the CloudTrail, the Access Analyzer provides unused access analysis. It reviews the CloudTrail history to identify the permission for services or action, IAM role, or access key that haven't been used recently, and reporting these things as the findings. And this helps you remove unnecessary permission safely. And similarly, it uses the CloudTrail history for IAM policy generation. It analyzes the CloudTrail history to determine which action and resource they actually used. Based on the analysis, it automatically generates a policy template that follows the principle of the least privilege. And this is a sample S3 bucket policy that would receive a warning from the IAM Access Analyzer. And this policy has the wildcard set for the principal, meaning it permits any user to read object within the S3 bucket. And this may be permitting the inadvertently broad access. And also because it is accessed from the outside of the trusted zone, it is detected. And we have introduced several types of IAM policies so far. Now I want to explain the policy evaluation logic using the simple example. Imagine an EC2 instance in account A trying to perform an action on the S3 bucket in account B. The several policies will be involved. The first, an identity-based policy attached to the EC2 instances the IAM role is needed. In AWS policy evaluation, the access is denied by default. This means an explicit allow is required. Otherwise, access is implicitly denied. For the EC2 instances to perform S3 action, its identity-based policy needs an explicitly allow. A permission boundary might optionally be attached to the EC2's IAM role to set the maximum permission the role can have. And if an account A is part of the AWS organization, SCPs might apply attached at the organization root, OU, or account level. The SCPs act as the permission guardrail defining the maximum allowed permission. The S3 bucket in account B can have resource-based policy, a bucket policy, and this defines which principals are allowed or denied a specific action on this bucket. Now let's explain the evaluation process and the order of the priority. First, the AWS checks all applicable policies for any explicit deny statement matching the request. If even one explicit deny is found, the request is immediately denied and the evaluation stops. The deny always overrides allow. And if there is no explicitly denied, AWS checks the applicable SCP. If the request isn't allowed by SCP guardrail, either explicitly or implicitly, the request is denied. Then, if applicable, permission boundary is checked. If the boundary doesn't allow the requested action, the request is denied. Next, if a session policy is present, it's checked. If the session policy doesn't allow the action, the request is denied. If the request hasn't been denied by any of the previous steps, I am taken then look an explicit allow statement in either the identity-based policy or the resource-based policy or both. If at least one explicit allow is found, the request is allowed. If no explicit allow statement is found in any relevant policy, the request is finally denied based on the default deny principle. This diagram from the official document summarizes the policy evaluation logic. Remember, an explicit deny anywhere results in denial. The applicable SCP, the permission boundary, and the session policy must have also allowed the request. Only then does AWS look for an explicit allow in either the identity-based policy or the resource-based policy. And if no allow is found, the request is implicitly denied. It is important to understand the evaluation logic for granting the permission you intend, while reliably preventing the unexpected access. You especially need to consider this order and the priority was denied when designing the policy for complex situations like a cross-account access or delegated permissions. Next, I will introduce directory services. The directory services are systems that centrally manage and control access to a company's IT resources. Among them, the Microsoft Active Directory is widely regarded as the industry standard, and you can deploy Active Directory not only on premises but also in Azure, the cloud service by Microsoft. The Active Directory offers the following functions: the authentication and authorization, directory services, the policy management, and support for LDAP and the Kerberos authentication. Starting on the next page, I will introduce the directory services available on the AWS. The services related to the directory service include the AD connector, the simple AD, and the AWS managed Microsoft AD. The AD connector is a directory gateway that redirects the directory to request from the AWS IAM to your on-premise Active Directory. It is installed within your AWS VPC. A simple AD is a managed directory service that uses the Samba for Active Directory. It allows you to set up the new Active Directory within AWS. AWS managed Microsoft AD also let you set up the Active Directory in the AWS, but it is designed for the larger environment supporting more than the 5,000 users. If you need the full functionality of the Active Directory, the managed AD is the recommended options. And this is a table that summarizes the 3 directory services. Again, the AD connector is a gateway services that connects to an existing on-premise Active Directory. The simple AD is a directory services suitable for smaller organizations. The AWS managed Microsoft AD provides the full-featured Active Directory in AWS. And this is the single sign-on flow using the ADFS, the Active Directory Federation Services. The flow allows the user to authenticate with Active Directory and use their credential to access AWS services. And first, the user connects to the authentication endpoint using the browser. The ADFS redirects the user to Active Directory, where Windows Active Directory authenticates the user. The necessary credential is sent to the user, and the user sends the credential to AWS single sign-on. And once the credentials are verified, the user is redirected to the AWS console. And at this point, the specific resources and the specific permissions are assigned based on the required access. And this is the image of the integration between AD connector and the managed Microsoft AD and the AD server. The AD connector acts as the authentication proxy to the on-premise Active Directory, querying it every time an authentication request is made. And this allows users to access the appropriate resources based on the credential in the on-premise Active Directory. The managed Microsoft AD enables two-way communication, allowing it to work in both directions. As a full-featured directory services, the managed Microsoft AD synchronizes the authentication information for both AWS and the on-premise environment. And for reference, let me introduce Microsoft Entra ID and Active Directory. The Microsoft Entra is a suite of services related by the Microsoft in 2022. And in 2023, the Azure Active Directory was renamed to Microsoft Entra ID. The Azure Active Directory is a service that provides Active Directory on Azure, the Microsoft Cloud Platform. The Microsoft Entra is a collection of products that integrates Microsoft Identity and Access Management. In addition to Microsoft Entra ID, it includes Entra Permission Management and Entra Verified ID. And for reference, Azure's services include both services prefixed with Azure and services prefixed with Microsoft. The services prefixed with the Microsoft are deployed by Microsoft, and the services with the prefixed with Azure are specific to Azure Cloud. According to the Microsoft official website, although the name has changed, most of the product feature remains the same. Existing Azure AD's user can continue using the services without any changes. Azure AD has simply been integrated into the Entra ID and renamed. Let me explain the differences between Entra ID and the ADDF organizations. On the left, we have Entra ID in Azure, and on the right is the On-Premise Active Directory Domain Service, ADDS. In Entra ID, the organizations are structured as tenant within the Azure environment. When you create an account in Azure, the single tenant is automatically created. And within the tenant, you can create the subscriptions and the resource group, and it's possible to have multiple tenants. And in ADDS, an organization is called Forest. Within the Forest, you can configure domains. The domains can have the parent and the child relationship, establishing the trust between each domain. The group of domain with the parent-child relationship is called a domain tree, as opposed to a forest. And let me explain how user information is synchronized from Entra ID to ADDS. After a user is created in Entra ID, their information can be synchronized to the domain services when they change their password. And this process generates the password hash required for Kerberos and NTLM authentication. As the synchronization is one way, meaning there is no reverse synchronization from ADDS to Entra ID. And this process is similar to the AWS AD connector. Additionally, the synchronization from ADDS to Entra ID is possible using a feature called Entra Connect. And this synchronization includes the user account, the group, membership, and the hash value needed for credential. The Microsoft products are not in the scope of AWS exam, but I have included them because of their practical importance. Firstly, I'm going to introduce the authentication and the authorization, which are two essential security processes. The authentication is the process of confirming the identity, who you are, often done through the things like knowledge factor, the possession factor, and the inherence factor. The authorizations occur after authentication, and it's a process of giving the permissions to access resources. The Amazon Cognite is a service that provides a secure user authentication and user management for web and mobile applications. It supports sign up and sign in capability, identity storage, and identity federations. The identity storage allows you to manage user and authentication information, which is done through a feature called the user pool in Cognito. The identity federation refers to the ability to authenticate and grant access to AWS resources using the external social identity provider. The image shows a typical authentication and authorization process using the identity provider, IDP, and the service provider, SP. The client sends an access request to the service provider, and the service provider redirects the users to the identity provider. The user provides the authentication details such as a user ID and password to the IDP. And at this point, you can add additional authentication like the multi-factor authentication. And if authentication is successful, the IDP generates the assertion, which includes the details about the client's privileges. The assertion is provided by the form of Samuel or OpenID Connect. The IDP sends the assertion to the service provider, and the client is redirected to the service provider. The service provider verifies the assertion and grants the client access. The authentication and authorization flow involves the technical details, while these are not covered in the associate level exam, but I believe it's important to understand from the practical standpoint, so I will include it. And let me explain some common use cases for Amazon Cognito. The Cognito provides both authentication and authorization capabilities. You can issue the authentication tokens using the Cognito user pools. And the Cognito identity pools can be used to grant access to necessary resources by specifying the authorization rules. Additionally, the Cognito can integrate with third-party identity providers, IDPs. So let me explain the main element of the Amazon Cognito. The Cognito user pool acts as the directory service that manages the user IDs and password, and as identity provider that issues the user credential. It supports the sign up and sign in using usernames and password, along with the common authentication features like password recovery and token-based authentication. And you can also trigger AWS Lambda function during the sign up and sign in event. For example, user attributes from the user pool can be passed to the Lambda function, and event logs can be stored in S3. The Cognito identity pool is responsible for granting the authorization to AWS resources. The user pool handles the authentication, while the identity pool handles the authorization. While you can use IAM and STS for temporary credential, if you want to handle both authentication and authorization entirely with Cognito, you use the Cognito identity pools. Additionally, the Cognito can integrate with the third-party identity providers like Facebook, Google, and Amazon. And this is a process for authentication and application and API using the user pool. The client attempts to connect to the application, and at this point, a sign-in request is made to the Cognito user pool. The client is then redirected to the IDP. The IDP can be third-party direct services. And if needed, additional authentication is performed by user pool. The authentication response is returned from the client. Once the authentication is complete, the client can sign into the application using a token or exchange data with the API. And let me explain the setup of the Cognito user pool and a simple authentication process. You can create the Cognito user pool from the management console. When the user pool is created, a user pool ID is generated, which is then set as the environment variable in your authentication code. And this is the JavaScript user authentication code. The onSuccess function handles the process for successful authentication. When onSuccess is called, the JWT token is obtained for accesses. The JWT token is issued when the user logs in for the first time, and it is automatically attached to the subsequent request. And if authentication fails, the onFailure function is called. Next, this is the authorization process using the Cognito identity pools. The identity pool assigns the AWS credential to the client. And first, during the authentication process, the client or application is authenticated. And this can be done using a third-party IDP or the Cognito user pool. Next, a request for authorization token and a request to the AWS STS for a role. The AWS STS is a service that provides temporary credentials. And finally, the credentials are issued from the Cognito identity pool, allowing the client to access AWS resources. When using both the Cognito user pool and the Cognito identity pool together, authentication is handled by the user pool, and the authorization is handled by the identity pool. And let me explain the configuration of the Cognito identity pool. You can create the identity from the management console too. Next, configure the IDP settings. And you can use the Cognito user pool ID as your IDP or choose a third-party IDP. And after that, specify the identity pool ID. In the login object, provide a token to authenticate the federated user and enter the Cognito user pool ID. And if the authentication is successful, the user will be able to access the AWS resources. Now, define the required actions for the AWS resource. And here is another feature Cognito offers, token-based authentications. With token-based authentications, the user provides a username and password when signing in for the first time. Once the authentication server verifies the user's identity, it issues a unique authentication token. The user then uses this token for access, which is typically included in the HTTP request header. For enhanced security, you can configure password policy or enable multi-factor authentication (MFA). The Cognito also supports password changes in case of a forgotten password, as well as the verification of email address and phone number. Additionally, the Cognito can block users if their passwords have been compromised on other websites. Let me explain the Samuel. The Samuel is an XML-based open standard used for authentication and authorization across different domains, primarily for single sign-on. The Samuel consists of the following elements: the assertion, the protocol, and the bindings. Assertions are XML formatted documents that contain authentication and authorization information. and the protocol define how to request Samuel response and assertions, while binding specify how Samuel protocol messages are transmitted. A common use case is when a user authenticates on the enterprise internal network identity provider and uses those credentials to log into the external cloud service provider through the SSO. For example, if an enterprise uses AWS, it can send authentication information from its internal Active Directory to AWS as a Samuel assertion, allowing the user to log into the AWS Management Console with single sign-on. The AWS supports single sign-on through a service called AWS Identity Center, which I will discuss later. And for now, please remember the terms identity provider and service provider. And firstly, I'm going to introduce the encryption in the cloud environment. In the cloud environment, where the sensitive data are stored online, the encryption is an important measure for protecting the data from malware and ransomware. The encryption is the process of converting the digital data into a string of the character unreadable by unauthorized user. Since the cloud is online, it's necessary to encrypt both the data at rest and the data in transit. Encryption is the process of transforming the plain text into an unreadable cipher. It uses the cryptographic keys and algorithms. The converted data can be reverted to its original form using the decryption key, a process known as reversible encryption. In contrast, irreversible encryption is known as hashing. It generates a hash value that cannot be reversed. The hashing is commonly used in the digital signature. There are a symmetric encryption and an asymmetric encryption method. The symmetric encryption is the method where the same key encrypts and decrypts the data. This method is fast and efficient for encrypting the large amount of data. However, there is a security risk to share the keys between the sender and the recipient. Asymmetric encryption, or also known as the public key encryption, involves two keys, a public key for encryption and a private key for decryption. The public key is shared between the sender and the recipient. However, only the owner of the private key can decrypt the data. And the hybrid encryption combines the strengths for both symmetric and asymmetric encryptions. The recipients share the public key in advance. The sender encrypts the data using the symmetric key. In addition to the encrypted data, the symmetric key is encrypted using the recipient's public key. The sender sends both encrypted data and encrypted common key. The recipient decrypts the common key first, and the recipient then uses the decrypted symmetric key to decrypt the encrypted data. The history of the cryptography is very long, with advancement in the computing science. It is important to use the latest and most secure way of encryption. AWS offers secure method compliant with the standard like FIPS. So let me introduce AWS KMS. The KMS, the Key Management Service, is a service that helps you to create and manage cryptographic keys. It supports creation and management of the HMAC key, symmetric keys, and the asymmetric key. You can control the access to these keys using the key policy and IAM policy. With KMS, you can manage the entire key lifecycle from the creation to deletion all in one place. The KMS also offers automatic key rotation, which reduces the security risk of using the same key for an extended period. Now I will discuss the keys and the key material. A key is a logical entity for the data encryption and the digital signature. It is associated with the metadata such as the unique key ID, ARN, the creation date, and the description. The keys you explicitly create and manage in KMS are called Customer Managed Key, CMK. The keys that AWS services like S3 create and manage for your code, the AWS Managed Key. The key material, on the other hand, that refers to the binary representation of the encryption key itself. The key material is actually used for the encryption and the decryption. When importing the external key material into KMS, the user is responsible for the generating and backing up the key material. The KMS doesn't support backup or rotation of the external keys. And this is a summary comparing the AWS Managed Key and the Customer Managed Key. The AWS Managed Keys are keys created and managed by the specific AWS services on your behalf. For example, you might use one when setting up the encryption in S3. With AWS Managed Key, you cannot directly edit the key policy. Their lifecycle, like enable, disable, and delete, is also tied to the AWS services using them. Often deleting the main AWS resources also deletes the associated AWS Managed Key. And there is no separate monthly charges for the AWS Managed Keys themselves. The Customer Managed Key, the CMK, on the other hand, are keys that you explicitly create and manage using KMS console, CLI, or API. And you have full control over their key policy, rotation, and the lifecycle. And this chapter will mainly focus on the Customer Managed Keys. The KMS has a key rotation feature. Using the same encryption keys for a long time increases the security risk if the key is ever compromised, and therefore the rotating the key periodically is a recommended security best practice. For CMK, you can enable automatic key rotation. When enabled, the KMS automatically generates new key material for the CMK once every year by default. The KMS also supports customizing this automatic rotation period between the 90 days and the 7 years. When KMS automatically rotates the key material, it keeps the older key material securely stored internally. And this means that data encrypted with the previous version of the key material can still be decrypted using the same CMK. Importantly, the automatic key rotation doesn't change the CMK's properties such as the key ID, ARN, aliases, or key policy. And therefore, if your application references the CMK using its ARN, key ID, or probably an aliases, you don't need to change your application code when they rotate automatically. So let me explain the life cycle of the key. A key's life cycle refers to the serial of the event from the creation to deletion. The customer managed key can be enabled, disabled, and deleted. Once a key is deleted completely, it cannot be recovered forever. The key should not be immediately deleted. Instead, they are first logically deleted and then physically deleted after a waiting period of the 7 to 30 days. And during this period, you can enable the key if needed. A logical deletion means the key appears to be deleted, but the data still exists. and during the waiting period before physical deletion, any use of the key can be tracked through the CloudWatch and the CloudTrail, allowing you to detect a compromise. It is best practice to disable key before deleting, rather than deleting them immediately. The KMS supports BYOK to bring your own key, which allows you to import external key into KMS. But BYOK has some limitations. It doesn't support automatic key rotation, so you need to manually regenerate the key when necessary. Additionally, you must back up your keys, as automatic recovery is not available in case of failure. The BYOK also doesn't support logical deletion. The keys are deleted immediately upon expiration. And here's the procedure for importing the BYOK key. First, download the public keys from the KMS. Then encrypt your key material using that public key and upload the encrypted key material to the AWS. The KMS multi-region key allows you to have the CMK with the same key ID and the same key material in different AWS regions. The main benefit is that you can encrypt the data in one region and then easily decrypt it in another region using the related keys there. And this is helpful for disaster recovery or global application where the data move between the regions. The multi-region key have one primary key and one or more replica key in other regions. While they share same key material, the settings like key policy, enabled or disabled state, the tags, and the aliases must be managed independently for each key and in each region. And they are not automatically shared or synchronized. Next, we will discuss the access control for KMS. The KMS allows you to control access to your CMK by setting the key policy. A key policy is a resource-based policy that defines permissions for who can access and manage the keys. The key policy are written in JSON format as shown here, and in this example, the action field has an asterisk after the KMS, which allow all possible operations on the KMS. By specifying the action in your key policy, you can limit the scope of the privilege. On the left side is an example of the action for the key administrator. The key administrator can manage the tasks like key creation, enabling the disabling and deleting, and scheduling the key. On the right side is an example of the key user action. The key user can perform the tasks such as the encrypting, decrypting, and generating data keys using the KMS. When decrypting the S3 objects that were encrypted using the KMS key, the principal performing the action needs the KMS decrypt permission. For example, imagine an application running on an EC2 instance needs to perform the get object operation on the object in the S3 packet, where the object was encrypted with the specific KMS key. In this case, the EC2 instance's IAM execution role must have the permission allowing both get object for the S3 and the decrypt for the KMS key. Additionally, the S3 bucket policy needs a statement allowing S3 get object for the EC2 role. The KMS key policy must also explicitly allow the EC2 to perform the decrypt action on that key. If any of these necessary policy permissions are not correctly configured, the client application will likely receive an access denied error. So next is grants. The grants are a mechanism for the temporarily delegating the usage permission for KMS customer managed key to other AWS principal. Without changing key policy or IAM policy, you can give key usage permission to other principal under the specific conditions. The only actions related to the cryptographic operation can be delegated with grants. The management operation cannot be permitted with the grants. And this is how grants work. A principal with access rights to the key calls the Create Grant API to create a grant. At this time, they specify the grantee principal. Typically, the AWS service principal or the IAM role are specified. They specify the cryptographic operation to the permit with operation. Also, you can optionally specify retiring the principal to retire the grant. Additionally, you can specify the condition for the grant to be valid. Next, it returns the grant token, and this is for immediately using the permission during the short time until the grant is reflected throughout the system. When the grant becomes active, the grantee principal will be able to execute the specified operation against the target key ID. When the grant is no longer needed, retire the grant. Next, let's discuss the data keys and how envelope encryption works. A data key is the actual key used to encrypt and decrypt your application data. The KMS doesn't store the data keys long term. They are generated temporarily when needed for encryption. The data key exists separately from the CMK. The relationship uses the envelope encryption. The CMK, the master key, encrypts the data keys. And you use the generate data key API to get the data keys from KMS. The use case of data key is to efficiently encrypt a large amount of data in your application. This avoids the performance and the cost issues, and the 4 KB size limit of using the KMS encrypt API directly for your large data. Your application performs the encryption locally using the download the data key. Your application must also save the encrypted data key, which KMS provides, alongside your encrypted data. And this is needed for the future decryption because KMS doesn't permanently store the data key. And this process also protects your CMK. With envelope encryption, the sensitive CMK key material never leaves KMS. Only the temporary data key is handled and briefly in plain text, then stored encrypted by your application. Now I will introduce the flow for encrypting application data using the data key envelope encryption. Imagine the red box above is the KMS and the black box below is your application holding the data to be encrypted. When the application needs to encrypt the data, it first sends a request to KMS to generate the data key. Specifically, the application calls the Generate Data Key API in your KMS. This request must include the key ID or ARN of the CMK that will be used to protect the data key. When KMS receives the Generate Data Key request, it first checks the caller's permission, and if permitted, the hardware security module inside the KMS generates the unique data key securely. You don't need to worry about managing the CMK key material itself within the AWS. Next, the KMS uses the specified CMK to encrypt the data key that was just generated. And this process, where the master key, the CMK, encrypts the data key is called the envelope encryption. Think of the CMK as the secure envelope and the data key as the item inside. The KMS then returns both plain text data key and encrypted data key back to the application in the generated data key response. the plain text data key is needed by the application to actually encrypt the data, while the encrypted data key is needed later for decryption. The application uses the plain text data key received from the KMS to encrypt the target data locally, the client side, usually using the standard symmetric algorithm like AES GCM. After encrypting the data, the application must securely erase the plain text data key from its memory, and this plain text key should never be stored persistently. And finally, the application stores the encrypted data together with the encrypted data key in the data store, such as S3 or database. Next, let's introduce the flow for decrypting the data using the KMS. And we start from the state where the data and the encrypted data key are stored together. The application sends only the encrypted data key to KMS by calling the decrypt API. The KMS receives the encrypted data key, identifies the CMK that was originally used to encrypt it, and check if the application's IAM role has the KMS decrypt permission on that specific CMK. If the permissions are valid, the KMS uses the CMK internally within the secure hardware module to decrypt the data key. The KMS then returns the plain text data key back to your application. The CMK itself never leaves the KMS. The application uses the received plain text data key to decrypt the actual encrypted data locally within the application. After decryption is complete, the application should securely erase the plain text data key from its memory. And finally, I will explain the pricing, the quotas, and the caching of the keys. As previously mentioned, there are two types of the CMK, the Customer Managed Key and the AWS Managed Key. For Customer Managed Key, there are charges for key storage and the number of requests. For AWS Managed Key, there is no storage charges. To maintain the service stability and availability, the KMS has quotas on the maximum API request rate per account and per region. These quotas vary depending on the key types and the cryptographic operation. For example, the symmetric key cryptographic operation generally have the relatively high rate limit. And if your application request rate exceeds these limits, the KMS will throttle the excess request. When throttling occurs, your request might be delayed or could fail with the error. If the default quota is not sufficient for your application needs, you can request a quota increase through the AWS support. The data key caching helps to avoid the cost and the throttling by reducing the API call. It is used with the envelope the encryption. And here is the basic idea. Your application gets the data key from the KMS the first time it's needed. It then temporarily caches the plain text data key securely in your memory, setting the limits like the time to live or maximum usage count. When your application needs to encrypt or decrypt again, it first checks the cache for valid key, and if found a cache hit, it uses the cached keys without calling the KMS again. If the key isn't there or has expired, a cache miss, the application gets the new keys from KMS, update the cache, and then use it. The KMS supports encryption for many services, and the encryption methods differ depending on the service. I will explain a few common examples. The System Manager's parameter store is used to centrally manage the system parameter and access keys. It stores various strings, both sensitive and non-sensitive. By default, AWS managed KMS key can be used for encryption. The Secrets Manager is a service for sensitive information such as the password. The secrets are encrypted with the KMS key. The encryption is also supported for the database services, with different services using the different encryption method. It supports encryption by cluster, table, and data. The EBS and S3 also support encryption. In particular, S3 offers both server-side and client-side encryption options. I will introduce the S3 encryption in more detail in later chapter. Next I'm going to introduce AWS CloudHSM. The CloudHSM is a service that provides a single tenant, the dedicated hardware security module instance in the AWS cloud. Generally, an HSM is a dedicated, tamper-resistant hardware device used to securely manage the cryptographic keys and perform the cryptographic operation directly within the hardware itself. The HSMs are often used to meet the strict compliance requirements, such as the certain level of the FIPS 142, and with CloudHSM, the customer has complete management control over the HSM instances and the cryptographic key generated and stored inside them. Because it is the single-tenant environment, your key material is never shared with other AWS customers. To achieve high availability, you typically configure CloudHMS cluster by placing the multiple HSM instances across the different availability zones. A cluster is simply a collection of these HSM instances working together. Each HSM instance is launched with the ENI into the subnets that you specify within your VPC. And this allows your application within the VPC to connect to the HSM over the network using the CloudHSM client software. The client software automatically distributes request and load balancer connection across the healthy HSM instances within the cluster. On EC2 instances that need to use the CloudHSM cluster, you must install and configure the CloudHSM client software, and this client software establishes the secure communication with the HSM in the cluster. Access permission and the ability to perform the cryptographic operation or manage key on the HSM are controlled by the dedicated user account that are managed inside HSM itself. And this is a separate authentication and authorization system from the IAM. The IAM users or roles do not directly log into the HSM itself. Let's introduce the 5142. This is a US government standard that defines the security requirement for the cryptographic module. It is issued by the NIST. The main purpose of the 5142 is for the US government agency to set a minimum security requirement for the cryptographic module. It serves as the standard when the government agency purchases the cryptographic product. And not only the government use, the 5142 is also widely considered a common benchmark for evaluating the security strengths of the cryptographic module in many industries. For example, some AWS services, like those used by CloudHSM, have achieved the 5142 Level 3 validation. The 5142 defines security requirement for cryptographic module across the 4 levels, with the requirement becoming stricter as the level increases. Whether a cryptographic module complying with the specific 5142 level is tested by the accredited independent testing laboratory. So let's explain the differences between CloudHSM and KMS. The CloudHSM is a hardware security module using the physical hardware with the anti-tampering feature. is primarily used for the compliance purposes. The KMS is a fully managed key management service that integrates with many services. It offers fine-grained control over key management, and you can also upload pre-encrypted data to the AWS using the customer-managed key. The next is AWS Secrets Manager. The Secrets Manager is a managed service to securely store, manage, rotate, and retrieve secrets like a password and API keys throughout their lifecycle. It helps you stop the hard-coding secret in your application code, which is insecure and make updates difficult. And with Secrets Manager, the secrets are stored centrally, encrypted using the KMS, and access is strictly controlled using the IAM Policy. A key feature is the automatic rotation for many secret types like the database password, which improves the security by regularly changing credentials. All access to the secret can be audited using the CloudTrail. The secrets typically managed include the database credential, API keys, OAuth token, and SSH key pair. The Secrets Manager can rotate the secrets automatically. For certain services like RDS and Redshift, the managed rotation is supported. You mainly just schedule, and AWS handles the update process, often using the pre-built Lambda. For other types of the secret, the rotation uses the AWS Lambda function that you configure. The templates are available from the console. The rotation capability is crucial for security, and please note that unlike Secrets Manager, the System Manager parameter store doesn't offer automatic rotation. And here's how to manage a secret when an application on EC2 connects to RDS. To connect to the RDS database, the username and password are required, and you should store this username and password securely in the Secrets Manager. The secret stored in the Secrets Manager can be encrypted using the KMS, and you can also configure the automatic rotation for these secrets using the Lambda. The EC2 instance needs the IAM policy, like a get secret value, to retrieve the secret from the Secrets Manager. The Secrets Manager also allows you to resource-based policy directly on the secrets themselves. Using these identity-based and resource-based policy enables a fine-grained access control over who can retrieve your secret. And I will explain the differences between the Secrets Manager and the System Manager's parameter store. The parameter store is used to store the wide range of the strings, including the system parameter and the secret, and it is free to use. It also integrates with many services. On the other hand, the Secrets Manager has an automatic rotation feature and is designed for securely managing the secret. This topic often appeared in the exam, so make sure to learn the different use cases. The Amazon S3 is the most popular object storage. The S3 stands for Simple Storage Service. It offers high durability and unlimited capacity. Unlike EFS or EBS, you don't need to specify capacity in advance. You are charged based on how much the storage you use. The S3 offers redundancy by replicating the object across the multiple AZ, ensuring storing the data integrity. It also supports various data protection features such as versioning, MFA authentication, and encryption. The S3 is used in the wide range of use cases. It's commonly used for backing up logs, the snapshot of AWS services. It's also used as a data lake for storing the structured and unstructured data, as well as for hosting static content. In S3, the container that holds the object is called a bucket, and the S3 Glacier The container for storing archive is called a vault. The S3 offers a variety of storage classes, and by default, the standard class is selected. The standard class is used for frequently accessed data. The standard IA is used for less frequently accessed data. The intelligent tiering automatically moves data to lower cost storage classes based on access patterns. The one zone IA stores data in a single AZ and is less expensive due to lower redundancy. All of these storage classes provide the 11.9 durability. However, the availability varies by storage classes. And be careful not to confuse availability with durability. The data stored in S3 is physically stored in AWS data centers. The high durability means the data itself will not be lost, but availability refers to whether the data can be accessed at all times. And the standard IA and the one zone IA have minimum storage period. Even if you delete before this period ends, you will still be charged for the minimum storage duration. And for reference, the RRS, reduced redundancy storage, is no longer recommended, but may still appear as an option in certification exam. And the next is storage classes for the S3 Glacier. Archived data that is accessed even less frequently than S3 is stored in S3 Glacier. The instant retrieval is used for data accessed about once a quarter, and the flexible retrieval is for data accessed about once a year, and the deep archive is for data accessed less than once a year. And the more frequently accessed data, the higher the storage cost. Conversely, the lower the access frequency, the lower the storage cost. But the retrieval fee increases and the retrieval time are longer. And all S3 Glacier storage classes have a minimum storage duration requirement. And you can set up lifecycle management based on the data access patterns. For example, you can automatically move less frequently accessed data to cheaper storage classes or delete it altogether. Currently, the lifecycle management can be applied across all storage classes. From here, I will introduce to the security features of S3. The security features by S3 include access control, signed URL, CORS, encryption, locking, and versioning. There are three main ways to control access in S3. The IAM policies are attached to IAM user or roles to manage access control. The bucket policy controls access at the bucket level. The bucket owner can set permissions for other accounts, and by specifying an object name in the resources attribute, it's also possible to control access at the object level. The ACL, the access control list, manages access at both the bucket and the object level. For account level control, the IAM policy are commonly used, and for bucket level control, the bucket policies are typically applied. On the other hand, ACLs are an older method of access control and lack fine-grained control options, so there is generally no need to use ACLs today. The ACLs can grant read, write, and list permission to object and the bucket. On the other hand, you cannot set fine-grained permissions for other actions. For example, ACL does not support conditional access control, such as allowing access only from the specific IP addresses. Therefore,
It's common to use bucket policies and the IAM policy for authorization management instead of ACLs. And here's a sample bucket policy. The JSON format is the same as that used for IAM policy. For example, you can enforce encryption by adding a condition in the condition field. And this is an example of enforcing server-side encryptions. The next, assigned URL allows you to set an expiration time for access to an object, and access is only possible via the generated URL. Only those who have the URL can access the object. However, once the URL is leaked, the third parties may be able to access the object, so it doesn't provide a complete security. Therefore, the signed URL are typically used for sharing the file for downloading. You can also create a signed URL for uploading file, not just downloading. And this is a sample of signed URL, which includes the access key ID, the signature, and the expiration time. Additionally, you can restrict the access by HTTP method or source IP addresses. Next, let me introduce CORS, the cross-origin resource sharing. The CORS refers to the sharing of resource between the different origins. If CORS is not enabled, you will encounter a blocked by CORS policy error. And this is an example of CORS configuration. In a web application, when the index file is on the domain 1 and the CSS file is on domain 2, you need to enable resources sharing between domain 1 and domain 2. With CORS, you can allow requests from the specified domain. And next, let's talk about the data encryptions. As mentioned in the KMS chapter, S3 supports encryption for data at rest. There are two types of encryption, and server-side and client-side encryption. With a server-side encryption, the data is encrypted by AWS after being uploaded to S3. And in contrast, the client-side encryption, the data is encrypted before uploading it to S3. For server-side encryption, there are three types: SSE S3, SSE KMS, and SSE C. And SSE S3 is enabled by default, and SSE KMS uses the KMS for encryption and decryption. And with KMS, you can choose between AWS managed keys and the customer managed keys. And SSE-C allows you to use a key provisioned by client. In this case, the key is not located in the AWS, but client locations. Make sure to remember the differences types of the key, where they are stored, and who manages the key. And for client-side encryption, CSE, since the data is encrypted on the client side before the uploading for the S3, the AWS is not involved in the encryption and decryption. Next, I will introduce object locking. You can lock the object in S3 to prevent them from being modified, making them the read-only file. You can set the retention period for the object lock. Once this period expired, the lock is automatically lifted. To use object locking, you must enable versioning, which I will explain later. There are two retention modes for object lock. The governance mode, which allows only specific IAM user to overwrite or delete object. The compliance mode, which prevents any changes from all users, including the root account. The compliance mode is ideal for log file used in the audit. Additionally, there is a feature called the legal hold, which protects the object for legal reason. The legal hold operates independently of the object lock's retention period. And this means that if the retention period has expired, the object remains protected as long as the legal hold is enabled. And similarly, if the legal hold is disabled, but object lock is still active, the object remains protected. The object can only be overwritten or deleted once both the object lock and the legal hold are disabled. The legal hold is useful when the duration of protection is uncertain, such as during the external audit where the end date is not yet known. And you can also set the bold locks in S3 Glacier in a similar way. So let me introduce the versioning. By enabling the versioning, you can retrieve previous versions of the object. In other words, even if you overwrite an object, you can still access its earlier versions. Additionally, when you delete an object, it's not permanently removed. Instead, a delete marker is created. And if you remove the delete marker, the previous version of the object will reappear as the latest version. To permanently delete an object, you need to specify its version ID when deleting it. And you can enable versioning on the bucket-by-bucket basis. In object storage, every object has a key and ID. When the versioning is enabled, a put object request or upload overrides the object with the same key. However, since each version has a different ID, you can refer to each as a separate object. The EFS and the EBS are storage options that can be attached to computing services like EC2 instances. The internal storage of EC2 instance is volatile. If you stop the instance, the data in the internal store will be lost. If you need persistent data storage, you should use EFS or EBS. The EFS can be attached to the multiple instances across the multiple AZ, and EBS can be attached to the multiple instances by enabling the multi-attach. But due to a certain limitation, it's typically attached to a single instance. Both EFS and EBS can be detached from EC2 instances as external storage, and EFS can be used as shared file storage, while EBS can be saved as snapshots. And this table compares the differences between the EBS and EC2 instance store and the EFS. Again, the EBS is block storage and the EFS is file storage. The EC2 instance store is internal storage in EC2. The connection type for EBS and EFS is over the network, while the EC2 instance store uses local disk. And EFS and EBS can be used for the persistent storage. And in terms of redundancy, the EBS provides the redundancy within a single AZ, while the EFS offers redundancy across the multiple AZ. The EC2 instance store does not provide the redundancy. And similarly, the EBS and the EFS are scalable, but the instance store is not. As a reminder, If you need to attach storage across the multiple instances in multiple AZ, use EFS, and for single AZ, use EBS. So now let me introduce the EC2 instance store. The EC2 instance store is a storage that is attached to an EC2 instance. The lifecycle of instance store is tied to the instance it is attached to. When the instance is stopped or terminated, the data in the instance store is lost. The instance stores are typically used for the temporary data storage, such as caching or use case with the high I/O requirements. And there are different types of instance stores, including SSD, HDD, and NVMe. The capacity and the specification of the instance store vary depending on the instance type. Next, here is a list of EBS specs. The EBS is block storage, and you can choose its specs. You don't have to memorize the number listed here. These numbers may be updated in the future. And for now, just remember the general categories such as the choice between SSD and HDD, and the specs based on the IOPS and throughput. The SSD generally offers a better performance than HDD. Additionally, the provisioned IOPS SSD is used for the workloads that require higher performance than the general purpose SSD. And also, the higher the spec, the higher the cost. The number at the end, like the GP2 and the GP3, indicates the versions, with the larger number representing the newer version. For example, GP3 is newer than GP2 and has improvements such as better scalability. The provisioned IOPS SSD support multi-attach, and only SSD support boot volumes.
Next, let's talk about the Amazon EFS. The Amazon EFS is an NFS-based file storage service. It can be attached to EC2 instances or on-premise server. To attach it to the on-premise server, the AWS Direct Connect is typically used. The EFS can be attached to the multiple instances across the multiple availability zone. It is fully managed, so users don't need to worry about the software update or maintenance. Additionally, its storage capacity automatically scales as needed. The NFS stands for the Network File System Protocol. It's a file sharing protocol designed for Linux, and the Amazon EFS is primarily used with the Linux instances. And for Windows instances, the Amazon FSx for Windows is used instead. The EFS offers two performance modes, the General Purpose and the Max I/O. The General Purpose is ideal for the use cases like web delivery, the content management, and the form directory. And the Max I/O mode is designed for workloads requiring the higher throughput, such as big data analytics or media processing. In addition to storage cost, there are also charges for the provisioned throughput. While not so many as S3, the EFS also offers different storage classes. The EFS standard is a storage class designed for frequently accessed data. It provides the high durability, availability, and the lowest latency access. Infrequent access is a more cost-effective storage class intended for the files that are not accessed often. It is suitable for the long-term storage for data you only need to occasionally. There is also EFS Archive added more recently, for even lower storage costs for very rarely accessed files. And similar to S3, you can enable the lifecycle management policy on your EFS file system to automatically transition files between these storage classes based on the access pattern. And here I will introduce the encryption process for EBS and EFS. When creating a new EBS volume or EFS file system, you can enable the encryption using the KMS. However, you cannot encrypt an existing EBS volume or EFS file system directly. And therefore, to encrypt the existing EBS or EFS, you need to follow these steps. For EBS volume, first create a snapshot of the existing EBS volume, then encrypt the snapshot. And after that, create a new EBS volume from the encrypted snapshot and reattach it to your EC2 instance. And for EFS file system, you need to create a new EFS file system with encryption enabled, then copy the data from the existing EFS file system to the new one. And with EBS, you can modify the size of existing volume. Specifically, you can increase its size explicitly when needed. And EFS, however, is designed as an elastic file system, and similar to S3, its storage capacity automatically expands or shrinks based on the amount of data you store. You don't need to manage or modify the size directly. It is important to understand the difference in how storage size is managed. A database cluster like RDS or Redshift also have their own specific method for handling the storage scaling. And this concept of the different scaling behavior is often tested on the certification exam, so please try to remember the distinction between EBS and EFS. First, let me introduce some key metrics and terms commonly used in the disaster recovery. The disaster recovery ensures the business continuity and helps achieve the system-wide fault tolerance and high availability, even in event of the failure in the region or availability zones. The two key metrics related to recovery design are RPO, the recovery point objective, and RTO, the recovery time objective. The RPO refers to the time between the occurrence of the failure and the last backup. In other words, it indicates how much data loss can be tolerated. For example, if backups are taken once every 24 hours, there is a possibility of losing up to 20 hours of data. The RTO refers to the time it takes to restore the operation after a failure. Generally, the shorter the RPO and RTO, the more frequently backups are needed and the faster recovery architecture must be, which can increase the cost. Disaster recovery scenario include the backup and restore, the cold standby, the pilot light, warm standby, a hot standby, the multi-site, and the active configurations. In backup and restore, the data is backed regularly, and in the event of failure, the recovery is attempted from the most recent backup. The backups are typically scheduled on a daily or weekly basis. However, since recovery from backup can take time, and this approach is suitable when longer service downtimes are acceptable. In cold standby, the data is replicated to secondary site, and if a disaster occurs, the operations are switched to the standby environment. In cold standby, the secondary site systems are powered off during the normal operation. In warm standby, a backup system is pre-configured in the standby environment, and in case of failure in the primary environment, the operations are switched over. In both cold and warm standby, the data is asynchronously replicated to standby environment. In hot standby, the same environment is set up at the secondary site, and in case of disaster,
the traffic is redirected to immediately to restore services without downtime. In hot standby, the standby environment is also running at all time, even during the normal operations. As for the backup and the restore, the RPO and RTO get longer and the cost decrease. Conversely, as you move down, RPO and RTO shorten, but the cost tends to increase. I will introduce the AWS services related to disaster recovery. And the first S3 is widely used as a storage for backup data. Additionally, Storage Gateway is used to synchronize and replicate the data between on-premise and AWS. AWS Backup is a service that automates and schedules backups. For cold standby, you can copy an Amazon Machine Image (AMI) of the production environment to EC2 instance template, and in the event of failure, use CloudFormation to build the environment in the secondary side. Let me introduce an example of a backup and restore configuration. Normally, the operation runs in region A, where AMIs, snapshot, and logs are taken as backup. And these backups are replicated in advance to region B. And in the event of failure, the backups stored in region B are restored. And finally, the traffic is redirected to region B. In the backup and restore scenario, since the restoration process starts in region B after a failure occurs, the RPO and RTO tend to be longer. In warm standby scenario, a minimal standby environment is set up at the secondary side. In the event of failure, the standby environment is scaled up to become the new production environment. During the normal operation, the standby runs with the minimal resources, but when promoted to production, auto-scaling can be used to add instances, and Route 53 can be used to switch routing. In a hot standby scenario, the same environment is running at both the production and the secondary side. This allows for seamless failover to secondary environment with no downtime in the event of disaster. A Route 53's DNS failover is used to switch to the secondary side, and the global accelerator can be used to speed up the failover process. In cold standby, the standby environment is only activated after a failure occurs. In warm standby, the primary region, the region A, is on operation during the normal time, while the standby region, the region B, runs with the minimal resources. In hot standby, both the primary and the standby environment are always running with the same configurations. In the event of failure, the traffic is switched to region B, since the standby environment in warm standby is already running. A recovery is faster than in cold standby. And in hot standby, the global accelerator is often used to minimize the downtime during the traffic switch. To further reduce the downtime during the database failover, read replica can be promoted to primary instances, or you can use DynamoDB's global table or Aurora's global database, which are designed for multi-region support. But I will introduce the read replicas and the global tables in more detail in the database chapter. AWS Database Services provide a replication option across the multi-region, which improves the availability and enables faster disaster recovery. The AWS Backup creates and manages resource backups and automates the backup process based on the specified rules. AWS Backup supports services like EC2, database services, and storage services. And you can automate the backups by specifying the rules for frequency, time, and other settings. The backup plan can be defined in JSON format. For example, here is a sample that runs a backup every day at 12 o'clock in the colon syntax. And the start window minutes parameter specifies the window in minutes during which the backup jobs can start. And in this case, it's set to 16 minutes, meaning that backup job will start at any time within 1 hour after the 12 o'clock. The exact start time is automatically determined by AWS. The completion window minutes parameter specifies the time in minutes, allows the backup job to complete, and in this example, it's set to 10,080 minutes. 1 week, meaning the backup job is expected to complete within the 1 week of starting. Let me introduce the AWS Elastic Disaster Recovery. The AWS Elastic Disaster Recovery replicates data from on-premise to the AWS environment or other cloud source services to AWS. In addition to migration, it can also adapt the architecture based on the AWS recommended configuration. The Elastic Disaster Recovery primarily supports server replication. Now I will explain the steps for using the Elastic Disaster Recovery. First, set up an EC2 instance through the console, then install a dedicated engine on the source server to replicate the data to AWS. The replication occurs continuously, and once complete, you can launch the recovery EC2 instance to perform the recovery. If a failure occurs in the on-premise environment, you can perform the recovery and fail back. And finally, let me introduce the definitions of RPO and RTO for disaster recovery architecture. The AWS defines the following number. The backup and the restore typically has the RPO and RTO of several hours. The pilot light aims for the several tens of minutes. The warm standby targets a few minutes, and the multi-site configuration aims for the real-time failover. The definition of RPO and RTO may vary depending on the source, but these are the numbers defined by AWS. Next up is RDS proxy. The RDS proxy is a free-managed, high-available database proxy that makes it easier to scale application by establishing a database connection pool to efficiently manage the connection to databases. The RDS proxy maintains a pool of database connections that can be shared among many application threads. This improves the application scalability by allowing a more efficient use of database connection and reducing the time and the memory overhead associated with opening and closing the connections. The RDS proxy supports IAM and the VPC security group, which also improve security. You can also improve the read performance by caching the result of your queries. And this is an image of RDS proxy. You can configure both the maximum number of connections and the connection timeout setting. If a multiple application attempts to establish connections, the RDS proxy handles these connections, resulting in the high performance and achieve high availability. The overall RDS proxy is designed to efficiently manage the database connections reducing the overhead of frequently opening and closing the connections and managing the connection lifecycle. Let's talk about the lead replicas. A lead replica is an instance that is replicated from the primary instance and is for read-only use. The lead replicas are replicated asynchronously from the primary instance. You can create up to 5 lead replicas with RDS. The lead replicas are primarily used to offload application lead processing. If you perform the write and the read operations simultaneously on the primary instance, the load of the primary instance becomes concentrated. Therefore, you should distribute the load by offloading the read processing to lead replicas. The lead replicas also asynchronously replicate the data from the primary instance, so they can be promoted to the primary instance. You can take advantage of this property and use lead replicas for purposes such as disaster recovery, the migration, and the copying. I will explain some tips for lead replicas. You can create lead replicas in different regions. You can use lead replicas for migrating to another region or for cross-region disaster recovery. A connection endpoint exists for each lead replica. You can focus the connection only on the lead replicas. The constraints for lead replica differs by database engine. For SQL Server, it's currently available only in Enterprise Edition. Also, in the case of SQL Server, it's not possible to create a lead replica in other region or multi-AZ. And for Oracle, it's only available in the Enterprise Edition. You need to use Active Data Guard to use of lead replicas. Also, lead replicas in mount mode cannot be read. In other words, the lead replicas cannot be used for the purpose of distributing the lead load, but only for disaster recovery purposes. The RDS supports automatic backups, the manual snapshot, and point-in-time recovery. For auto backups, it performs backups once a day and retains for up to 35 days. You can also take a manual snapshot up to 100 at any time. The RDS also supports the point-in-time recovery. I will explain more details about backup. The retention period for automatic backup is 0 to 35 days. If you set 0 day, no backup is created. The default setting is 7 days. The first backup is a full backup, and the second and the subsequent backups are differential backups. In other words, only the changes are backed up. The snapshots are stored in S3. The automatic backups are performed once a day. On the contrary, you can take a manual backup at any time. The snapshots are stored in S3, so they can be copied to another region or another account. When copying to another region, the KMS keys, the parameter group, and the option groups will not be copied. The KMS must be configured for permission at the destination region. With AWS Backup, you can specify the time instead of days, and AWS Backup offers migration automation. When restoring the snapshot, a new DB instance will be created. You cannot restore a snapshot to an existing DB instance. The connection endpoints are also newly created, so you will need to configure network settings such as DNS for new endpoint. For point-in-time recovery, the restores are performed using the transaction logs that are stored in S3 every 5 minutes. You can specify a time to perform a point-in-time recovery. The restoring from the point-in-time recovery also creates a new instance. In other words, you cannot restore a snapshot to an existing DB instance too. Next, I will introduce the monitoring of RDS. For OS-level metrics that cannot be got with the CloudWatch standard metrics, you can use extended monitoring. The extended monitoring includes the detailed OS-level metrics. For example, it includes the CPU usage, the memory usage, disk I/O, and so on. And if you want to get metrics on database performance, enable Performance Insight for RDS. The Performance Insight provides visibility into performance at the SQL level. The metrics that can be obtained with the Performance Insight include the SQL wait event and the database load. You can visualize the insight by filtering the specific period of time, so you can see which query affects performance. It can store metrics for 7 days by default and up to 2 years.
The next is TDE, the Transparent Data Encryption. The TDE is an encryption feature built into the database engines like Oracle and SQL Server. It automatically encrypts the database file like the data and logs stored on the disk. It's transparent because your application usually doesn't need code changes. The database handles the encryption and the decryption itself, managing the key internally. In RDS, it is recommended to use KMS. The TDE is available as an optional feature for Oracle and SQL Server. You might use TDE if specific compliance rules require engine-level encryption, or if you are migrating the system already using TDE, or you need a table or column-level encryption, but mainly Oracle. Now please note that not all the native TDE features might be free supported RDS. Using both KMS and encryption and the TDE together can potentially impact the performance and makes management more complex. And for reference, this is the summary of the TDE feature and SQL Server and Oracle. And the SQL Server, the database data file, the transactions, and the temporary database are encrypted. On the other hand, the system database are not encrypted. The table level and the column level encryption are also not supported. The data is encrypted with the database encryption key and protected by the server certificate. The certificate is managed by the RDS, and it can be used by enabling the TDE in the RDS instances option group. In Oracle, you can select not only whole database encryption, but also the table space level or column level encryption. Also, the TDE master key can be protected by a KMS custom managed key. And by doing so, the KMS features such as the key policy and automatic rotation can be used. Using the conventional Oracle wallet is also possible. The next is the encryption in transit, protecting the client RDS network traffic using the SSL and TLS. Your client application must enable SSL TLS for the connection. For best security, it's also recommended to validate the RDS server certificate, and you do this by downloading the AWS Root CA certificate bundle and configuring your client application to trust it. The AWS updates these CA certificate over time, so keep your client bundle updated. As the table shown here, the newer CA certificate lasts much longer than older ones. The Amazon Aurora is a free managed relational database engine. It's compatible with MySQL and PostgreSQL, providing higher performance and availability at much lower cost. The Aurora is designed to be optimized for cloud environment and highly durable and fault-tolerant. Automatically replicating data across the multiple availability zones and continuously backing up data to Amazon S3. The Amazon Aurora has similar features as Amazon RDS, since they both are relational database,
but Aurora provides some unique features. From next pages, I'm going to introduce them. And I will introduce the architecture of Aurora. For Aurora, you can manage your instance and the storage separately. You can scale computing and storage independently. The data volume are stored in 3 availability zones, 2 in each, for a total of 6, and this ensures the data redundancy. Aurora follows a quorum model, which means that only 4 out of 6 write operations and 3 out of 6 read operations will succeed. In other words, if 2 out of 6 write operations fail, the 4 successful data volume complements each other to preserve the data. In Aurora, a read and write instances is called a primary instance, and a read-only instance is called a replica. You can create up to 15 read replicas. The volume on which Aurora data is stored is called a cluster volume. The cluster volume are replicated to 3 AZs for redundancy. The unit of primary instance, replicas, and volume is called a cluster. The Aurora has endpoints for primary instance, replica, and you can set the custom endpoint. To distribute the read load, for example, when connecting to the BI tool, you had better to use the endpoint for replicas. I will explain the Aurora availability and failover. In the event of failover of the primary instances, the replica will be promoted to primary instance. In most cases, the recovery is in less than 60 seconds. In other words, in some cases, recovery may exceed 60 seconds. Recovery within the 60 seconds is best effort. If connected to a cluster endpoint, the endpoint is automatically switched during the failover, so you don't need to switch endpoint. If there are multiple replicas, you can assign recovery priority. If no priority is set or the priority is the same, the replica with the larger size will be promoted. If the new instance doesn't have the sufficient computing power and memory, the replica with sufficient capacity will be chosen because it will not be processed properly. This concept of the recovery priority is often shown up in the exam test. Normally, during the failover, there is a downtime before recovery. Then the cluster cache comes in. By enabling the cluster cache, the cache is synchronized to the replicas, reducing the downtime during the failover. The recovery time is often less than 60 seconds for Aurora, compared to 16 to 120 seconds for RDS, and less than 120 seconds for SLO. Now I will introduce the Aurora global database. The global database consists of the database across the multiple regions. You can have the one primary region and up to 5 secondary regions. The replication and the failover between regions usually take less than 60 seconds. The global database is designed to route application requests to the region with the lowest latency. This means that when applications access the database from various global locations, they automatically connect to the nearest region in terms of the network latency. The global database enhances the fault tolerance by distributing the database across the multiple geographic regions. A similar feature to the global database is cross-region replication. With cross-region replication, you create a read-only cluster in other regions. The cross-region replication often has the higher latency compared to global databases, and it's useful for offloading, backups, and the geographical proximity. Additionally, the Aurora offers the capability of multi-master cluster, which means you can have the multiple writable master instances. In the multi-master cluster, you can have up to 2 writable instances. The multi-master cluster are only supported with the MySQL. The multi-master may experience a lower performance compared to standard single master clusters, especially when ensuring the right consistency across the geographically distinct instances. In addition, you can't enable a backtrack feature for multi-master. As for backups, Aurora offers more extensive backup capabilities than RDS. You can use the automatic backup for both RDS and Aurora. The Aurora provides a continuous backup, whereas RDS provides daily backup. The point-in-time recovery is a feature that you can recover a database at any time within 5 minutes. And you can also clone your database instance, which copies the instance portion. And with Backtrack, you can rewind the database to any time within the 72 hours. The Backtrack is a feature to quickly move an Aurora database to a previous point in time without needing to restore data from the backup. With Backtrack, you can recover your database for up to 72 hours. With Backtrack, you don't have to recreate the database, and the recovery time is shorter than with backup. To backtrack a database, you may experience a temporary stop processing the database. The backtrack is supported for MySQL-compatible Aurora. It's useful for development and testing environment where changes are frequent and the potential for error is high. And it's also useful in the production for minimizing the downtime in case of errors. The Amazon DynamoDB is a free managed key-value database. Like RDS and Aurora, it's one of the most popular database services by AWS. The DynamoDB is a NoSQL database that stores data as key-value pairs. The key-value database has a simple structure with keys and value of the same nature, which generally allows for the faster processing compared to relational databases. In DynamoDB, each item has a key and attribute. The key consists of the partition key and optionally a sort key. The data is distributed based on the partition key, and the items are ordered with the sort key. The attributes are fields that contain the data for the item. The DynamoDB is used in the wide range of use cases, such as content management, catalog, and user profile management. I will explain the future of DynamoDB. Since it is serverless, you don't need to manage servers, apply patches, or configure scaling. The DynamoDB has excellent scalability. When creating a table or indexes, you can specify the throughput to ensure enough resources for the stable operation. Additionally, you can adjust the disk capacity for storing the data, and storage is unlimited. Although it's NoSQL, but you can use the SQL-like query language called Particle to perform operations. And it also automatically stores data across the 3 availability zones, ensuring the high availability. The DynamoDB streams is a function which captures a time-ordered sequence of the item-level changes in DynamoDB table. It stores changes for 24 hours. It captures records of changes to items, the insert, update, and delete. The DynamoDB streams include the record and shard ID. Then you can use the streams to replicate the item-level data from one table to another across AWS region. You can also analyze the data changes and feed them into other systems such as Amazon Redshift or AWS Lambda. With AWS Lambda, take some action in response to the streams in your table. With DynamoDB streams enabled, you can use global table. The DynamoDB Accelerator, or simply DAX, is a free managed in-memory cache strategy. It's designed to improve the read-intensive performance, offering the microsecond response time for accessing your data. The DAX offers an in-memory caching, which keeps frequently accessed data in RAM, making it unnecessary to access the original table. And DAX take the write-through strategy. When you write to the table, the DAX writes both to the cache and to the DynamoDB. I will explain the behavior of DAX. For request from the application, if there is a cache in the cache layer, the response is returned from the cache. On the other hand, if there is no cache in the cache layer, the request is forwarded to DynamoDB table. And you can set the time to live for the cache. The default is 5 minutes, and therefore you may not get the latest data of the original table. And if you request with the strong consistent read, the response is directly returned from the original table, not the DAX. When you send the write request, the request writes to both the cache and the DynamoDB table, and this is called write-through. If both writes succeed, a success response is returned. The DynamoDB's backups include on-demand backup and point-in-time recovery. The on-demand backups are full backups performed at any time manually. Regardless of its size, it can be restored in seconds, so there is no performance impact. The backups remain until you explicitly delete them. The backup is saved even if the original table is deleted. The point-in-time recovery enables the continuous backup of your table, which provides the granular recovery from accidental operations. It can be saved for up to 35 days. You can retrieve and restore the transaction logs every 5 minutes. Therefore, the point in time that can be restored is from the 35 days to 5 minutes ago. The point-in-time recovery is reset once it is disabled. For both on-demand backup and point-in-time recovery, the new tables are created when you restore. In other words, you cannot restore to existing table. When restoring, you can configure secondary indexes, capacity mode, capacity unit, and encryption. Conversely, auto-scaling, the IAM policy, CloudWatch, the tags, the stream setting, and the TTL will need to be reconfigured after restoration if necessary. For DynamoDB security, like any other database service, it includes the IAM access control, encryption, and network isolation. And here I will introduce the things specific to the DynamoDB. The DynamoDB allows access control using the IAM. You can control access not only for table, but also indexes and the DynamoDB stream with unique ID. And this is an example of IAM policy allowing action on the DynamoDB table. And usually, the actions on the DynamoDB tables are executed through the APIs. You can control access to the DynamoDB by IAM policy. At the rate of 2023,
The DynamoDB now supports the resource-based policy. Previously, the access control for DynamoDB primarily used the identity-based IAM policy, but now you can also use the resource-based policy attached directly to your DynamoDB tables. And this means when receiving the request from the multiple accounts, you can control access directly in the table's policy by specifying the allowed principal. The DynamoDB often integrates with services like SQS and Lambda as part of the serverless architecture. Using the resource-based policy, it gives you more flexibility and a simpler option for managing the cross-account access control scenario involving your DynamoDB table. For private network connectivity to DynamoDB from within your VPC, you can use the Gateway VPC Endpoint. The Gateway endpoints are available for S3 and the DynamoDB. And here is a summary of the differences between the interface endpoint and the gateway endpoint. The gateway endpoint works by modifying the VPC route table. You add a route that directs traffic designated for the service to the gateway endpoint resource. And you can manage the DynamoDB with one endpoint, and which simplifies the configuration. Next is management and security governance. Here, I will focus on the AWS Organizations and the other organizational governance tools. The AWS Organization is a service that helps you manage the multiple accounts in the hierarchical structure. With AWS Organizations, you can create the organizational units OUs to group and manage the individual AWS accounts. While you can manage the account permission using the IAM, managing the accounts at the organization level can be challenging. In large organizations especially, where there are lots of employees, creating the individual account and managing the policy for each person requires significant effort. But with AWS Organizations, you can centrally manage the policy across your entire organizations, which allows you to set guardrails across the multiple accounts. With AWS Organizations, you can use the consolidated billing, with which you can manage the billing centrally by the organizational unit. And normally, the AWS bills each account, but with consolidated billing, you can handle it all at the organization level. In addition, you can share quotas and discount across your account with it. A quota is basically a limit on how much on the resources you can use. With AWS Organizations, you can share these quotas with other accounts in your organizations. And you can also share free usage and discount like the reserved instances and the saving plans within your organizations. The SCP, or the Service Control Policy, is a type of policy in AWS Organizations that you can attach to the organization root and the organization unit or individual account. By attaching the SCP, you can centrally control the maximum permission allowed for IAM principle in the account under the root OU or for the specific account. For example, if you want to forbid the use of the specific service or action across your entire organizations, you can set a deny rule in the SCP attached to the root. And this action will then be blocked in all accounts, regardless of what their individual IAM policy might allow. The effects of SCP are applied hierarchically. The final permission boundary set by SCP for an account is determined by the combination of the SCP attached for the organization root down through any parent OU to specific account. And it's important to remember that allow statements in SCP are generally not used to grant permission directly like IAM Policy do. The SCP acts as a guardrail. Their main purpose is to define the maximum boundary of what action can be allowed within the affected account. The actual permission must still be granted using the IAM identity-based or resource-based policy. And I will explain a specific example of SCP usage. For example, regarding the EC2, if an organization wants to prohibit the use of the specific instance type or uniformly restrict the instance's launches under certain conditions, the SCP can be effective tools. Let's say that the organization-wide account have an IAM policy that allows the launching the EC2 instances. And the SCP has the default full AWS access permission policy configured. On the other hand, an SCP that denies the launching of the specific EC2 instances is configured at the organization unit level. And here is a sample of the SCP described in JSON. On the left side is the IAM policy that grant permission to launch the EC2 across the entire organizations. On the right side is the SCP that denies the launching of specific EC2 instances. And here the condition field denies the launching of the M5.large instance type. And you can see the effect section contains a denied, which signifies the rejections. In other words, the organizational units will be able to launch EC2 instances other than M5.large. I will introduce the deny list strategy for SCPs. When you create an organization and enable the SCP for the first time, an SCP called the full AWS access is attached by default, and this allows all action and all resources. While keeping the default full AWS access policy attached, you explicitly deny specific services or actions that the organization wants to prohibit. The SCP denied statements are powerful. Even if an action is allowed by the IAM policy within the account, if it is denied by SCP, the action cannot be performed. And this functions as the guardrail for the entire organizations. On the other hand, you can also detach the full AWS access policy and configure explicit permissions. And when you detach the full AWS access policy, all actions are implicitly denied. And generally, the deny list is the intended use case for the SCP. The purpose of SCP is to set the upper bounds on the permission at the organization and the organizational unit level. The AWS organization is often used alongside other services. So let me give you some example. The AWS provides the infrastructure as a code, or IAC, which lets you define the infrastructure using code. The CloudFormation is a popular IAC service. By combining the AWS organizations with CloudFormation, you can create stacks across the multiple regions and multiple AWS accounts, which minimizes the management overhead because you don't need to set up the IAM role to each user individually. I will introduce the CloudFormation in another chapter. When you use the AWS organization, you can centrally collect the API calls from the all accounts within an organization using the CloudTrail feature called the Organization Trail. The Organization Trail logs are automatically delivered to the designated S3 bucket. And typically, in large organizations, It recommends to centrally manage the logs in the log archive account managed by the security teams. When the outputting to the S3 bucket, the file path of the log file includes the organization ID and the ID of the member account that generates the logs by default. Next, I will introduce AWS Control Tower. You can use AWS Control Tower with AWS Organization to deploy a landing zone. A landing zone is a solution for setting up the governing the multi-account environment. As your company grows, the management and the governance of the multiple accounts becomes more complex. The AWS Control Tower helps by automatically setting up the multi-account environment. It includes the configuration for accounts, the organizational unit, IAM, networking, security, logging, compliance, and governance. In this context, a landing zone is a blueprint for the initial configuration of your environment. The term landing zone originally referred to the helicopter landing area. Similarly, in the cloud industry, a landing zone is used to describe the initial design of the safe and secure environment setup. And here is an overview of the Control Tower. The Control Tower allows you to set up the organization structure in the AWS Organizations. For example, this landing zone has OUs for the log archiving, the auditing, and the development. The log archiving unit has access to the CloudTrail and the Config. The CloudTrail is a service that provides a trail of account activity, and the Config is a service that tracks the history of the resource changes. In other words, the log archiving the account is dedicated to the managing logs accounts and the resource activity. Conversely, no other operations are allowed by policy. Similarly, the OUs for auditing and the development can only operate on security-related service and the network services, and respectively. The AWS and the other IT industry in general recommends the principle of the least privilege, meaning that only the minimum necessary permission should be granted. With AWS Control Tower, you can manage your organization's security policy and the governance by setting up the account rule in advance. Next up is the AWS Service Catalog. The Service Catalog is a service that provides a centralized control over the creation and the management of the AWS resources. And this improves the IT governance and the compliance, and it can also standardize the resource usage across the organizations. The Service Catalog allows you to create a catalog of the product and enable authorized user to deploy them. Here, the product refers to the collection of the AWS resources defined in the CloudFormation template. And for example, you might have a simple template that sets up S3 bucket. The administrator creates this template, and the end user deploys the resources based on it. The actual template typically includes more detailed information such as an IAM policy, regions, and network settings. The end user can only deploy resources they are authorized to, providing the governance and the control of the organizations. And this is the workflow for the administrator, as described in the official AWS document. The administrator defines a catalog which includes the portfolio and the product. A portfolio is a collection of the multiple products. The administrator can specify the parameters such as the activation settings, the permission, the notification method, and the regions. By associating these catalogs with users and accounts in AWS organizations, the users can deploy AWS resources based on the specified template.
The AWS Service Catalog also supports the version control. On the other hand, here is the workflow for the user side. The user can deploy AWS resources based on the product assigned to them and manage those resources. And behind the Service Catalog, the CloudFormation templates are used, allowing the resources to be launched by specifying the resources and the parameters defined in the template. For example, you can specify the type of EC2 instance, the region where it will be deployed, and other parameters. Next, let's introduce AWS Resource Access Manager, LAM. LAM is a service that allows AWS resources to be shared across the different AWS accounts or within the AWS organizations, and this eliminates the need to create and manage resources separately for each account. When using the LAM to share resources between accounts, the resource owner simply invite other accounts to access the shared resources. And you can share resources from the management console with just a few simple steps. Currently, LAM also supports the global resource sharing. The LAM supports sharing many resources, however, you cannot share all AWS resources, specifically the many security-related resources that contain sensitive information or require individual access control are not supported for sharing via the LAM. For example, you cannot share Secret Manager and the KMS because they contain sensitive data. The IAM resources, GuardDuty, the Security Hub also cannot be shared, while VPC component can be shared, WAF cannot. The resources shareable with the LAM have been updated and changed in the past, so please refer to the document for the latest information. Next is the CloudFormations. The AWS CloudFormation is the infrastructure as a code service. The IAC allows you to define the infrastructure configuration as code. For example, to start an EC2 instance from the console, it requires the manual steps in your browser. And if you need to launch the multiple servers, it takes a lot of time and effort. Additionally, if you want to launch a server in a different environment with the same settings as an existing one, it's more convenient to document the configurations. The IAC offers the benefits in terms of the reproducibility. With CloudFormation, you can describe the resource configuration in the template using the JSON or YAML. For example, here is the sample template for creating an EC2 instance. So let me introduce the components of the CloudFormation. The CloudFormation consists of the template, the stacks, and the target resources to be deployed. A template is a JSON or YAML file that describes the resource specs and the configurations. And from this template, a unit called a stack is created, and which is responsible for actually creating, modifying, and deleting the resources. A stack can include the multiple resources. For example, when you create an EC2 instances, you can include the network, load balancer, and the autoscaling in the stack. And you can also use the stack set with the AWS Organizations, allowing you to create, modify, and delete stacks across the multiple accounts, and which is particularly useful in the collaborative deployment. The stacks can also have the parent-child hierarchy. Starting on the next page, I will introduce each component. First off, I'm going to introduce the template. And this is an example of the YAML template. In the resources sections, you define the configuration of the AWS resources. And in this example,
an EC2 instance and the VPC are included. In the parameter sections, define the values that will be used when the template is executed. For example, you can specify the machine types of the EC2 instance. And in the mapping sections, define the details like the region where the resources will be deployed. The next one is the change set. The change set offers a preview of features that you can understand the impact on the resources before executions. You can understand the changes on resources before actually executions. And here is the flow for change set. You can either create a new template or directly edit an existing one and preview the impacts of the environment. And if everything looks good, execute the deployment. But if there are the issues, modify the template before the deployment. The next one is the drift detections. The drift detection is the feature that identifies the differences between the template and the actual resources. It is useful in seeing what changes have been made to resources after they've been created by CloudFormation and then manually modified. And you can perform the drift detection from the console or the CLI. Additionally, you can work with the AWS Config to set up the management rules that automatically run the drift detection as part of the config rule. And this allows you to configure notification and corrective actions if any differences are detected during the drift detections. And here is an image of the drift detections. The actual state of the resources is shown alongside the expected values. The blue highlights indicates the differences, the red highlights indicates the deletions, and the green highlights indicates the additions. And this way, you can understand what differences there are between the template and the deployment. And next I will explain the error handling. If the error happened during the deployment, you must stop the deployment, and the system needs to be restored to its original state, and this process is called rollback. The CloudFormation monitors the status of the stack creation, and it can take action if there is an issue. And you can also set up the CloudWatch alarm for each rollback trigger you create. To handle the failure, you can retry the deployment, update the template, or rollback the process. The retry is the process to retry the deployment again without changing the template. The retry is useful when the cause of the failure is not about the template issue, such as an access right, the networking problem, or dependency issues. After resolving the problem, and then retry from the point of failure. An update is to fix the template before retrying to create the stack. It restarts from the last point of failure, and rollback is the process to restore the stack to its last known good state. Next, I'm going to introduce the policies you can configure in the CloudFormation. A stack policy is a policy that controls resources within the stack during the update, and it helps prevent the unintentional update by allowing or denying the specific actions. When the stack policy is set, all resources are protected by default. If certain action needs to be permitted, they must be explicitly allowed. The example here shows a policy that prohibits the updates to the database. By default, all actions are denied, so the first statement allows the updates to all resources. the second statement specifically prohibits updates to the database. Next, the CloudFormation guard statically validates whether your CloudFormation template complies with the organizational security policy, the compliance requirement, and the best practice before you deploy the infrastructure. The first, you define the guard rules. In guard rules, you describe the policy rules you want to validate using the dedicated language. Next, you use the validation commands to check if the template complies with the rules. By integrating the CloudFormation guard into your CI/CD pipeline, you can automatically block the deployment of the template that violates your policy. The next one is AWS Trusted Advisor. The AWS Trusted Advisor analyzes your architecture and provides the recommendations based on the AWS best practice. It offers guidance in the area of the cost optimization, the performance, the security, the fault tolerance, and the service quotas, and which are key pillars of the well-architected framework. And here is an example of the recommendation provided by the Trusted Advisor. For example, under the cost optimization, you might receive the suggestion on the EC2 pricing plans, the identification of the underutilized instances, and the detection of the unassociated IP addresses. The security category of the Trusted Advisor aims to identify the gap and the risks in the basic security settings in your environment. Here is an example of the main checks provided by the security category. In reality, dozens of the rules are provided. Please refer to the document of the details. And here are some important notes when using the Trusted Advisor. The checks provided by the Trusted Advisor are recommendations based solely on the AWS best practice. You cannot add or edit user-specific custom rules. Therefore, if you have a unique security requirement, you need to integrate with other detection services. The Trusted Advisor is used to complement other security services. The scope varies depending on your support plans, and if you have the business or enterprise support subscriptions, you can obtain the comprehensive recommendations. On the other hand, with basic and developer support, only some items are checked. The Trusted Advisor findings can be integrated with the Security Hub. And here I introduced the well-architected framework, which serves as the fundamental design philosophy for AWS. The well-architected framework provides a set of best practice and guidelines for using AWS. It is built around the pillars of the operational excellence, security, reliability, the performance efficiency, the cost optimization, and sustainability. And this framework is essential for the effective development and operation of the AWS architecture. Next, I'm going to introduce practice questions. And if you want to tackle more practice questions, and we have prepared the practical question collections. And this includes the collection of the questions and the explanation designed to simulate the actual security specialty exam. The explanation includes not only the answer to the question, but also the supplementary information such as the sample code and the implementation steps. I think the explanations alone have the considerable amount of the content, and the instructor's coupon can be issued, so please send a direct message on the comment if you need one, and we can issue it at any time. In Chapter 4, the summary of this course, I will introduce the pricing calculator, the partner network, the support plan, and the marketplace. The AWS pricing calculator is a tool to help you estimate your cost. You can input your resource usage, such as the number of EC2 instances, and the calculator will provide a detailed breakdown. And you can estimate cost, the save and the shared estimate, and get recommendations. And for your reference, the image shows the pricing trends for EC2 and S3. The prices of the cloud have been going down over the years. Because of the competition between the cloud provider and the improvement in technology, and these prices are expected to keep dropping. The prices and the services from all cloud providers change often, so it's important to stay updated. Next, AWS Partner Network, or APN, is a global program whose purpose is to identify the AWS partner who can assist clients. The APN consists of the two types: the consulting partners that help clients design, the architect, the build, the migrate, and manage their workload on AWS. The technology partner is independent software vendors that develop and offer software solutions optimized for AWS. They provide the services such as the SDK, API, and other tools to assist in the integration of the client's application with AWS services. The partners in the APN can get benefits including the training and the certification program, and the marketing and the sales support, and the technical support, and access to the AWS resources. And this is a list of AWS support plans. By choosing a pet plan, you can receive more comprehensive support. The farther to the right you go, the more extensive support becomes, including the technical support from the terms and the faster response time. And the AWS Repost is a Q&A community where the members can post questions, and the members of the community provide the answer. With AWS Marketplace, you can purchase the software and the services from the third-party vendors, and you can utilize the marketplace to discover the solutions tailored to your specific needs. For example, in EC2, you can purchase the machine images with the software from the third-party vendors. And here are the optional learning resources. While I've covered what's on the exam, I recommend for you to check the official document. The AWS also has a training site called the Skill Builder with sample questions. The AWS announces new services at the event like re:Invent and the AWS Summit. If you use the AWS often for work, it's good to attend these events. And thank you for staying with me throughout this course. I also offer courses on the AWS, the Google Cloud, and Microsoft Azure. So please stay tuned as I will expand my offering in the future.